I did just edit them again, I think, actually, because
Okay.
textual and visual descriptions were. Oh, you got it.
Oh.
Since I looked last.
Is this a?
This looks like a merge.
Is this a merge pack?
Yeah, cool.
So these are the ones that I
Those are great. Yeah.
Do we know?
There are 3 sessions. You shouldn't do the first one.
Well, in that case, there's 4 sessions.
Testing.
We hear you. 8:45. Okay, we got 15 minutes. Let's go find a second. A little nervous about fitting everything in, so forgive us for starting punctually. Can I get the slides from my laptop up on screen here? Do you want to join, Jeffrey? Where's Josh? There he is. That is my email. Ron, can we do the other one? Here. Cool. Let me just unplug that for a sec. Arrange multiple displays. Oh, yes. Thank you, Apple. The system used to be so fast.
I think you got to plug in the display.
We'll try again. All right. Yeah. Come on. There we go.
Yeah. I think it's not an override. You just drag this window over.
Yeah, you hold the Option key down. There we go. All right. It's that famous intuitive Apple user experience. Yes. All right. There we go. Welcome to the 10th workshop on live programming. We're your hosts. I'm Peter Van Hardenberg. This is Jeffrey Litt. That's Josh Horowitz. Thanks for coming. Thank you all for your submissions. I think about half the people in this room submitted, so thanks. This is the standard definitions. Josh is going to get into a longer definition in a little while, and I'm sure Jonathan will talk about this too. But this is what's on the webpage. What is live programming? Live, structured, tangible, and concrete. If you would like me to read the slide out loud, you're going to be out of luck. And this is the 10th year now of the live workshop. This is the third one I've been involved with. Has anyone been here for all 10? Not even you, Jonathan? No? You missed the first one. Who's been here for 9 of these? All right, we got one. So Jonathan's going to be giving our keynote in a few minutes. This is a workshop for those of you who are not presenting or this is your first time here. There's a real emphasis on like real working systems, on novel environments, and that history has been going on for more than a decade now because there were a couple of years missed. Started in 2013, and we've been at Splash since 2017, and it's always been an interdisciplinary thing. There's programming language people, there's HCI people, so many things. So yes, thank you for being here. Here's our schedule for the day. Okay, we're going to have the opening, we're going to have our keynote and some sort of meta discussion about what live programming is. Then we're going to go into our visual systems block, which will be people who are live programming with pictures. Then we're going to go into a textual systems block, which is live programming with textual code. And then we have a third block called substrates, which is live programming with different underlying models. And yes, these categories are arbitrary, and actually we just needed to fit everything into 3 blocks, but we tried to create some thematic consistency. And then at the end, we're going to have presentations, and at the end of each one, rather than having a Q&A after each session, please kind of hang on to your questions, but we're going to get all the speakers from each block to come up together, and that way we can have maybe a bit more of a moderated discussion. We can have several speakers answer the same questions and those kinds of things. Hopefully we can generate some interesting conversation. Logistics. Who's in this? Is everybody in the Splash Discord? Okay, well, if you join the Splash Discord, there are threads there. Every talk, separate from the coordination Discord we made for speakers, the Splash Discord has a thread for live, and each session has a thread there. If you want to ask the speaker questions about their talk that you can't get to during the discussion block, or you just want to ask questions generally or offer links or whatever, put them there. And so speakers, if you could just make sure you check in on that at some point so that people aren't asking questions and left in the cold. We are streaming live on YouTube already. I don't have the link. I couldn't get into Twitter this morning, but it's on the Discord now. And so if you want other people to be able to see this, you can do that. We have 2 remote presenters. They're going to be in the second block today after the first coffee break. And we will see you on screen via Discord. There won't be a video feed from the room. I didn't update the slide. Apologies. And yeah, I mentioned that we're going to invite speakers on stage. And yeah, everybody here is a weird live programming person, or at least interested in weird live programming. And so, like, share what you've got, ask questions, ask if you can see what they've been working on, share your work. We're all here to see each other's work. Jeffrey here has a 3-minute, 1-minute sign. He'll be sitting in the front row. And Josh here has volunteered to be the Reaper.
Like, really ruthless.
Yeah, so
Unforgiving.
if you run long, he will come for you. And when he comes, your time will be over. All right, and that's it from me. So I want to welcome Jonathan Edwards to the stage for his keynote, The Meaning of Live.
Okay. Hello. Oh, thank you, Peter, Jeffrey, and Josh, for inviting me. This, as Peter said, is the 10th anniversary of Live, and really the only reason I'm standing up here in front of you is that I'm the guy that has just decided to keep this thing going. So every year I find somebody to bug to, lead this. And I want to thank all these people that I've bugged into doing it, particularly the people here today. So, you're counting, is it 10? Yeah. And the moral of the story is just show up, right? Makes progress. So, we actually are all grown up now. We have a steering committee with, some general people on it, as well as the last 3 years or whatever of program chairs. But when we were getting started, we had a lot of arguments for the first few years about, is Live really the right name for this place? And in fact, in Peter's slide there, it was live and structured and tangible and something, right? So it's kind of like a bundle of stuff. So we were always, it's concrete, tangible, direct. It's a software medium. Nowadays, there's this word substrate floating around that we might have chosen. So there's always been a little bit of a schizophrenia about what it is we do here. We've also, some of our alumni have gone on, some of these people, Scott Kovach and Jeffrey Litt and Joshua Horowitz, who are our co-chairs this year, all, I think, did your first published work here and then went on to grad school. So that's a win. I think that's great. We're actually creating researchers doing really great work. So that's why I feel this is a really good thing to keep going. We've also had some wins. I mean, we've moved the needle a little bit, maybe. I mean, you see like these learning playgrounds now. There's very much live programming going on in these playgrounds. I think inspired by Brett Victor, but also this whole community. Hot reloading has become an important checklist item for software development environments these days. But is that it? I can't think of much more. Shout out if you can think of it. And so that makes me ask, why aren't we having more of an impact here? What's holding us back? And so if I put up, what it says on the call, that Live is about immediacy, usability, and learnability. I didn't see that slide that Peter put up with the tangibility, but it's the same stuff, right? And I think we have to face reality here. The reality is that, this is what programming really is. For most people, this is the mainstream dominant form of programming, which is a giant stack of specialized technologies. And each of these levels has many choices that you can use. And all of them have just hundreds or thousands of person years invested in them. It's just an incredible capital investment of human capital and also money capital into building this thing. And it's just really hard to make this giant stack of things that have all been cobbled together, right, into something that's immediate and usable and learnable, right? That the stack evolves by viral adoption, right? No one designed it, right? The old worse is better slogan. Viral evolution, I don't think, is going to lead us to immediacy, usability, or learnability. In fact, I believe the stack is a virus. It's inimical to humane programming. It is a virus. That's how it has evolved, and it's inhumane. So what should we do? Do we give up? Is it just impractical? And many of us just say, well, no, we can do it because we've seen it before, right? We've seen all these things. We've seen immediacy, usability, and learnability. So Smalltalk itself, Smalltalk invented sort of half of programming, right? And together they pioneered really direct manipulation and liveness and malleability. These are touchstones that we go back and look to. We're saying we're sort of trying to revive the golden age, right? They're kind of a golden age. There was HyperCard that was really usable and learnable by lots of millions of people. This very cute system, Boxer, which is really not very well known, but was really nice and elegant. It's basically Lisp where the parentheses are boxes on a canvas. And it was used for teaching physics to school children, and it's very, very cute. It's nice. So all of these golden age programming systems didn't look like a stack. They looked like this. They were a conceptually unified platform. And this is what I define as a substrate. A substrate is a persistent code and data store. There's a direct manipulation UI on that state. There's live programming within that state. And programming and using become the ends of a spectrum. There isn't a development time and a runtime. It's all just, you're in this world. And you can switch from being a user to a programmer and back again. And the most important thing is that it's conceptually unified. It's not a stack, right? There's one kind of data. There's one kind of if statement, right? How many if statements do we need in the stack, right? How many syntaxes are there for an if statement in that stack that you all have to deal with? It's crazy, right? So people, old guys like me have been whining about this. Smalltalk was great. We invented everything back in the 80s, blah, 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 right? And I think we just need to stop whining about this, right? And we need to understand why we lost. Because we were definitively beaten, right? The stack definitively beat substrates in the 90s. It just had what people wanted, right? And so what do they want? And how can we beat that? We have to understand why we lost. And then we have to invent new substrates, right, that can beat the stack, but that can beat the stack on the battlefield of our choosing, right? You don't win a guerrilla insurgency by a frontal attack, right? We need to be smarter than that. So, and I think we can learn by thinking about what else has beaten the stack, right? So I've used this slide for a while. I conjecture there is a power law of software complexity, that basically there are exponentially more simple programs than complex ones, right? There's just lots of simple problems out there and fewer complex ones. But when we look, when we actually observe software in the field, there's a big gap in this distribution. And this is the gap between spreadsheets and stack programming, because you would never hire a programmer to build a spreadsheet for you in Python or whatever, right? It's crazy, right? But there's things you can't do with spreadsheets, and it's just not worth learning how to program to solve these little problems that just barely don't fit into spreadsheets, right? So it has to get to be a big, important problem before it's worth getting into all the stack. So this gap, that's the battleground. That's where we might be able to win. This is also the gap where so-called no-code and low-code products have been trying to fill in. And basically, the strategy there is to template the stack, right? Say, you know, it's usually what we're building is CRUD apps. They're really, really kind of, when you squint, they're all the same, right? So let's template that so that you can just generate them quickly. Well, that doesn't really work in practice. And that's another long story that I'd be happy to tell another time. But so in any case, in practice, these have not succeeded, right? They just have not stuck. They come and they go. I say what we want to do is we want to fill in this gap by generalizing spreadsheets into substrates that are more powerful than spreadsheets, are more general than spreadsheets, but keeping their benefits, right? Keeping what makes spreadsheets win, right? Substrates are just a design philosophy, sort of an implementation approach, right? Let's think about what it is that spreadsheets can do that we should also do to beat the stack in the gap. So I propose to call this data-first software. I'm just throwing this out for comment. What we want to do is have, it's like a spreadsheet, but for more general data models, right? We have to escape the grid. You know, a grid of cells just doesn't work for everything. And the real benefit here is to disintermediate the user's data. I mean, another way of putting this is, it's the data stupid, right? That's what really matters to the user. And they don't want to have to deal with code, and especially coders, right? That's what a spreadsheet is. It's just data right there in front of you, right? And so while we're at it, I think we should also add version control on that data, which would be a real killer feature, to have real usable version control that end users could use. They really need it, and they don't have it. Like a spreadsheet, code is metadata. It's secondary. It's behind or above, in some sense, the actual data. And the goal is that it should be small and readable and hackable, right? Which is like formulas in spreadsheets, but also like view source in the old web, right? Which was really the great thing about the old web, was that's how many people learned to program. They just did view source on a web page and then copied it. And that's how you get malleability, right? And we have to still interop with that legacy stack, but we can exploit the legacy stack because of all these microservices, right? You know, my slogan is HTTP is the new FFIs, the new foreign function interface, right? That's all we need to do. JSON, HTTP is all you need to interact with the stack now. And while we're at it, another, plus feature is this still on? No. This suddenly went off. Hello? 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 Oh, now it's, did I accidentally hit the button? All right, is that better? Am I fading out? Can everybody hear me? All right, I'm good. All right. So data for software, right? So where am I here? So code is metadata. Oh yeah, trustworthy source-only supply chain management, right? This is a big problem in the stack, right? It's just, you got all these executables, you got build scripts. Who knows what's in this junk that you're downloading into your NPM modules, right? In a simpler world, maybe we can have a better solution to this, and I think it should be source only, right? Executables are a performance optimization for rebuilding. Did I just died again? I think the battery on this is going.
Use the podium.
Oh, there it's on again. Hello? All right. So anyway, sorry. Trustworthy supply chain management, and maybe being source only, maybe being a simple substrate gives us tools, simplifies the problem enough to do better than the stack has done. And finally, there's this idea of an application as a, application as a document. A number of people have been talking about this. And the way I put it is that we have to reify actions that are opaque into visible state that the user sees, right? So it's their data. And I mean, one example of this is that a submittable form is really just a view of a request log, right? So show them the request log. The form is just a shortcut for interacting with the data recorded in a request log. This is kind of, you know, I'm getting a little speculative here. I've been beating on this idea for a while, and it's hard, but I think it's an interesting direction to go in. And speaking of which, so all of these features of data-first software tell us that there's some problems we should be working on. So this is a software research agenda here. So alternative UI metaphors, right? Documents, outlines, canvases, graphs. Let's let 1,000 flowers bloom. Let's try other approaches to what a substrate should look like. Certainly, we need to go beyond the grid of a spreadsheet. Database sufficiency. You know, databases are really useful things, and we shouldn't be ignoring their features, right? We should have a minimal set of features that match what databases do for application builders. Types and schema changes is one of my personal hobby horses. I think we should think about, we definitely need to think about schema change. This has been a problem from the beginning. Like, I was actually tried to deliver customer software in Smalltalk images, and it's a pain in the ass, right? When your software changes. So we can improve upon the past here. I already mentioned this, end user version control of data. That is a big open problem. I mean, we want to have multiplayer collab, but we also want to have async version control like we have for our source code these days. Again, the supply chain management, I think it's a big festering wound in the stack currently. Modularity, malleability, hey, I mean, we love that stuff, right? Lots of places we can go for ideas there. When you have a simpler substrate, right, everything is going to just naturally fit together better because there's less variety in the sorts of things you have. And again, this idea of app as a WYSIWYG doc, and we need things like updatable views and reified execution. So I'm just throwing these out as things I think you should be thinking about and coming back next year with some work. And finally, the most important feature is, you know, we have to worry about big data, big code, performance, and scalability. And this is the most important feature because we have to not work on it, right? These lead to the dark side. These lead back to the stack, right? That's not the battlefield that we want to choose, right? So, and this is, at least for me personally, has been a struggle because I just love to think about performance. I mean, it's just such a wonderful thing to think about. Oh, you could do it faster if you did it this way, right? You know, it's just you can be clever and you can measure the results objectively. I mean, performance is just crack for programmers, right? And it's just it really takes discipline to say, no, I'm not going to do this just because it's faster. You know, I'm going to do it the simplest way possible, and then if that's too slow, I'll speed it up. Oh, that's so hard to do, for me at least. So that's my research agenda. Now, I've been, talking about substrates and data-first software. A lot of people, many of you in this room, in fact, have been working, nibbling away on these same ideas for years, and many others that didn't fit on the slide here. And we kind of agree in spirit, I think, about a lot of stuff, but I think we have some very specific disagreements also. And my goal in this talk, really, is to say that we need to get together and have a conversation about what it is we are doing here, that what is our field. I think we need to define our field and give it a name. And, maybe substrates is a good name, maybe data-first software. I don't care, but I would like us to get together, and so I'm trying to organize a meeting to start that conversation. And let me know if you're interested in participating in that, because I think it would, if we could define what we're doing and have a good name to define it as a field, we would be able to compare and exchange our work better It's better to have more interaction, more feedback, and also it just makes us more legible to the rest of the world, which is important. Anyway, I mean, I'm just an old man shaking his fist at the cloud, literally, right? The stack has been dominant for like almost 30 years, right? And it is all that many programmers have ever known. And in fact, it is quite reasonable, and many people believe that it is the pinnacle of software technology and will last forever, right? I mean, it's really, you know, it's impressive. But maybe history isn't actually over. You know, change is in the air, and you know, actually, if you can remember from before the stack, things used to be quite turbulent, right? We had this whole series of platform shifts from mainframes to mini computers to microcomputers to the web, and at each point, everything got thrown away, kind of. I mean, it's still all running there somewhere, but everyone lost interest in it, and it became a legacy. So, and you know, I grew up with constant disruption, and it's been so boring, you know, for decades now. And maybe that's because, you know, all right, it's the end of history, we've won, blah, 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 but I don't think so. Those sound like famous last words to me. And, you know, AI, who knows what that means, but it's definitely messing things up, right? And there's gonna be some changes. And times of disruption and turbulence, right, is when these big, enormous monstrosities, right, no longer are have, you know, survival value. And it's these scruffy, fluffy little things, right, that survive, clever little things that can survive the turbulence and emerge as, you know, the next mainstream. So, finally, to come back to where I started. What live means to me is that we should conceive new substrates to humanize programming. We should disrupt applications with data-first software. And we should subvert the stack. Thank you.
Thank you, Jonathan. I think we're going to do questions jointly after the next session. Nope. Oh, we have time for questions now? Great. Okay. Oh, good.
Yeah, I wanted to not blab too much.
Yeah, we have 20 minutes for questions.
Oh, fantastic. Okay. Well, I see we have a question that Raven here is our student volunteer. She's going to run mics. Here you go, Jonathan.
I had really small questions. On the data first slide, disintermediate data from code, could you talk a little more about what that means?
Yeah, so I mean, when we're building applications, you know, we write all this code which puts forms or something up on the screen, right? And we're in control of the data. You know, we control the horizontal, we control the vertical. Maybe that's like a dated reference, but and so the user is at our mercy, right? And I'm saying is no, we should just give them the raw data, you know, modulo security and stuff. Give them the data, enhance it with, you know, interesting views that are shortcuts for doing stuff, but let's just get out of the way, let them see their data, which I think will give them just a much more a feeling of empowerment, right? Right? Spreadsheets are great, it's just all there. You can do what you want to with it. And the code should, I think we should be more humble, you know, about the experiences we build. We should just give them their data and enhance it, make the data more usable, but get out of the way.
The other one I was asking about was DB sufficiency.
Yeah. Right, so this is, there's kind of the stack also exists, not only in our technology, but in our minds and in our research fields, right? And so programming languages and databases have just forked, right? And they don't talk to each other. And I mean, think about it for a second. Why is it that just because your data has to last after you pull the plug on the computer, that we should use a completely different set of semantics for it, right? Completely different data model, completely different languages, right? Whereas programming languages, are just another world. Why is that, right? So people talk about orthogonal persistence. Been talking about that for a long time. So I think we got to deal with that problem, right? The data is the data, and actually the data should persist, by default, really. You want to add?
Ask a louder question. How big is small data?
Huh?
Right, you say we should avoid big data. Like, is Moby Dick too big?
Well-
Is War and Peace? Is the phone book? Like, can you talk a bit about what kind of data should we think about?
Well, it's basically just a pragmatic thing that let's not worry about the performance. Let's just do as big as we can get without worrying about it, which is going to be pretty good, right? So Moby Dick's not a lot of characters and text, right? And so databases is what?
It's a million. Ask me how I know.
Yeah. But it's like, certainly the data fits in memory, right? There's no reason to have to worry about data being outside memory, right? And queries don't need to probably, millions of rows is probably big, right? Thousands of rows should be, easy to do, right? You don't really have to even worry about the complexity of your algorithms much if you only have 1,000 rows. 1,000 rows goes a long ways, and there's so many easy ways to get from 1,000 to 1,000,000 that we shouldn't be worrying about 1,000,000 rows. I don't know, that's kind of a weak answer, but.
Millions, not billions.
Yeah, billions is probably going to be problematic, and let's just cede that territory to the stack, right? That's not where we want to fight.
All right. Hey, so I liked the things you're talking about. There's actually one thing I'd kind of like to disagree with, which is the power law of complexity. I'm sure one exists, but I think we need to maybe stop romanticizing the spreadsheet, because I think the spreadsheet is better thought as a subset of programming, i.e. one simple Zapier rule. I can maybe just be loud as well.
Yeah.
One kind of like, if it's raining outside, or like it's light outside, turn on the lights. Like, spreadsheets don't manage the outside world. And I wondered if that maybe we've kind of got a bit lost on like that being a misleading direction. Like, how do we make really, really simple things which don't fit in spreadsheets? And is that a valuable battleground as well?
Well, yeah, I probably should have put that on the slide, but effects, right? Clearly, spreadsheets don't have effects, and that's something we need to have in a good substrate. I think spreadsheets are quite limited, but they're just so impressively good. Users just really, really like them because they're simple, and once you learn how to use one spreadsheet, you can pretty much use any spreadsheet. That's great. It's not true of applications. That also goes to the disintermediation thing, right? Every app has its own layout of fields and its own set of actions, and gosh, that's just like you have to be trained on every app. You don't have to get trained on every spreadsheet. So there's a lot of things we can learn about it, but yeah, they're not a programming system, really, right? They have very limited programming capabilities. But I'm just saying that we should take lessons from what works about spreadsheets when we design a new programming system. Oh, am I? Sorry. Michael.
Okay, so this is really interesting. I've been thinking a lot about scientists and the needs of scientists. And on the one hand, I don't think they want to stack. I don't think they need to stack. They're not really trying to build applications. On the other hand, they deal with what I think you would consider large data sets, maybe terabytes. They maybe are interested in the code, or at least the analysis, more than the data. So I'm not sure whether this data-centric or data-first view kind of fits their needs. I'm wondering how you feel about that sort of application or user space. Do they fit in your vision? Is that a separate vision?
That's a really good question. And yeah, it doesn't quite fit. You could, because they really do have big data. So maybe there's a way we can sort of force fit it. I mean, I don't think notebooks are meeting their needs either. And from what I've heard from people out in the labs, scientists can't use notebooks either. But Joe Hellerstein's work on what was that product? Wrangler, right. So Wrangler was a nice little research project on direct manipulation of data in order to do data cleanup kind of stuff, right? And it just sampled your real data and then let you work in this nice world. And then once you had it working the way you wanted, then it would write SQL or whatever stuff to do it on the big data. So maybe that's a way to sneak it in. But I think you're right. There's a little bit of a force fit there. Jeffrey.
Curious, so at some point you said modularity is a value. On the other hand, when you compare the stack to substrates, the stack looks much more modular to me because part of the value of the stack is you can pick your database and pick your front-end language and blah, blah, blah. And it seems to me that often a challenge with shipping substrates, let's take, I'll pick on Darklang as an example, which some of us may have heard of. They tried to ship essentially a database, a programming language, an editor, and a runtime all together as a startup, and they're still working on it, but it's just really hard to do all that stuff and to convince people to go all in on a monolithic, thing like that. I'm curious, do you see that as a tension too, and do you have any thoughts on how we should approach that challenge as a community?
Oops. Now what? I think there's actually two questions there. Modularity. So yeah, I mean, the reason the stack works is that the viral DNA fragments can be recombined easily and produce new Frankenstein monsters. But that's how it works internally. In fact, the problem is that if you want to reuse code, right, or something, if someone else has built an app and you want to take some of the functionality out of it, it's really hard, right? In practice, at the end programmer level, there's all this glue, and basically it's just a lot of copy and paste. I mean, I don't want to. A lot of people work on modularity, right? I mean, it's really an interesting problem. And modularity and malleability are kind of dual to each other. They're really closely related, and there's been so much work on it, and I can't say that I feel that any of it's super successful, right? I mean, the one place you get modularity is in spreadsheets again, right? Because I can just copy a formula from one guy's spreadsheet into another. It's kind of easy, right? And so used to be able to, when you could do view source on the web, and you just copy that code and make a few changes to it. So, everything, modularity, malleability, it all gets so much simpler if it's small, right? It's just things should be smaller and consistent. If it's all in the same language, the same semantics, and this goes all the way back to Lisp, right? When Lisp machines, where everything is an S expression, all the code's written in Lisp, it's all just Lisp functions, anybody can call anybody, then you have a lot of possibilities for modularity. So I think substrates inherently simplify the problem just by reducing the variety of things that need to be connected and customized. To answer the other side of your question, which is really important to think about, business models, right? And I mean, Darklang, I don't want to be too critical, but I think it's not unreasonable to say that their business model didn't work, right? So, I just don't think a venture-funded startup is probably the right way to revolutionize software. There's a lot. Maybe we should create an independent research lab funded by interested people and collect interesting people to work together on these problems. Just a suggestion.
I'll get on that.
Oh, sorry. Question over here?
So one of the things that comes up with these totalizing substrate systems is that they're not legible to the outside. The data gets kind of trapped inside. Do you see that as a problem, or does everything just go into the substrate and then you don't care about using your data with outside tools anymore?
That's also a good question, and that's one of the reasons that things like Smalltalk didn't succeed as much as they could have, because they were kind of insular. and isolated from the rest of the world. And it's not unfair to blame them because they came from before networking was a thing, right? I mean, personal computing was the thing they invented. And now personal computing is not the most important part of it. It's all of us computing together. I think that's a solvable problem, though, if we think about it. I mean, we should think about it hard. And like I was saying, I mean, I think JSON is all you need now to talk to anybody else. HTTP JSON, everything should be that, right? So let's not bother about foreign function calls, anything, you know, just that gets us everything we need. And let's just make that work very smoothly and cleanly. Yeah, you want to?
I understand how code can talk, but if my data is in the system and the data is trapped something, I can't open my data anymore.
Oh, well, yeah, no, we have to do the JSON HTTP has to go both ways, right? We have to serve it too, right? We have to, you know, put ourselves up there and export CSVs or whatever people want of your data. You have to be completely open now to the rest of the world, and it's just web APIs seem to be the way to do that, and there's a lot of kind of de facto standards for that, in fact. But, you know, you're quite right. Right, there's this ancient cultural tendency here to isolate ourselves into a little language cult and not worry about the rest of the world and just create our little utopia. That doesn't work, right? That's been proven not to work, right? We have to be part of the world. Yeah. Taylor.
You mentioned Smalltalk a few times. I know there's some Clojure people with NextJournal here. What are some other substrate type groups that you think are doing a lot of things right now?
Well, I mean, I certainly think, I mean, Clojure is a wonderful ecosystem and has really good taste, you know, in design. But it's still just a programming language that runs on the JVM, and you know, and I'm saying that we should do something more ambitious that reaches the end user, right? Clojure doesn't. It's a thing for developers, and we want something that you can put in front of the user, because that's how you deliver some value, right? Simplicity doesn't sell. Okay, here's the problem. You know, you can build the most wonderful programming system in the world. It's so elegant, it's so simple. Programmers don't care, right? This has been proven. Simplicity doesn't sell. An expert is more interested in their expertise, right, than throwing it away, you know, for something new that anybody can learn. You know, I'm being a little insulting, but intentionally, right? This is a problem, right? We're not going to convince programmers to change the stack, right? We have to go over their heads to the users and create value, right, to the end users that then will compel people to jump on that.
Is there anybody doing it right?
Oh, I mean, I like what you're doing. It has some good stuff. You know, you're down in the et al. Part of that slide. There wasn't any room. Yeah, I mean, let's experiment and try stuff. But, you know, we're all struggling here, and I think a lot of the people that you'll be seeing later today are making some good efforts in these directions. Peter again?
Yeah, you mentioned going beyond the grid. Where? Like, what are the other things? What's the grid bad at? What else do we need? Like, you said outlines, is that it? Just grid plus outlines? Done?
I don't want to pitch my own research here.
That's fair. Hey, it's your keynote, man.
That's true, it's my keynote, and you're kind of stuck here. I mean, I really like the idea of trees, cross-linked trees, as kind of a sweet spot in data models that can handle a lot of the other stuff we do. And it's the cross-linking that's important. People sort of leave that little detail out, and it turns out to be really nasty to get right. So cross-linked trees, I'll just leave it as that, is my proposal for that's the kind of substrate I'm building.
Do you think that's enough alone?
I don't know, but it you know, I mean, it handles databases nicely. It handles documents, which are tree structured. It handles code, which tends to also to be tree structured.
What about drawings, maps?
Yeah, those are kind of like atomic things that don't really fit into my structure all that well, to be honest. Yeah, they're just data types. But I'm not really, I don't have a good algorithm here for, yeah. Ivan.
Hello, is that on? Okay, great. So you started the talk by sort of looking back on 10 years of this session, whatever you want to call it, and then talked a little bit about substrates, but this session live, there's work from more than just the area of substrates. Like substrates is an interesting focus. It's like, here's an area where we could do more explanation and it would be very enabling. But there's also work shown here on interfaces and on like stuff that's closer to the end users than to the programmers. And I'm curious if you know, looking back over 10 years, have any things that you feel like, there's aside from substrates, here's another area where there's still a lot of, you know, green grass, a lot of blue ocean to explore, or alternatively, here's some totally brown field, you know, bloody water, get away from there as fast as you can kind of stuff that this group might have been exploring that you want to caution us away from?
Well, the latter's easier to answer.
Yeah, don't say the stack. It has to be stuff we in this room would be interested in that you want to scare us away from.
So, you know, visual programming with nodes and wires. I mean, I've done it. We've all done it. Everyone goes through that phase.
Nobody's done it well. Nobody's done it well.
And everyone grows out of it for good reason. So
I will remain forever young.
Hey, you know, more power to you, and keep at it, because maybe someday somebody will make it work, right? I mean, we have to have faith here, right? And so I don't want to tell someone not to do research, but there's just been a lot of dead ends there, you know. And also, you know, I mean, I say let's generalize spreadsheets, but, you know, putting Python code into the cells of a spreadsheet, that's not going to get you very far, right? So I'm sorry if I'm criticizing people's research here. I don't want to do that, but you know, you asked me to, and I took the bait. So, and the other side of your question was, well, what else should we do, right? So I'm not saying that live should be about substrates. It's not all about substrates. I'm just this is just my vision that excites me about the future, about how to change the future, and I think substrates is maybe a separate, somewhat slightly overlapping with live. Right. So who's first? You guys fight it out.
Hello. So yeah, really cool talk. I'm trying to like synthesize this together in my head. So I apologize if this. I hope this doesn't come across as like overly like antagonistic. I'm just trying to understand. So you talk a lot about this idea of having like a single substrate that's simple, where everything is expressed in kind of like one language. And there have been a few questions, like Peter and Michael have asked questions about like, what about drawings? What about scientists? And you said a really cool phrase that I thought, I think ties it all together, which is you said sweet spot, right? You've found that this like linked trees thing touches on like the sweet spot, which I assume is like the domain of kinds of programs that you're considering, right? And it feels to me, this is just from my initial impression, the place in which this story falls apart is that you're simultaneously pitching this idea of like everything should be expressed in a single like language, single kind of layer of abstraction, and that way, that's how we like solve a lot of these problems. But on the other hand, there are all these domains that don't fall into that. So then maybe for your sweet spot, there's this language, and then for the scientist domain, there's a different language, and then for the drawings domain, there's a different language, and then you no longer have this unified like substrate, right? Am I like missing a part of the story? Like how do you like contend with that idea?
That's a very fair question, and I think there's a lot of truth to it. I'm coming from a certain background of, you know, building certain kinds of applications, so I think about what their needs are inherently more than other kinds, and there's just a lot of there's a lot of kinds of software out there, and the stack handles all of them, and that's why it's so powerful. It's universal. There's no risk of, you know, well, Unix, you can't use Unix to do that, right? There's just no risk that you hit that kind of a wall. So, and maybe we are just a bunch of little fiefdoms that don't really interact. But I really believe there are some sweet spots, to repeat that are some big, wide, general purpose areas that we could address. And maybe there's more than one. I mean, substrates is a plural, right? Maybe there's whole other things. Maybe scientists need a different kind of substrate. Great, let's have many of them. And the thing though is that, divided we fall, right? So somehow we have to come together and agree on what it is we're doing and how we can talk to each other, how we can help each other, and how we communicate with the rest of the world. Because we're not going to do anything as individual researchers, right? We need a field of research. That's how it actually works, right? We have to bridge these gaps and even understand what the gaps are. I don't really claim to understand what the gaps between the different domains are.
Hi, Jonathan.
Hey.
Sorry.
We'll make this the last question unless anyone has a burning question.
All right, go for it, Alex.
I enjoyed your talk. The question I wanted to ask has to do with what I see as a tension between this focus on, like, let's not be insular in these substrates, let's talk JSON, let's whatever. Because when you do that, to some extent, you lose control over the live programming experience that you can provide, because now there are external things. And I'd argue that none of these insular systems, Smalltalk included, reached what I think might be like the pinnacle of live programming, what the experience, that we want to create, or aspire to create or whatever. And I worry a little bit about this focus on external communication insofar as it might discourage people from sticking with the, I think the beautiful, elegant substrate that can do everything and has a great experience hasn't really been conceived of yet.
I totally agree. It's still, these early age systems, or these golden age systems were just so long ago, right, and really before the internet. So we can do a lot better, right, and our standards have risen. So we can do a lot better, and it's inevitable though that as we exchange, we do foreign exchange with the rest of the world on the old tech stack, that there's going to be a loss of functionality. But that's just the way it is, and that's kind of good, really, because you go visit some foreign country, it's fine, but then you come back home and you feel comfortable, right? And we want to have a comfortable place for people to program. And I certainly agree we could do a lot better than any of those golden age systems did, right? So let's do that, right? And finally, I want to put in a plug for the programming conference, which is going to be in Prague in June, and is very much a place where these kind of people, these kinds of issues will come. Certainly with a more European slant, obviously, but I encourage everybody to consider coming, and I'm hoping that I will be running a workshop there about substrates or whatever we decide to call it in the meantime. So please come along. Thank you very much.
Thank you, Jonathan. The great opening to our argument block. Excellent work from the audience. Thank you all. And introducing our next meta argument presenter is our co-chair here, Josh Horowitz, who's going to be trying to define what exactly live programming is in an inarguably correct way that nobody here could possibly dispute or disagree with. And I'm just going to let you have it.
Thanks.
And I'll let you have it after.
Thanks to Jonathan for, I really appreciate, provocative, visionary keynote. This is meta, but it's definitely not a keynote. I'm going to get a little bit more into the weeds. I'm actually not even going to be going as much into definitions for this talk, but I do hope that it's interesting and helps us all think about liveness. So title of this talk is Technical Dimensions of Feedback in Live Programming Systems. And if you saw my essay submission or heard that intro, you'll know that I'm narrowing my focus a little bit for this talk. In the essay, I started to explore this question of what liveness means in general. And it turns out it means a lot of things to a lot of people. I talked about some of those in my essay, which I'll make sure is public somewhere. But in this talk, I want to focus on one particular angle that I've always been really partial to, and that's feedback. According to at least some people, live programming environments provide programmers with continuous feedback about a program's dynamic behavior as it is being edited. And in case you're wondering, according to who, well, here's at least some people. Here's an assortment of papers that use that definition. So there's nothing authoritative or conclusive about this, but I do think it's clear that one way or another, we're all pretty interested in feedback. So I think we should talk about feedback. And I want to make clear that feedback, it's not just one thing. It's not like, does your system have feedback or doesn't your system have feedback? Really, we're exploring a big multidimensional space of programming systems that provide feedback in different ways. So I want to talk about some of those dimensions in that multidimensional space because I think they give us meaningful ways to compare different approaches. So I'm inspired here by the paper on technical dimensions of programming systems that came out last year, which Jonathan, among other folk, were on. It catalogs 23 different dimensions that programming systems can vary along. So each dimension gives you a different question you can ask about a programming system. I think this is great. I think you should check it out. But what I'm going to do today is narrow our focus from programming systems at large to the specific topic of feedback in live programming systems. So I have 5 dimensions to talk about today to get the conversation started, but I'm sure I'm missing really important things. So I hope we can keep talking about this today and beyond. So let's jump in and look at the first dimension, which I call granularity of feedback. I'm going to show 3 systems that vary along this axis. First of all, a demo from Brett Victor. So here, he's editing the code on the right-hand side, and the output on the left instantly updates. That's great, that's live. But there's all these variables and functions and if-thens and all that stuff in the code. So what are they all doing? The system isn't actually giving us any visibility into that. That's kind of interesting. Now here's an observable notebook. In a computational notebook, you break your code up into cells, and the system shows live output for each cell. That's really neat. We're not just seeing a single final output anymore. We have feedback on intermediate values along the way. But there are limits. We still have some if-thens and loops and conditionals and stuff in the code, and the notebook doesn't provide any feedback on what's happening in the code. So we might want live feedback that is threaded all throughout our code. And that's what a lot of interesting systems, including Soren Lerner's projection boxes, does. So compared to these 2 systems on the left, this has a finer grain of feedback. So we're going to make this definition that granularity feedback is how deeply into the structure of a program feedback is provided. And we can pretty clearly rank these systems from low or coarse grain to high or fine grain. And now it's time to introduce a little visual language that I have for thinking about this. The metaphor is that the programs are kind of lurking underground beneath the grass, and we can't really see what they're doing by default. But in a live programming environment, the program can sprout up little flowers, which are the visible feedback. And importantly, programs are usually made by putting together different parts, whether that's lines of code or functions or cells. So on the left, we only are getting feedback about the final output, but on the right, these different parts of the program are giving us individual bits of feedback. Does that make sense? Everybody likes the flowers? Okay, great. Cool. That's good, because there's going to be a lot more funny flowers. But the last note before I move on from granularity, I'm going to make things a little bit more complicated. I've actually left out an aspect of Brett Victor's system that I showed there, which is that even though it only shows the final output as a single pane, it actually gives you this magnifying glass interaction where you can hover over part of the output and it shows you what code made it and vice versa. So in this way, this is actually giving you a kind of a granular feedback that in some ways is better than notebook style cell by cell feedback because you're seeing everything in context. You're seeing it where it fits together. But which is better, having separate outputs, having it all in one pane? I don't know. There's a lot to think about with granularity of feedback, but we got to move on. 2, the second dimension, which is reactivity of feedback. Here, I'm showing a simple little program in Nato, which is a very cool canvas-based notebook. And the pane on the right is sorting an array of strings on the left. And now we want to reverse that array for whatever reasons. So we start typing a dot. And Nato is so live that we get instant feedback. And it's a syntax error because we just have a dot there. So we keep typing, and after a few more characters, we get new feedback, which is that .toRev is undefined. Okay, and then we finish typing, and we get the result we were looking for with a toReverse call. So Nato is reacting to the changes very quickly. It's doing it on every keystroke. And this isn't how a lot of live editors work. For example, in Observable, you need to shift return to run a cell. Is Nato's approach good or bad? Well, it makes things really direct and really immediate, but maybe sometimes it's a little bit nonsensical or a little distracting. Like I know .rev is undefined. That's okay. I'm still typing. So I don't know which approach is best, but one thing I do know is that this is a dimension, and I'm calling it reactivity of feedback. So it tells you how often changes to a program are responded to with feedback. And Nato actually is kind of aware of this dimension. It has a setting over here where if you click it, it turns off the auto mode, and now the cell only runs when you deliberately press the play button over there. So this actually makes Nato less reactive in this sense than Observable. Observable always updates when you move away from a cell. So here's a ranking of these 3 different interfaces by reactivity. And now the x-axis is kind of like a timeline, and these are different states of a program, which are connected by edit actions with these little hands. So on the left, you can have several edits without feedback visible, but on the right, every edit gives you feedback. So there's a lot more to say, naturally, about reactivity, but we have to move on again to the third dimension, which is also about time and change. This one I call velocity of feedback. So far I've been drawing the program editing cycle kind of like this. You see some output, and then you make a change to the program in response. But sad but true fact of life is that feedback isn't always instantaneous. Sometimes there's like a bit of a delay from when a program is in place to when you can see what it does. And sometimes there's a lot of delay. So it's pretty simple. That's velocity of feedback. How quickly is feedback available after a change? We're pretty spoiled today in modern computing that a lot of the things that we do are so fast we can basically pretend they're instantaneous. But if you go back in time, latency of feedback was a big deal. You used to have to type your program on a punch cards, drop them in a queue, and then maybe the next day you get your output. Time sharing systems drop this latency to maybe seconds. That's amazing. That's a lot more live. But even today, velocity is often on our minds as we build live systems. Sometimes it means we need to be careful in how we implement systems. For example, a lot of live systems are designed to run incrementally, so that when you make a small change to one part, the program doesn't have to run from scratch. It just runs the right parts. And making things incremental, it's hard work, and it's all work that's being done to maintain this high velocity of feedback. And there's still, even after all that, sometimes things just take a long time to run. Like if you're making a data analysis system for scientists, sometimes there are going to be steps that take seconds or days to run, and this introduces design challenges for systems around that. Like how do you design environments where feedback can get out of sync with a program? So tricky questions that we should consider, but we should also move on to the fourth dimension, which is bidirectionality. This one is huge, very big topic. I'm going to cover it in one slide. So on the left here is Sketch and Sketch. It looks at first like your typical split screen code preview kind of editor, but there's a twist, which is that you can directly edit the thing on the right, and that changes the program on the left. So feedback becomes not just something to look at to understand the program, but it becomes a handle for editing the underlying program directly. In the center is the extractor tool from Ingraft, and this one lets you create a program that extracts information from a complex JSON structure just by clicking on the parts that you want. So here, feedback from a previous step in a pipeline becomes a handle for defining the next step. So there's a ton more examples like this. Sometimes they go by names like output-directed programming or programming by demonstration, that kind of thing. But they all share this characteristic that feedback sprouting up from the program becomes a handle that you can act directly on to change the underlying program. As I said, enormous space, very exciting to think about, but we can't do that now. Because we gotta talk about our last dimension, and I think I've saved a really interesting one for last. The name here is definitely to be determined, but I'm calling it criticality for now. And it's demonstrated, I think, really well by this circuit simulation that Alex Worth, who is here with us, made with eToys. The way this is programmed, each circuit component, like the wire or the inverter, it looks at its input dot to see what color is underneath it. Is yellow underneath it or black? And then it uses that color to determine its behavior and what color it becomes. So that means that the thing that we humans are seeing that makes the program's behavior visible is also the thing that's driving the program's behavior. If we turned off the yellow-black thing, because, oh, it's just a visualization, the program would stop running, it would stop working, which means that visualization is on the critical path, which is why I call this like criticality. So here's how I draw this with flowers. You gotta draw it with flowers. So on the left, with something like projection boxes or many other systems, feedback is not critical. It's sort of, in this case, tacked onto Python as a side effect, and we could just as well turn it off. But on the right, with eToys, feedback is on the critical path. In a sense, computation goes through the realm of feedback, the realm that's visible to us as humans. And this is a radical approach. It goes against a lot of traditional computer science principles, like that you shouldn't like mix up your views and your models, and computation shouldn't be, it should be driven by like elegant mathematical abstractions, not by like dinky little pictures on a screen. But having critical feedback profoundly affects the experience of using a system. The program is looking at and working with the same things that you are as a human. So you're not a second-class citizen anymore. And I think this concept of criticality is expressed really well by Boxer, which was mentioned earlier, and which I hope some of you know. Boxer is explicitly based on this principle that its creators call naive realism. They say that this means that users should be able to pretend that what they see on the screen is their computational world in its entirety. So I think this naive realism is sort of criticality taken to its full limit, where the entire computational world is pulled up above ground. Okay, so those are the 5 dimensions of feedback that I have to offer today, with a 6th at the bottom as sort of a teaser. And as I mentioned before, it's all just sort of a first draft, my first run through of trying to think about this. If you have critiques of some of these framings or like other dimensions in mind, I'd really love to hear about them. So thanks so much. Yeah, and also we can also do it. We can continue to have, if people have questions, I think, about the keynote as well. If you'd like to come up, that's also great. So yeah.
Hi, is this on? Yeah. Thanks. Hello.
Thank you.
Thanks so much. That was really, really great. I really liked how like this opens up a lot of broadness in what feedback can mean. You're not putting forward this vision that's like this is the way to do feedback. It's more like these are some dials to play around with for different use cases, and I really, really appreciate that. I also really benefit from these visuals, cool. And I'm curious to hear more about like the process of landing on these visuals. Like, was it like your first attempt, or were there like some other attempts along the way? Yeah, thanks.
Yeah, thanks for the question. Yeah, it's a good question. Definitely not the first attempts. I think it is kind of a struggle. There's a lot of like constraints you're working with when you try to make a diagram for something. There's a lot of like dimensions that you're working with, and you're trying to compress it all into something like this. I think I just by chance came up with things in time for the talk that felt like good enough to share. But I think fairly early I felt that I wanted to have visuals, and I'm not exactly sure why. I think maybe it's just that when you're presenting a bunch of things like this, it has the risk of just being kind of a hodgepodge and a grab bag. And my hope was that having a visual language would give some underlying structure that would allow you to like connect together these different dimensions and think about even maybe their interactions. But yeah, I just messed around with it until it kind of worked. I don't know if I have anything better to say. Okay. Oh, and I guess I should call on people. Yes.
Deployment outside of your computer. At least that's one that I struggle with. It's like it works on my laptop.
And in terms of feedback, this is about like being able to get.
Well, because it's like, how do I take that flower and put it in a pot somewhere else?
Okay, yeah. I mean, I don't think this is exactly what you're saying, but I mean, one question is about, now that, for example, we live in a networked world, I may be doing things that are supposed to have effects sort of places that are far from my computer, like maybe I'm sending out some requests or something is running far away, and how do I get that feedback back to where I am? I don't know if that's quite what you were saying, but
also,
that one resonates for me.
Just when I work with these systems, it's like it's very nice on my own system.
Yeah.
It's like, but it's not working yet.
Oh yeah. That almost gets into this issue of like, a natural issue with a very big general problem with liveness is, you're seeing the results from some execution, but how much do you know about the generality of that execution? I think maybe this is a way of abstracting what you're saying. So for instance, even I'm seeing the results with one set of inputs. What if the inputs were different? And this is of course why, the static typing people feel great about what they're doing, because it's like, well, we have mathematically proven that this behaves a certain way in all possible situations. And we're taking a certain trade-off when we move to like looking at concrete execution. But there's a question of how do you sort of get a sense of the adjacent possible, like somebody else's machine. Yeah, that's great. Okay, sorry, me babbling. Yes, in the second row. Yes. Yes, you. Yeah.
Thank you so much for the amazing talk.
Oh, thank you.
I really liked it, and it really got my thoughts flowing about this type of stuff. So one question I have is how you think about like the representation of feedback kind of relating to these technical dimensions. Do you think that like the representation of feedback could be like a separate dimension from the ones that you presented? I think it might also relate to moldability.
Yeah.
Maybe I'm guessing like how those representations can be modified by the user. But do you think that like the representation of the feedback is a separate dimension, or do you think there's maybe even some like smaller dimensions within how feedback can be represented to people? Because programs can be represented in many different ways.
Yeah, I think that's a great question. Programs can be represented in many ways, and the things that, like the data flowing through the programs, can be represented in many different ways, and those questions intertangle. So yeah, I think it's got to be like a lot of dimensions about that. In this, I'm sort of thinking here, it's a flower. When I talk about feedback, it's like I'm not even really looking into what's in the feedback. So there need to be more dimensions about how the different flowers can look, and I have so the moldability is related. In this case, what I'm sort of talking about is this idea that when you're working with different kinds of data, for instance, you don't just want to see some generic representation of the data, like, oh, it's just like a JSON dump or something. You actually want to see like powerful, visual, diagrammatic, whatever representations of the system you're working with, and that's something that might not be something that, it's not like the system is going to know every situation you run into. It's going to, you're always going to be running into new situations. So here I'm terming that like moldability, the ability to, as somebody who's engaging in the act of programming, mold these representations into new forms. And I'm sort of taking that term from the glamorous toolkit folk who talk about multiple development, and then the clerk folk who have sort of followed in that lineage of moldable viewers. And the representation is, it's a weird, different, pretty flower. So yeah, thank you for the question. Okay, I'm going to go to this side a little bit. Michael.
So your visualizations, you can think of as programs in a visual language, or otherwise known as a core calculus, right? So you develop the core calculus dimensions. I wonder if there are other dimensions that core calculus suggests that we can explore also.
So yeah, you're saying that sort of discovering new dimensions through playing with the visual language. Yeah. That's a delightful thought. Yeah, I'd love to do that. I'd love to mess around with a whiteboard or something. Too bad we don't have a whiteboard in here, but maybe somebody knows where we can find one. Thank you for the point. Okay, in the back against the wall there. Oh, okay.
I'm curious if you've thought about, so like there's granularity, which is talking about, it kind of tells how deeply into the structure of the program, but if you think about like projection boxes, right, you're seeing each line of code, you're seeing like each expression, whatever. I'm curious if you've thought about like maybe depth, maybe I would call it, of feedback. So like you could see you can see all of the data, cool. But how do I know like the VM underneath the hood? How is it running? Am I able to get feedback into at the level of the system, and how is the heap going, et cetera? So we can kind of see like a surface level, but we might not be able to see it underneath what's going on.
Yeah. Do I have that in here? Oh, that goes into the genuine garbage files. I'm not going to go into that part. Okay. Well, I'll just mention that I was really charmed by a tweet recently of somebody tweeted that their vacuum cleaner showed them the size of the quantities of different particles, and then Andrew, who's I think here, retweeted it with the text, "None of my business," which I think is like a kind of a lesson about like. It's not like turning the dial of granularity up to max is always a good idea. But yeah, you're making a good point that there's sort of like layers of abstraction, say, where when you're working in a programming language, there are things that are kind of part of the semantics of the language that are exposed to you. But for example, how is it laying these things out in memory? How is it like, what is it jitting or not jitting? Yeah, I think that's a really good point in that I see that there's like a bit of a different flavor in that from the granularity as I've discussed it here. And that is stuff that sometimes you want to see. You want to know, like, this is going really slowly. Why? Oh, maybe it's because of like branch prediction on the CPU or something. So yeah, absolutely. Yeah, against the wall, yeah.
Hi, this was a really cool talk. Kind of thinking about trade-offs like in the last question. So like, in like reactivity, sometimes like if you have like a system being very reactive, it's almost overwhelming. But I was wondering for like criticality, what do you like foresee as like potential trade-offs there? Because I feel like the feeling of being a second-class user like is very visceral.
Yeah, I definitely sort of put in I let some of my bias show when I was talking about that dimension, because I'm very like interested in pushing on this criticality dimension, and I think part of the reason why I wanted to speak with that bias is because it is so unconventional, and like again, sort of I think most computer science people would tell you lots of problems with that kind of criticality. Like you're sort of giving up these worlds of like predictable, structured abstraction, things that don't live on a screen, but things that live inside of like data structures that perfectly semantically represent what they're supposed to represent. So I don't know if I can speak too much in detail about the trade-offs, but it's very clear to me that like an awful lot of people are definitely not into this criticality direction. Yeah, that's helpful. Jonathan, you should go ahead.
I love this. Thanks. I want to suggest that criticality, which is the coolest like thing going on here, I think. Like this is like sort of the research frontier. The picture there, what you really should have is that above and below are the same, right? That the flower is also below. And, and this is something I've called alignment between the semantics of the UI and the programming language. Right? They're the same thing. Maybe one's a subset of the other. I wanted to call it unification. Yeah, unification.
Yeah, and you're saying, I guess your suggestion about the visual language specifically is
the flower should be underneath.
Oh, okay. Well, yeah. I mean, I guess the heuristic that I've been using for the visual language is that the line of grass separates things you can see from things you can't see. So I guess I feel like the flower is usually the thing you can see. But what's that? Oh yeah. So in this case, this part of the program is above the grass. This is a system where some parts are critical and some parts aren't critical. But the indication was supposed to be that the program is above the grass. So, but yeah, I mean, I'd be happy to iterate on the visual language a bunch. Yeah, I'd love suggestions on that. Next question. Yes, Saketh.
Hi, thank you for the talk.
Thank you.
Yeah, so I kind of wanted to follow up with what you were saying about abstraction and levels of abstraction. It seems like, when you're designing a system, you have to make a decision about like where you want people to stay generally, but I'm curious about your thoughts around like, sometimes you do have to move between them, and like, I mean, I'm sure you've thought about this a lot within Graph. Like, how do you deal with just having to switch between levels of abstraction and keeping options open? Do you need to?
Yeah, I mean, it's a great question. In general, in thinking about this talk, I've been very much like, I don't need to actually solve any problems. I just need to articulate them. But I think in the world of user interfaces, we have a lot of patterns that we use for things like that. Even things, I mean, it can be really prosaic. It can be things like the image of like expanding and collapsing. We're all used to like interfaces that show you overviews and let you dig in more deeply. So I think a lot of those like very prosaic interface elements deployed correctly in the context of a programming environment could do the trick. It may not be something super fancy, But I'd also be happy to hear people do have super fancy ideas. Oh, and then another example, just like another concrete example, which came up in a recent project I was working on was, so I'm sure there's like a good fancy HCI term for it, but something where focus, like an expanded view follows around where you are. Something where, if you have a cursor in a code editor or something like that, then the system has some idea of where your focus is. You can use more screen space to have an expanded view of what's happening there, and in other places you can just have summaries for peripheral vision, that kind of thing.
Like a lens.
A lens, a fisheye, exactly. Fisheye, lens, these are exactly the terms. Thank you. How about in the back? There.
Yeah, I really like these dimensions. I was wondering about, you mentioned how turning the feedback dial up to max is not always helpful. So is there some dimension here about sort of the specificity or economy or informativity of the feedback? For example, I was thinking like if I get feedback about what a variable x's value is, I don't need to also see what x plus 1's value is if that's on the next line, because I can kind of do that.
Yeah, no, that's a great point. I might naively at least kind of fit that into this kind of granularity thing of you're basically saying there are certain parts of the execution that you don't have to show. The most obvious version of that is, levels of structure in, the AST or whatever, like a notebook shows you cell by cell output, but not more detailed things. But part of what you're indicating, I think, is that the structure of the computation itself might give you cues about where it is and isn't useful to show certain things, like as you say, like don't show x and x plus 1. That's a really great thought. I appreciate that. Maybe in the back here, let's do Ivan.
Great stuff, Josh.
Thanks.
I just want to, this is going to be super quick. I want to point out that all of these are talking about feedback that somebody gets from the program, and they suggest the other direction, that there's ways of inputting information into the program that all of these dimensions allow you to play along. And so I think that would be a really interesting...
Like just flipping them.
Yeah, exactly.
Yes, that's a great point. There's something that, I don't know, somebody I showed this to made the point that, well, these arrows that represent edits, they're all underground, which is weird because it's that's the part that you don't see. And I'm like, well, but it's that you don't see the dynamic behavior, but you see the static behavior. But there's sort of a whole other set of questions about the line of how you actually engage with the program, and that gets a little bit into. I'll put in a plug for. Sort of trying to socialize the terms like liveness and richness as distinct qualities, and so I have like a paper on that. And richness talks about one particular dimension of how you interact with a program, specifically being able to like interact with it with direct manipulation and that kind of thing. So that would be a part, I think, of what you're talking about. So thanks for that point. Lisa.
Thanks, Josh. This is really great work and really great essay. I have a question about how you think customizability have a place among this dimension. I brought this up because we've done some recent work. Actually, an earlier version was presented at Live last year, so a little bit of throwback. In the recent work we did, we found that users, especially programmers, they want to see different levels of, for example, granularity and then other aspects of dimensions you mentioned, like in the feedback when they're in different modes of programming, like starting from development, incremental development, to debugging, and eventually to testing. They want to see different kinds of live feedback in different modes. So I was wondering, like, have you thought about turning these different dimensions, or at least a subset of it, into like a customizable set of sliders that the user could play with to, get customized kinds of feedback and so on and so forth. Like, do you think of customizability as a separate aspect in the technical dimensions, or do you think of it more like a meta player that could, coherently connect these pieces together?
It is almost like a meta dimension, because what it's saying is that a given system doesn't necessarily like occupy a single point of one of these spaces, but it might give you different handles, different interfaces for actually moving around on this in different ways. And I think we saw like a quick example of that. I passed through quickly with Nado for reactivity, where it does give you some like adjustable reactivity depending on what you're working on and your needs. And I've seen other systems that do that too. So yeah, I think for any one of these systems, you might also want to say, what does it mean for a system? For any one of these dimensions, you might want to ask, what does it mean for a system to give control of this to some degree to a user. Yeah, I don't think I have anything more insightful than that to say, but yeah. Okay, Jeffrey.
Curious, do you have any suggestions for us as a community for how we might use a set of technical dimensions to make progress? So, for example, like the work that Doug and others have worked on, they put a bunch of systems on a website and did the work of assessing them against dimensions. And I've gone through that table and thought about it. So I can imagine a similar effort. Maybe people could start like using the dimensions as part of their evaluation sections when they submit to this workshop. Do you have other ideas or hopes for how this sort of thing can help us as a group?
Yeah. Well, I don't like the idea of people having evaluation sections when they submit to this workshop. But aside from that, it's a great question. So immediate thoughts on the top of my head. One hope I have is just that these will be useful, like words for conversation. Like I've found that it's hard when you're having a conversation about, say, like live systems, and you don't have like well articulated kind of like concepts that you can share with other people. So part of my hope is that it's just useful for conversation. Another hope is that it can be something that's generative, something that where if you're like designing a system, you can sort of run through these and say, well, what is the relationship that this system has with granularity or with bidirectionality or whatnot? And then I guess you're also mentioning the sort of the task of going through existing systems and trying to understand them this way. I think that would be a useful exercise to do. Maybe I'll do that. I don't know. It sounds like some work, but well, maybe we can do it together. I don't know. Let's split it up. Yeah. Thanks.
We have time for maybe like one or two more questions.
Okay. Cool. How about in the back?
Thank you. So have you ever thought about a new dimension, the vividness of the output? For example, a plain text unformatted syntax tree is, of course, less informative than a pretty printed one, and also less informative than, for example, an interactive one. Yeah, I think in your metaphor, that might be the growth of the flower.
Yeah. And I really appreciate getting the word vividness. That's a very helpful one to work into this. And I think that when I articulated this sort of moldability dimension during some Q&A, I guess in that case I'm sort of focusing on giving the user control of like how do they represent it. But even before you talk about user control, there's just the question of how helpful is this feedback? And because when you talk about a pretty printed program, it's not just that it's like more colorful, it's that it actually hopefully like helps somebody understand it. And we all know like the world of like rich, well-designed visual representations is just so powerful. So articulating the degree to which a system gives people access to those is a great question.
Okay, thank you.
Okay, I'll give Peter privilege.
I'm gonna oppose one of these dimensions.
Cool.
Isn't velocity necessary? And not really, like, if your live programming system doesn't give fast feedback, it's not live, it's dead. That's the whole point.
Yeah, and there's a funny thing where when I listed all of those like citations here, they actually almost all before the word feedback they say like immediate or continuous or things like that. But I don't know. I'm a little bit informed here by I had a chat with Steve Tanimoto, who arguably coined the term liveness back in the 80s, and he sort of told me this context of like, well, when he was writing that, like the memory of the progression of computing was very vivid in the mind, of going from the punch cards to the time sharing system to the graphical user interface. And I think I feel like each of those steps was a step forward in liveness. I don't know, it's sort of, maybe it's a semantic argument, but there's a sense in which like, immediate, these are all sort of in the eye of the beholder, they're all relative. So yeah, and sorry.
It's kind of the only one you have where I can't imagine good reasons to be at either point.
As in it's only a good thing. I think that's a fair point. Yeah, I think that's a fair point that it's not one with some sort of like interesting design questions about where you want to be. You just want to be high up. So yeah, you're right. It is different in that way. I appreciate that.
Well, it's annoying when you're typing things and the system is annoying.
But that's reactivity. That's a different one. Yeah, this one is like, these are all, I call these technical dimensions, partially as an homage, but also to emphasize that they are all aspects of the system as a technical artifact, as opposed to, you could also, by the way, this is a great point to mention, there's a whole world of like social dimensions that you could mention of liveness, where you could talk about what liveness means in the sense of like people's experience of it and people's experience of it with each other. I'm not doing that here. I would say that this velocity is maybe like too technical. It's like it's very implementation-y, but it's in there. Maybe that's enough.
All right, thank you, Josh, for a stimulating debate and excellent figures. This concludes the meta nonsense part of our workshop today. Henceforth, everybody will be showing things that they've built, so thank you all for coming. It's a half-hour coffee break. Please come back relatively promptly for the next session because we got a lot to get through today. And next up is visual systems, so we'll see you in half an hour. Enjoy.
work on your sonnets. Right, okay. 14 minutes is not a long time. Done my best.
We got a lot of good talks today.
All right, everyone, we're going to get started here with our next session. All right, so this is the block that we've titled Visual Systems. We have 5 awesome talks for you, which all involve very loosely some aspect of live programming with pictures. And our first speaker today is Marcel Goethals with Subsequently.
So hello everybody, my name is Marcel Goethals. I am a researcher at Ink and Switch. I work on a project called Programmable Ink, which I will not be telling you about today. My colleagues Ivan and Alex will be telling you about that in an upcoming presentation. I'm going to talk today about a project I've been working on called Subsequently, which is a visual and tangible programming environment for exploring and understanding algorithms. So one of the questions that I'm interested in is like, how do we build mental models of programs, right? Like, how do we get an intuitive understanding of what an algorithm does, how it works? And one way of approaching this is to look at how people explain algorithms, right? So here's somebody that's like trying to explain an insertion sort algorithm, and what they, like a kind of pattern that you see again and again is what people will do is they'll do a step-by-step walkthrough using a concrete example, right? So they're like drawing like actual data structures on a piece of paper. They're like walking you through step-by-step, sort of telling a story of what's happening in the program. And what's interesting to me about that is that it's so unlike the experience of actually programming, right? When you're doing an explanation, you're using concrete examples to tell a story, and you're using pictures to sort of support your story, your narrative that you're telling. When you're programming, when you're actually implementing an algorithm, you're dealing with these abstract generalizations, you're sort of pushing around these abstract symbols on the screen, and you're certainly not having any pictures that like kind of support what you're doing. So the question is, can you tell stories with pictures to make programs, right? Can we try and make the experience of programming a bit more like the experience of when you're trying to explain something? So here's Subsequently. Oh, it's like only partially on the screen. I can see now. That's okay. We'll deal with it. And so, oh, there we go. Great. Yeah. So what we're seeing here is in the beginning, you're sort of prompted with this panel in the middle of the screen, and it says in the beginning, as you can see. And so it's telling me, okay, begin to tell your story, right? So I can drag this thing over here into the middle. And what I'm doing is like saying, okay, let's create a list. And the description on top will be updated, right? Create a list A. And I can continue my story, right? I'll create a panel underneath and saying, okay, and then what do we do now? So what I might do is sort of concretely act on that data structure, right? I'll take this number over here and drop it down. And you can see, again, the description updates, right? Take the last element of A and call it B. And these things are color-coded, right? So like A is green and B is blue, as you can see. Now you might, in this case, I'm sort of taking the last element, right? But I might want to do something else. Maybe I'm like interested in taking the second number, right? So I can do that as well. In this case, take the second element of A, right? Or if I really wanted to do, I can do something even more fancy, right? Maybe I'll like add a second number over here, and then I'll concretely act on that number over here, and then say, actually, it's not the second number, it's the bth number, right? I'm like using that number over there to like index into the array. And indeed, if I scrub this number over here, right, you can see that it updates. Do you see that, right? So this is sort of the general principle of the system, right? I'm sort of like creating these sort of concrete steps, directly manipulating data structures, and in doing so, building up an execution of a program. So let's try and do something a little bit more interesting here. So maybe I'm going to create a program that reverses a list. It's like a very simple program, right? So I'll create a list first, then I'll create a second list that I'm going to use as sort of the target where I'm going to put my reversed list into. So I'll create an empty list, right? Again, the description updates. And then what I'll do is I'll take the last element like this and like pop it into that element over there, right? And I can continue doing this if I wanted to, right? I could just concretely act on the data and like, right? But this is a bit of a simple program, right? We're programmers and we want to like actually automate this process. So let's try and do that instead. So what I can do here is I can take these eyes, right? And I can drop them on this list, right? And so these eyes are looking into the array and saying, is this an empty list? No, it's not. And as you can see under here, we sort of created a branch-like structure that's appeared, right? And I can sort of click on these to create panels for each of them. And as you can see, one of the branches is highlighted and the other one is grayed out, right? Because we're concretely running this program and this branch, we don't have any, it's just not occurring in our program. So in this case, what we want to do is, okay, if the list isn't empty yet, we'll just like take the last element, put it in the second list. And then what I'll do is I want to repeat that process, right? So I'll just concretely draw an arrow up and like wire it up like that. And now what you see happened is there's these little dots that appeared, right? Which are sort of indicating that like the program is looping around and like every time it passes around, there's a little dot. So if I click on those little dots, I can actually see the execution of the program step through, right? Until eventually, inevitably, the list is empty. It's like, yes, it's empty. And if we look down there, we can see, indeed, the list has been reversed. Success. Okay, let's try something a little bit more interesting, right? Let's try filtering a list. So we want the list. Let's do this. Like that. And I'll create a number as well, which I'm going to use as my condition, kind of, right? So I'll say, let's give me the list in order, but like only the numbers that are smaller than 4. So we'll do the same thing again. I'll drop in like the eyes. And now in this case, what I'm going to do is take the first element, right? So I'll concretely take out the first element, drop it next to it so I can compare them. And I'll take this comparison action, right? I'll put that underneath so I can say, so I'm going to compare 1 and 4. And indeed, 1 is smaller than 4. So we can see, indeed, if we do this, right? Yes, 1 is smaller than 4. And so what we want to do if it is smaller than 4 is we'll drag the 1 out and like append it to the list like before. Okay, and then we just want to repeat that process, right? So we'll like drag it up again all the way to the beginning. There we go. Interesting, right? Because there's now only 4 iterations that appeared. That's a little bit strange. Zoom out a bit, I can check. And indeed, we'll see, when we switch to the 4th iteration, we've reached a branch that we're not doing anything with yet. So in this case, 4 is not smaller than 4. It's equal to 4. And we just want to like continue and do nothing with that value. Oh dear. Gonna drag it all the way up. And now, the program continues. Right, and so if I can sort of toggle between these things, you can see all of the different code paths that the program takes, and in the end, we'll see the result, right? We filtered the list, so we only have the numbers smaller than 4. And again, this is live, right? So if I update this number, it'll dynamically recompute. Okay, cool, let's go back to the slides. So what do we see here? This is sort of a truly visual programming language, right? And we're visualizing 3 things in particular. We're visualizing what is happening, and what will happen next, right? So we're visualizing what is. The state of the program at each point in time is there in front of you on the screen. But not only that, we're also visualizing what is happening, right? Because programs aren't just arbitrary sequences of state. Things happen for a reason. And so we're trying to visualize those reasons. Right? Before and after pictures, if I'd just done that, they don't encode causality. What happened here? We don't know, right? It's sort of too ambiguous. And so just before and after pictures aren't enough to encode real reasons. So instead, we make movement visible, right? And we use these sort of like effective visual language, right? It's not just like I'm like appending a thing to a list. No, snap, right? It's like actually clicking together. And this is not necessarily an original idea, right? Like comics have done this for ages, right? They use sequences of images, but they also encode like motion using visual language. Now, just because we've done that doesn't mean it's completely unambiguous what is happening, right? Because we're creating programs, and there's sort of different levels of abstraction that I might mean by dragging an element out of the list here. So it might mean that I'm taking the third element concretely, or it might mean that I take the last element, right? And it doesn't really matter how long the list is. Or maybe I'm doing something even more abstract, like taking the nth number of the of the list. And so the solution here is that I'm just sort of like doing this disambiguation through structured interactions, right? So in this case, if like the user pulls out from the side, that means it's like the last element. If I'm pulling down, that means like concretely that I'm using a specific index. And as we saw in the demo, right, I can also even wire up that number and say, no, actually this is a number that I'm using from the program. I'm also using these descriptions, right, which is important. So it's not just the visual or the text, it's the visual and the text together that like help, clarify what's actually happening at each step. And finally, what I'm making visual is like what will happen next, right? So I'm using this sort of visual flow diagram style arrows that show control flow. And we're also flattening time in space. So just like I'm visualizing actions and making them static on the screen, I'm also saying, well, actually the entire execution of your program is like there in front of you, right? I'm sort of like the beginning, the middle, the end, it's all there right in front of you. So runtime versus compile time, no thank you. Step debugging, out of the window, right? We don't need that. If you want to know what's happening at a certain point in time, just go and look. It's right there. Now, this is obviously a very early prototype. There's lots of different things that still need to be explored. But I hope at least I've convinced you a little bit that you can tell stories with pictures to make programs. Thank you.
All right, thanks so much, Marcel. So as we mentioned at the beginning, we're not going to do Q&A after each talk. We're going to get through all the talks, then we'll do a group Q&A at the end. So yeah, thanks again, Marcel. Awesome. So do we have our remote speakers on the line? Great, and I guess we're going to get them set up right now. So we have 2 remote talks today from people who weren't able to make it in person, and we're going to have those 2 talks next up. Our first one is Codeflow Canvas by Michael van der Lisdonk. And we'll just take a minute to get them set up on our stream here.
All right.
Okay, hello, Michael. We can hear you. We don't have your screen showing yet, but there we go. We're almost there.
How can I share my screen now? Because
yes, you can.
Wait a minute. I hear myself as well.
I see, you hear yourself. Is there any way that we can, I guess, yeah, well, for now, I guess you need to hear me. Just, we can hear you and we can see you. So if you start your talk now, we can see you and hear you, and I think that'll work.
No, I don't hear you.
Oh, maybe. Can you hear us now? Hello? Hello? Hey, we can hear you and we can see you, so we're ready when you are for your talk.
All right. I will just put off my headphone. Good morning. This is my presentation about Codeflow Canvas at Live 2024. My name is Michael van der Lisdonk. I'm a freelance software developer focusing on front-end and working on Codeflow Canvas for the last 2 years in my spare time. And I strongly believe that an interactive picture has more than 1,000 lines of code. So, what is Codeflow Canvas? Codeflow Canvas is a generic visual programming system, and it's generic in the sense that different visual programming languages with different implementations can be built on top of it. It can be used together with and in other code bases, which is TypeScript for now. It's extendable and based on a node and wire model. My goals for CodeFlow Canvas are to visually and interactively explain how software algorithms or application logic transform input to output, to build data processing pipelines, and show how data flows through an application. And to use visual programming in existing code bases, so you have less visualizing of code and data structures in your head, and see the impact of changes in a code base live. This is what CodeFlow Canvas looks like, and I will demo it in just a few seconds. These are two implementations based on the same infinite canvas editor. On the left side is a logic computational model in a traditional web environment. All nodes are functions, and the engine calls these functions from JavaScript in the browser. On the right side is a visual live program environment for building a GPU pixel shader. Do you actually see my slides?
Yes.
Oh yeah.
Yes, we see your slides. We do see your slides right now. Yeah.
Yeah, but you don't see my browser.
We're currently no, we don't see your browser. You might need to share maybe your screen or a different window.
Yeah, you're right. I was afraid that this would happen. This is Celsius to Fahrenheit converter implemented as a bidirectional data flow.
Can you wait one moment? We're waiting for the stream to load up.
Excuse me?
Give us 1 second. Sorry, we're waiting for the screen share to work right now. You're sharing your screen?
Okay. Yeah. We've paused it for you to save your resources. It's fine.
Yeah. Do you think you could restart your screen share and just stop it and start it, and then hopefully that'll work?
Is it better? Oh, it stopped.
Yep, we got it. We're good. We can see.
Yeah? All right. This is a Celsius to Fahrenheit converter implemented as a bidirectional data flow. When you type in some degrees, some Celsius degrees, the Fahrenheit gets calculated, and vice versa. When you type in the Fahrenheit, the Celsius gets calculated. And you can use this timeline slider at the bottom to go through all the steps that the program made, inspect what happened, but you also can travel backwards in time. You can also export this flow to TypeScript, and a separate TypeScript program on my computer uses that flow to generate an API together with a Swagger page, and it uses the CodeFlow Canvas runtime engine to execute the flow. And because it's a Swagger page, you can execute the API and see the results at the bottom. I also have a bit of a more complex example, which is the k-means clustering algorithm implemented using CodeFlow Canvas. And the k-means clustering algorithm is an algorithm that groups together similar data points in clusters. Here I use a data set of 50 random data points. I can put this flow on a bigger speed, higher speed, or at full speed, and then it finishes immediately when it hits the first node. You can also inspect this program, and then you see how the clusters converge to the final state visually. Unfortunately for this, I still need some escape hatches, which is implemented using regular JavaScript code. You can give this function a name, and that name you can use in an expression node like this. But in the next example, I will show something that I want to use here as well in the future to hopefully have less or no escape hatches like that. This is the GPU pixel shader that I built. This is of course the famous Mandelbrot factor, which you can also
Hey Michael, we lost your audio
output
for
color, which is output using this node. And that interaction that you just saw.
Hey Michael, can you hear us?
Is handled by the scene position and scene zoom node together with this transformation. This the Mandelbrot calculation itself is I have put in this composition node, which is basically a subflow. But you can also put multiple compositions on the canvas if you need to do that. And subflows themselves can also have compositions in them. Another feature that I want to show is that when you select a node, you can easily replace it with a compatible node and immediately see the effect of that change. And you can do the same with a connection. You can insert a compatible node into a connection. All right. This was almost my demo of my presentation. If you want to play with CodeFlow Canvas yourself, you can do it online. There's no user account or login needed because everything runs in the browser. The code can be found on my GitHub, as well as the presentation. And if you have questions in the future, you can contact me on the Future of Coding Slack or at my email address. That was my presentation. Thanks for watching, and have a lot of fun at the rest of the conference.
Thank you so much for the talk, Michael. That was great.
Thank you. Yep.
Okay. And yeah, please stick around, Michael, for the Q&A at the end of the session. If you have questions for Marcel or Michael, you might want to jot them down so you don't forget, because we have a few more talks coming up before the Q&A. All right. Next up, we have our third speaker, our next remote speaker, Hamish Todd, presenting Snappets. Hamish, are you there? Sorry?
Hello?
Hello, we can hear you now. And we don't see your screen yet, so give us a moment to get that set up.
Mm-hmm.
Oh yeah, could you please do your screen share? Hello.
Hello, sorry.
All good, we've all done it. Could you do your screen share, please?
Okay. Right, yes. And I can hear myself, which is a bit annoying.
Yeah.
Cut myself off.
I think we're going to mute on our end once you start talking, so we can hear you.
Okay, brilliant.
We can see
so I guess I'm just
screen.
going to go and ahead and give my talk.
Yes, please.
And you have no way to tell me to stop. I hope that you... Wait, 1 second. Can you also see...
All right, take it away.
Can you see me? No?
Hello,
Oh,
we
dear.
can hear you, yeah. Go ahead.
And see me?
Yes. We actually
Can you see me?
We can see you, and I think we're very close to having the screen share working. We see. Oh, great. Oh, yeah, we're in good shape. Yeah, we're good. We're good. Let's go.
So you can see both myself and
we can
my
see you.
video
We can
stream.
see your presentation. Yep.
No, but can you see me?
Yes. We can see.
Brilliant.
Sorry,
Okay.
we can see everything you want us to see.
All right, here we go. So, the Snap-it is a virtual reality animation system based on projective geometric algebra. Here's an aspiration for you all, a very lofty goal. We want a live programming interface that is so visual that non-programmers can learn something from watching it. So, even if you could even have a small child aspirationally looking at you programming. And here's a remark for you all. Brett Victor, I think we all love Brett Victor. And here is Brett Victor's laptop for a while. And if Brett Victor thinks that geometric algebra is a cool enough thing to put on his laptop, then you should probably pay attention to it. That's something that I decided on a while ago. So yes, what can geometric algebra offer visual programming? That's what I want to sell to you all. I'll first show you a recorded demo of Snap-it, which was at some point live, I promise. I'll then say why hand gestures are these things called dual quaternions. So they're vitally important if we are thinking about live programming using virtual reality. I'm going to talk about how the geometric product makes code simpler. And I'm going to talk about how geometric algebra allows you to have multiple pictures in the same picture. So first of all, we've got a demo. And introduce everybody to Mr. Alligator. Say hello to Mr. Alligator, everyone. Hey, everyone, nice to meet you. How are you feeling today, Mr. Alligator?
Textualize the use of a new technology, otherwise it just seems a bit weird.
Well, we don't want you to seem weird, do we, Mr. Alligator? So we're going to contextualize you. You're right.
I'm always right, Hamish.
And second part of that, where I show you how to make things in Snap-it. Now let's say that I want to make an animation of a thing with an eye that can look around. So here's my eye. It's very easy to make. It's just, I've got a paint button. So I can add a pupil to that eye. And what we want is to make this eye follow this point around. That'll be a fun thing to see. So how are we going to do that? Well, number one is going to be telling the computer in some sense where the eye is. So I'm going to put that here, and you'll see that I'm doing this sort of Street Fighter Tai Chi hyperloop pose. There's a very good reason for that. All right, and now I'm going to make, this is a So we've got the point where the eye is, we've got the point very far away where the eye is looking, and now I'm going to do this with my hand, and I'm going to press it, and I've made this sort of line, and I'm going to press the button, which makes it so that you can see this flat flashing line here, and now if I let go, we've got a line that is the line that connects that point we made back there with the point that's over here. If I grab that point over there, you see this line moving. All right, let's say that is approximately the quote-unquote tracking this point here. So I'm going to do, make another line, and here we go. We've now got two lines, and the claim is that the eye should have the pose that takes it from looking in this direction to looking in that direction. So I'm going to grab the eye now. I'm going to turn it in the way that I want it to go. Fairly intuitive thing to do. Now I press my snap button, and it recognizes it's making this line flash and this line flash. And here's the rotation that I want, so I let go, and now we've got the eye following a point. That was freaking difficult. Yeah. Okay, let's make it a bit more sort of cartoony and fun. I'm going to make it a pirate, because that explains why it's only got the one eye. I've got a pirate. I'm going to have some faster tools for making this kind of thing pretty soon. All right, and we're going to have an eye patch. There we go. And we're going to have let's have him have a little tongue sticking out his mouth. He's blowing the raspberry at us. Let's make it so that he's looking at something. So we're going to make a fish. This is my little tribute to Brett Victor, whose idea this significantly is. We've got a fish. And let's have an eye on the fish. That makes it look more cartoony and fun. We've got pupil for it. So here's our fish. We want the pirate to be looking at the fish. So let's make another point with our Street Fighter Hadoken pose. Another point, and this is the point that it's been moved to. And now I grab this point, I press my snap button, and it knows what to do. So now, look, we've got a pirate that is following this fish. It doesn't look great, but thank you very much. Okay, there was Snap It. Now I'll say a little bit about that. So, hand gestures are dual quaternions. What on earth is a dual quaternion? Well, a dual quaternion is a rotation or a translation. Now you see why I needed to berate poor Josh about being on the video. It's a rotation, it's a translation, or it's a screw motion. Every hand motion you've ever made when you pick up a fork or move a mouse or tilt your head or whatever, that is a dual quaternion. Dual quaternions have an axis as well. Here you're seeing me show a purple dual quaternion turned into a rotation and translation part. So it's always a screw motion in general. A rigid motion is another word for this. And dual quaternions are much more visualizable than matrices. That's why you folks, I claim, should pay attention to geometric algebra. The dual quaternion gives you the axis. It's right in there. So, for example, these 3 floats within the 8 floats of a dual quaternion tell you the direction, loosely, that the axis is going in. Whereas getting that same information out of a matrix, well, you can do it, but it's very hard. Okay. Here's another reason that you should care about geometric algebra. So there's this thing called the geometric product in geometric algebra, and it makes it so that you can solve lots of different problems in the same way. Loosely speaking, the geometric product is transform composition, but here's an example of that. So you remember this part of the video. I've set the line of sight for the eye and the line of sight that we want the eye to have, and I've sort of turned the eye using my hand, and we want the program Snappets has given us this yellow rotation here. That rotation is of course a dual quaternion, and it so happens that if we call these 2 lines, line start and line end, if you take their geometric product, you get loosely speaking, a transformation from the start towards the end. Okay, it's a little tiny bit more complicated than that, but not in a way that I need to get into. And it might sound strange to say we're multiplying 2 lines together, but that's what you do in geometric algebra. You can multiply a plane by a point or a line by a volume. You can do all of that. Here's a more sophisticated usage of the geometric product. So here's 2 video gamey type situations. We've got a shooter where you're defending yourself from a sniper, and you've got somebody who's about to land on some snow on a snowboard. We might want the collision point of this line of sight and this shield that the player has. We might want the place where the snowboard is about to meet the snow. And we might want angles for both, so we're going to turn them both into platonic idealized objects that we're then going to solve problems involving. And it turns out that a thing that's very useful to know about if you're going to solve these problems is a rotoreflection. So what's a rotoreflection? It's very simple. It's just more or less this, right? It's a reflection followed by a rotation. It's somewhere in between a planar reflection and a point reflection. You may or may not have seen a point reflection at any point in your life, but this is a point reflection, and if you imagine, it's defined by the fact that if you move from this fingertip towards this special point, and then out the other end by the same distance, you get to the same fingertip on the other hand. So planar reflection, point reflection, rotoreflection. It's in between the 2 of them. And a rotoreflection is interestingly defined by both a point, a specific point, and a specific plane. And in geometric algebra, when you can represent a rotoreflection as a matrix, but what we do is we represent it as a point literally added to a plane, which is Again, strange, but that's what we do. But, you know, sort of better than a matrix because both things are visualizable. Anyway, so let's try and solve this problem. The way we do it is that we consider a 180-degree turn around that line followed by reflection in that plane, and that will give us a rotoreflection. And it so happens that the point of that rotoreflection will be the point where this thing is meeting, the point where this line is meeting this plane defined by the shield. So we've got a rotoreflection defined by these two objects, and it's got a plane in it as well. Maybe we want the angle because we're thinking about, okay, if the bullet deflects off at a certain angle, we want to put a dent or something. And it so happens that you can get this angle by just extracting out this point and this plane part and looking at their sort of amounts, and then taking the arc tangent of that ratio. Relatively simple thing to do. A total of 3 lines of code, and we've got some very, very useful information. And that's how you extract the amounts of a point or a plane inside of a rotoreflection. So last part, geometric algebra lets you put multiple pictures in the same picture. And this is something that I think is probably the most important part, but it's the most abstract part. So here's Ken Perlin's Chalk Talk, which is a wonderful visual programming system. It's got multiple spaces, which is a very, very good idea. You want to have this kind of picture, and you want to have relations between the pictures. However, my claim is that there should be as few different spaces as possible if you're thinking about trying to reduce the complexity of something. So to hammer that home, here's a project that I was working on where I started out with 2 spaces, and it was never really satisfactory to me in this situation. And with some iteration, I got it down to 1 space, and I was quite proud of that. And you can play around with this thing there. Here's a link from the previous talk. Comics allow the sort of comic view of the world. Well, comic type explanation. You're going from one picture to another. Perfectly good thing to do. But you don't want to do it unnecessarily. In some sense, you want to put a lot of information onto one picture if you can. That's my claim. And another part of my claim is that vectors. Okay, you all you all know about vectors. Vectors are the thing that we teach to students, and they encourage people to break out things up into lots of different spaces when they don't need to. There's history behind that. You can look up these folks. Anyway, no time to get into that. So a vector can represent a rotation. All right, you can wonder about that rotation. A vector might also be a translation. A vector might also be a point, which is subtly different from a translation. And a vector might be a plane. It might be the normal sticking out of a plane. And all of these different things, I mean, if you had a bunch of vectors and you were trying to solve a problem involving them, you need to know which kind that you're dealing with. And so it's a bit nasty to try to put multiple different kinds of vector into one picture. And so if you apply the sort of Chalk Talk view to this, you end up with a picture like this, which is awful, because these things should be viewed in the same space, all right? That's just the way it should be, and geometric algebra lets you do this because it says a plane is a plane, a point is a point, a rotation is a rotation, a translation is a translation. These are all different kinds of objects, and we deal with them in different ways. Okay, you can kind of turn them into 3 floats if you really need, if you want, for the sake of efficiency, but yeah, it stops you from losing sight of the actual geometric nature of the thing. All right, and if you're interested in this question of multiple pictures in the same picture, or trying to reduce your spaces, so I recommend Brett Victor's Up and Down the Ladder of Abstraction, and I also gave a presentation called Unintuitive Action at a Distance. And if you really like listening to me talk about geometric algebra, here's 2 presentations you can find. 1 second. You just need to type in Hamish Todd GDC into YouTube, and you'll find them. I've actually developed a live programming interface for giving these presentations, which you can play with yourself at this link, but it is very janky, of course. It was mostly designed for those 2 presentations. And so this has been Snappets. You can contact me via these links, and I'm grateful to so many people who have helped me make this work what it is. Yes, I also do fortnightly streams. So thank you all very, very much for listening.
Thank you, Hamish. I don't know if you heard the applause, but great talk.
I heard one little flapping.
Okay, there was a lot of clapping. Don't worry. Thank you. And,
Wonderful.
Please stick around for the.
And thank you so much, Josh, for allowing me to come in this sense while I'm financially constrained.
Totally. Thank you again. Please stick around for the Q&A at the end of the session. All right. Now we're back to in-person talks. Next up, we have Alex Worth and Ivan Reese presenting Inkling.
Check, check. Cool, cool. Check 2, good. Yeah, and I wouldn't mind having power.
Okay.
Would you mind
try not to
passing
trip
me?
on it again.
Thank you. All right. That's going to be me. And then HDMI.
Transitions are going pretty well, so I will allow you an extra 45 plus seconds.
Awesome. You won't need them.
Which you've taken 7 of those seconds by saying that.
And you've taken 7 more. No, I haven't started your time. You're okay.
And I'm just going to do a sound check. Let's see if we got sound.
Hello?
Yeah. Okay, cool. And then to go to QuickTime. Jordy Greep, former singer-guitarist from Black Midi. Just the band broke up and he put out a solo thing. It's really good.
I'm also not hip enough to know what he's talking about.
Put it on later, but don't put it on around your kids.
4/3, please. Just waiting for 4/3. Let's see.
Do we need to begin?
Okay, cool. Well, weird. All right. Yeah, you ready, Alex?
Do you want to hit the full screen thing or?
No, because I need to be able to hit.
Okay.
Actually, you know what? Yeah, let's see if I do this.
Hello, everyone. We have an exciting prototype to share with you today. But our prototype is laboratory-grade computer science. It is not safe to give software of this nature a live demonstration. Listen carefully while I outline the 3 safety precautions of this academic computer science presentation. Number 1, for safety, Alex Worth will do all of the demos live.
Alex Worth, everybody.
Number 2, for safety, Marcel Gutols will blend in with the audience. And number 3, for safety, Ivan Reese, me, will be pre-recorded. And Ivan Reese, me, will wear high visibility flagging tape. What? I put it in your backpack for safety. Today, we are excited to present Inkling. We work at Ink and Switch. We work on ink. We want a notebook. A notebook is a book, one of the technologies of all time. A notebook is blank. You may fill it with your own ideas. It is a physical space, one page after another, a structure that gives shape to your thoughts. tactile, malleable. But you also love the computer. I don't need to tell this room of people why you love the computer. Nobody loves the computer as much as the people in this room. But the computer forces your thoughts through an aperture the breadth of a mouse cursor, tapping buttons one by one. That is not how we want to feel when we are thinking, because feeling is reality. We want tools that we can wrap our hands around, ones that let us scribble and sketch. We want a dynamic notebook. In Inkling, the pen draws. Erase by pressing 2 fingers to the screen whilst drawing. Draw another ink stroke, then tap the ink splat in the corner to enter meta mode. Tap the ink stroke to add handles. In meta mode, drawing creates a gizmo, 2 connected handles with a special sigil at the center. Handles want to snap together. Tap the sigil to impose a length constraint. Tap again to constrain both length and angle. And once more to constrain just the angle. Draw a second gizmo, and then draw a wire to connect their sigils, making their lengths and angles equal. Now draw a wire into the nothingness, and 2 properties appear, each of which can produce a numeric value. Tickle the value with your finger, and the gizmo reacts. Some numbers are light and free to change. Other numbers are dark and must keep the value you give them. Tapping a number toggles this behavior, and every connected gizmo and number changes in kind. And from the nothingness, tap the pen to create a linear equation. A simple tool for powerful mathematic manipulation. Math, wires, gizmos, handles, and ink. We started by drawing ink strokes, then drawing constraining gizmos onto those strokes, and drawing mathematical relationships for those constraints. Inkling has a smooth progression from doodling to modeling. At every step, you have something useful and playful. The focus on physicality and drawing means you often make a thing just by feeling your way through the possibility space. The tool doesn't work at the speed of thought because you're not even thinking. You're just feeling. It's faster. Feeling is reality. And Inkling doesn't feel like anything. Here's how we achieved that feeling.
So everything you see in the system is either represented as variables or constraints. And when you mess around with stuff with your fingers, what we're doing is we're using the gradient descent solver to pick new values for the variables to make the constraints happy again. And so, but it's not trivial to create this kind of feeling that the material feeling that we have in Inkling. And so I'm going to talk about 3 of the techniques that we use in the system to make this work. One of them we call propagation of knowns. And so, thank you. I'm going to illustrate this with a little example. Hang on. So consider this little construction of 2 gizmos that are both angle and length locked. and what happens when I put my finger here on this handle and move it around. So normally with constraint solving, you'd be doing all kinds of stuff. But here, we're doing something much simpler. What's going on is that when I put my finger on this handle in the bottom, the system knows that I want it to be right there, right? And because the position of the second handle is fully determined by the position of that finger that's down, I'm not even using constraint solving at all. Same thing goes for the third handle. This is a kind of data flow, but you can actually use it from any direction, right? So right now, the positions of the two handles on the outside are being determined by the position of the handle in the middle, so on and so forth. Okay. Another neat idea that we use here is something that we call unification of variables. And that is to say that we don't use equality as a constraint. And so here's an example to illustrate that. I have two gizmos, and I'm going to pull out their angles and lengths. Let's put the angles together and the lengths together here, and show you the values. Okay, so right now, if I just manipulate these gizmos, you see that the values of the lengths and angles are completely independent from each other. But let's see what happens when I snap these handles together. What you're seeing here is two overlapping gizmos. That's why you have this arrow going on both sides. And the interesting thing that's happening is that their length variables and angle variables have been unified together to reduce the number of dimensions that the solver has to worry about. And so now if I scrub the length of one of them, you can see that I'm actually scrubbing the other length because that's the same variable. The same thing is happening with the angle, even though they're 180 degrees apart. This is like just a different kind of equality. All right. Yet another idea that we're employing here is what we call clustering. It's similar to what people in the video game industry do. Yeah, with simulation islands in their physics engines. So here I have two chains of gizmos that I can manipulate independently, and because these constraints and the variables have no overlap with each other, we can actually hand them off to the solver to solve separately, which improves the efficiency of the thing and also enables the solver to converge on a solution that it sometimes would otherwise not be able to converge on.
Feeling is reality. And Inkling doesn't feel like anything. Here's how we achieved that feeling.
So one of the things we were thinking a lot about at the beginning of this project is user interfaces for drawing. So there's a couple of ways that that thinking sort of manifests in this project. I'm going to really quickly talk about them. Some of the things we wanted are like an app that you could use with both hands all the time, all fingers, all over the screen. You could have multiple pens going on the screen or multiple people sitting around the same iPad all playing. And so the way that we designed the interface is that, oh shoot, what was the thing? Yeah, so the constraints and the interface have this like interplay between them, right? So if I have this gizmo, do you want to go to a, you don't have to show it.
Yeah, I could show a gizmo.
Yeah, if you have a gizmo with a locked length and you put your finger on one end and pull, the gizmo's gonna go with your finger. But what happens if you put your finger on both ends and pull them apart? What should happen? Should the gizmo kind of go in the middle and keep its length or stick with one finger or the other? We think the only thing that makes sense in this case is that the gizmo should obey the fingers because that's the input that you're giving it. So that preservation of user intent is really big. Another thing that was really important for the design is that we don't have any absolute coordinates. There's no X, Y positions. You never see that kind of stuff. We have numbers for lengths and angles, and lengths are good because they feel kind of relative and you can build your own coordinate spaces out of that. But angles suck because there's an absolute 0 degree pointing to the right. And you could use, you know, a linear equation to try and change that frame of reference angle, but that doesn't feel very good. And I asked Ivan what he would do about that. And do you know what he told me? Do you know what Ivan told me? He told me, algebra is an illusion of the mind's eye. Did you just tell me to go F myself? So yeah, this is something we hope to explore more in future work. And yeah.
Here are some further explorations that Inkling has encouraged us to take. With a handle that leaves a trail of ink, you could visualize the motion of your models. You could take one of those handles and make it go everywhere within the range allowed by its constraints to produce elaborate curves or even filled regions. What we built is but a prototype of a constraint solver and a user interface. Yes, this prototype is not the notebook we seek. There are no pages in sequence, no book-like structure for your thoughts. But what Inkling gives us is better than thinking. Inkling gave us a feeling. It is our new reality. We have all been changed by it. All the technology we created is in support of that feeling. Feeling is reality.
Yeah, so if you want to play with Inkling, there's a GitHub repo. You can download it on your computer.
Nobody loves the computer as much as the people in this room. But the computer is not the point. The code is not the point. The point is how this feels. Feeling is reality. Feeling is reality. Feeling is feeling is reality. Is feeling is reality. Is reality. Is reality.
All right, thank you, Ivan and Alex. We have a wonderful variety of presentations here today. Oop, that was just a choice. Okay. Next up, we have our last talk of this session. We have Lou Wilson presenting Roost.
Right. Hello. Hello. Is this thing on? Is this thing on? Can I just do an audio test first so I can know if it's broken now rather than in like 7.5 minutes? Okay. Oh, thank you. I don't hear anything coming.
Yeah, I think you have to change the output.
All right, let's see. I'm on HDMI to USB. Let's try again. Okay, yeah, you can start my time now. Yeah, so my name is Lou, and yeah, you know what, like I do a lot of talks, but I still get really nervous before every single talk, you know? Like I think that's part of why I enjoy them so much, like in like demos, but I still feel like, anyway, so I'm part of this tentpole collective, and the name of my presentation today is Roost. Unblocking creation with friends. And so part one is about creation, or more specifically, creative work. And so for me, creative work is when you use your imagination to make something. And it could be anything. It could be baking a cake, writing something, programming a program, like doing a presentation, making a song. And I think like when we're being creative, we have all these blockers, right, that get in our way. Like, think about like what stopped you from doing creative work, which is very important work, right? It could be that you've just run out of paint, right? So you can't do your painting. Or it could be that you don't know how to use this programming language, or you feel too nervous to go up on stage. Yeah, there it is. It's a slight delay. I'll factor that in, right? Funnily enough, I experienced all of these today. And, you know, but there are so many different blockers that we could feel, right? You could probably think of some of your own. And we could take a look at these, and I think we could, like, map them out, right? We could map them into different categories. We could, like, categorize them. We could put them in a scale. And I'm just starting my timer now. Boom. So I think we could map them out like this, right? We could say some of them are, I think some of them are intellectual blockers and some of them are emotional blockers. It doesn't mean anything. I just made up these terms, right? It doesn't mean anything. But I'm going to tell you what it means in a second. So let's color code them. Let's color code them. Look, I've color coded them all, and we could like split them all out. So here we have intellectual blockers at the bottom. And for me, this is like when you can't figure out how to do something. You don't have the resources, materials, or the brain power to figure out how to make the thing you want to make. And emotional blockers, I think they're really different. It's when you know how to figure out something, but your emotions get in the way, right? You feel too distracted or shy or nervous or something else. And I think live coding, it's got too many syllables, and I have 14 minutes. Live coding is great for tackling many of these creative blockers, right? So like this is like the canonical example of using live coding for being creative, doing creative work, right? Which Joshua said earlier. If you're on catch-up, go watch it. And Untangled does the same sort of thing. It helps you to figure out what you're doing when you're being creative. This is Strudel by Felix Roost. It's a live programming tool, and it visualizes the different parts of your program that are running. It helps you figure out what's going on in your program. But I think we have this huge bias towards solving intellectual blockers. I think we often ignore, or at least we're not explicit about, emotional blockers, in my opinion. So, you know, like we're so focused on tools for thought. It's all about like the thinking, sometimes the feeling, like the last talk. But usually it's about tools for thought, right? Like we have this huge, I think we have this huge bias towards the bicycle for the mind, right? Everyone's trying to make the bicycle for the mind. And I think that's great, but like, I think we need the bicycle for the heart. No, that's too cheesy. I would never. Anyway, so you know, there are lots of tools out there. They're not live coding tools, but there are tools out there that try to help you get over emotional blockers, like TL Draw, which uses sloppiness to make you stop trying to be perfect and just make stuff, right? And there's Sunspiel, right, which is a video game, but people don't use it as a video game. They use it as an art tool. People draw in it. Like, why would they do that? Why would they draw in a video game and not something like Photoshop? Why? Like, that should make us ask these questions when we see something strange like this. And the reason is people often explain it. And you just read the comments. They say, you know, it's something about drawing and creating in an environment of play. And it's about the expectations. You're not expected to draw something good with Sunspiel. So you feel more free to draw something good, right? Electroplankton is this musical instrument that you do not control. You don't control it. You just influence it. So if it makes something bad, it's not your fault. There are no emotional blockers. The responsibility is taken away from you. And the automaton is this toy musical instrument. But the weird thing about it, despite being a toy, it's actually really hard to play. And that's very like emotionally and creatively freeing because there's no expectations. So like, hey, look, that's Haley. Haley, okay, Haley, can you record a sound? Perfect. Okay, and go back. I'm going to show you one more time.
And next up,
listen to this beautiful,
Haley. Okay, Haley,
beautiful voice. You come in at the right time, yeah.
Perfect. Okay, and go back.
And the algorithm community has this culture of embracing mistakes and encouraging newcomers, right? And so, like in live programming tools like Strudel and Tidal Cycles, the community is one of its features, right? That's one of its features of this live programming tool is the community. So, right, part 2, Roost. Orion, where are you? You need to come up. Great. So I thought, could I try to, like as a thought experiment, try to combine many of these strengths together into one tool? And what's happened is that it's made something completely ridiculous, right? Yeah, you just hold this, like just roughly here. No, here. Yeah, that's it. Okay, so when you load a Roost, you're presented with this, yeah, you're doing great. You're presented with this mantra, and it says normalize sharing scrappy fiddles. And what that means is that when someone like makes something sort of like that they're a bit shy about, that should be normal. It's not good, it's not bad, it's just normal, right? It's part of the culture of this. And when you click it, thanks. And when you click on the screen, did you see that circle? Just appear from the, I'm gonna do it again, right? Watch, I click on the screen and the circle appears, and it actually appears somewhere random. Right, okay, I promise it's random, right? Okay. So I didn't make this. A Roost made that little shape, okay? And that's part of the feeling that it's creating, is that you're not in control. A Roost is in control, a Roost made it, right? And I can move it around. This is like a little simulation. I can zoom in, I can drag the camera like this, and it should feel like I'm interacting, or influencing a physical simulation, right? And I can click on this and click again somewhere else, and it makes this other shape that I can also move around. And let's hope this works. If I click it, I can record something. No, I cannot. Right, let's try again. Let's see. 1. Oh, yeah, that worked too much. Yeah, I think down a bit. Yeah, okay, great. So I've recorded this sound. And I can keep recording more sounds. 2, right? And what I can do is I can change the starting point of this sound. 2. So I can make it start later, or I can make it start earlier. But really importantly, it's really hard. I can't see anything. I've been intentionally, like, there's really bad granularity of feedback here, right? I can't see exactly where the sound wave is, and that's on purpose. So you stop fussing over it. It's just, I'll just guess, right? Around like this. What I can also do is move them up and down.
1,
2,
1, 2.
And I can change the pitch.
1.
And this does a couple of things. Like, partly it sounds funny and silly. Like I could go like this. I could go right, and then I've sort of made a musical instrument. A little bit further away. Yeah. And delete that. And so partly it sounds silly, so it's like a way of like loosening you up. It's like an icebreaker, right? But partly it sort of stops you from fiddling and moving things around, because like every time you move a sound, there's a risk that you accidentally mess up its pitch. So if I create another one, 3. 3. If I move it over here, there's a chance that it messes up the pitch. So I don't want to do that. This is encouraging you to just leave it alone. Don't move your sounds. Leave them where they are. It's okay to be messy. And you see this? I can delete sounds that I don't want. The thing is, some of them are too important. So like, I can't delete the creation block. It comes back, right? So if I delete this, it'll just appear again. Like, even if I zoom out, even if I zoom out a long way, like if I delete it there, it's over here, right? Yeah, and you just saw that. Don't worry about zooming out too far. You can't get lost, right? You just like, you can zoom all the way in and then all the way out. Yeah, whatever. It's just a gimmick. And so this one, it lets you connect things together. And this lets you create more interesting sounds, because you can play 2 sounds on the same beat, right? This connects them, and it's 2 sounds on the same beat. 3. And you can connect multiple, like in a chain. 2. Right? Or you can do like stuff like this. 3. Right? And what you can do is you can click this button here. Instead of making it fire on the same beat, you make it fire 1 beat later. So watch this.
1,
2. And you can start to create like a chain, right?
1, 2, 3.
And then you can like make a loop.
1, 2, 3. 1, 2, 3.
So this is like a really simple way.
1, 2, 3.
Oh shit, that's going to be a bad one. All right.
1, 2, 3. 3. 1.
This is like a really simple way of making simple beats.
1, 2, 3. 1, 2, 3. 1, 2, 3.
Right?
1, 2, 3. 1, 2, 3. 1, 2, 3.
So,
1.
So remember, this makes it fire 1 beat later. If I click it again, listen, if I click it again, it makes it fire 1 beat earlier. This was really hard to program, right? So like I'm gonna press it, and you're gonna hear 1, and then you'll hear 2, but like in the past, right?
1.
Did you hear the 2? No?
1.
We can't hear the past, right? So what you have to do is like you send like a signal into the future, which sends it to the past, which ends up being the present.
2. 1.
Or you could like flip it and send it to the past, which then comes back to the future.
2.
Right? You following, right? Right. Very simple. So there's one last thing. You can change the color of a wire, and it changes the color of the pulse that passes through, like this. And like so, red pulses only don't pass through wires of different colors. And you can use this as a way of like doing control flow. And the fun thing is that you can like combine different colors together to make patterns like this, right? And you can like mix colors. Oh no, wait. Let's see. This needs to be white, and this I'll do blue. We combine like blue and green together, and you get different. You invent new colors, right? And this. Thank you. You've done very well there. You can leave that now. So you can use this color system to make all sorts of logic gates and things, and people in the community have built amazing things. Like this is a bit adder. Here's a NOT gate using another feature. So this is Turing complete. Stop asking me about it, right? But the more interesting thing for me is that this is Ivan Reis made this song using Roost. And instead of programming really complicated things, the easiest thing to do is just to perform it, right? You can see he's like clicking different parts of this instrument he's made. And I'm really, really pleased that lots of people have made different music, well, they've live programmed musical instruments for themselves to play and perform. Here's one from Avon, and each one has like an element of. I was worried that all songs made with Roost would sound the same, but they all have that person's personality in them. Here's one by Alex McLean from the live programming world, using samples. But some people like Elliot Evans use what they have around them, like typing and tapping things to make different kinds of noises. This is one of my favorites. This is non-nullish. And I think she said her boyfriend was like using a hairdryer or something, and she's used it to make like a nice little song. I'm gonna hurry up. Right, so I was really pleased that so many different people used Roost. One of those people was Shane Crowley, who wrote up their experience of trying Roost in a blog post. And I'm really, really pleased like the effect it had on them. They said that their discovery of Roost led to a sudden burst of music making, not just in Roost, but in other things as well. It got them back to a place where they could make something. So that for me was really, I was really pleased to see that. Also, reviewer C said they had the same thing happen to them. They said they've been blocked on composition of music, even though they do a lot of music themselves, and they found that making music with Roost was quite freeing. So this for me was, I was really happy to see that. It also changed me a lot. I used to be very shy about making and sharing music, and it completely changed that for me. It also changed the kind of music that I make with other instruments and tools. Like, here's one I made last night in the hotel. I think you heard it a bit earlier. It's nothing really. Like, so this is using Flock by Damien Silvani. So my hope is that, this is just a very silly, ridiculous thought experiment. My hope is that it starts a conversation about emotional blockers. We don't just want to help people think better. We want to help people to feel better. Not like feel good. Not feel good. When I say feel better, I don't think it's enough that a tool feels good. I know lots of people want their tool to feel good to use, but feeling good is not the same as feeling free from emotional blockers. getting through a blocker can be uncomfortable, it can be painful. And I think we should make tools that help people do that, because that's sometimes what we want. The most surprising thing to me was seeing that the most important part of our Roost was not anything I did, it was from the community. And that was really surprising and enlightening for me, and I'm still learning what that means. Like I said, I put out this mantra, and people have really run with it. It's gone a bit crazy. Like it's getting a little bit, it's getting a little bit out of hand, right? It's sort of, and I think it's really important that when we build tools, it's not just about the tool. It's about building a community, or it's about like making room for community to grow. Because there's no point doing any of this in isolation. So like this is nothing to do with our Roost, but our Roost led me to this point. Right? This is a song that has been made by about 10 to 15 people over the course of 2 days, all collaborating in this shared environment with Strudel and Hydra and its flock. And a lot of these people are sort of repeating this mantra of normalize sharing scrappy fiddles. And so I encourage you, as people building tools or building things, don't do it in isolation. You're going to learn so much more by sharing your work, making it open, and getting other people involved. That's the end. Thank you.
All right, thanks so much, Lou. Could we have all the speakers who spoke in this session come up to the front? Okay, so and we have our remote speakers too. Amazing. Oh man, the caution tape. Okay, so we have 15 minutes for Q&A to wrap out this session, and the way it's going to work is we're going to have Q&A with all the speakers. If you have questions that apply to more than one talk and might highlight some commonalities or interesting differences or themes across the talks, I think those questions will be more interesting. And feel free to direct your question at specific people. We won't have time for like everyone to answer every question, but hopefully we'll get a little bit of crosstalk going. So I'm going to start moderator's privilege with the first question, which is you've all shown some really interesting techniques for visualizing stuff, behavior, data. There's been a lot of ideas about visualizing time across many of the talks. I was curious, do any of you have thoughts on what's something that you found particularly difficult to visualize? And maybe you cracked it and found a good way for it, or maybe you haven't figured it out yet. Where does visualizing behavior get tricky?
Yeah, so one thing that we struggle with over and over and over again in these projects is wanting to visualize the code or whatever it is that is producing a behavior in the exact same canvas, in the exact same space on that canvas as the thing that the behavior is affecting. And so we reach for things like layers, or maybe like this thing is like floating up in the atmosphere over this stuff on the ground, or there's like wires or probes or that kind of thing. It's really hard because there's so much you can do with visual expression of the code, but a lot of it depends on like sharing a meaning between the code and the thing you're manipulating. And so that's just like a super recurring perennial challenge.
Yeah, to add to that, I think a lot of the stuff in our system, for instance, the layout of how you show the meta stuff on top of the concrete stuff is tricky, right? Because often you'll have a model that you can do a good layout for a static version of the model, and as soon as you start playing with it, there's stuff behind the meta stuff that you drew, and we don't have a good solution for that yet, other than like maybe we should go bootstrappy on this and actually move things around via constraints, for instance, in Inkling too. I don't know, but I haven't seen really great solutions that scale.
I have you folks can hear me again?
Yeah.
Yes.
Cool. So this is going to be an answer that's on brand for me. So there's different kinds of geometric algebra, and one of the kinds that you can read about is called conformal geometric algebra, and that allows you to do reflections in spheres as well as reflections in planes. And one thing that I've struggled to visualize for the last 2 years, and I'm only just managed to get my fingers on it is something called a hyper-ideal reflection, which is, in a meaningful sense, you can reflect in a sphere. And an example of that would be like, you look at the back of the spoon, you see a certain kind of reflection, so you distort it. That's a sphere reflection. Reflection in a hyper-ideal sphere is a reflection in a sphere that is, in a surprisingly meaningful sense, it's got a radius that's bigger than infinity. It's a pain, but it's very interesting.
I think if I heard the words he was saying, I would still understand it about the same amount, but yeah.
I was just going to say, I always find it hardest to represent visually just abstract things. My other project, CellPond, does a really bad job at that. So it was cool to see subsequently sort of have a go at that, which was really cool. Yeah.
Oh, I have a question following from that.
Come grab this, Peter. Yeah.
Okay, so I wanted to contrast or ask maybe Marcel and Hamish to talk a bit about, like, Hamish was like, put everything in one place, and Marcel was like, that's not how people think or talk. Can you maybe like play on that a bit?
Right, yeah. I mean, I think in my prototype, at least, the iterations were still sort of like displayed in the same place. But like I've been thinking a little bit about maybe even like getting rid of that, right? So like actually spreading out like iterations in time out in space. So like there's literally everything is always visible, and there's no like need for interaction other than like, no more dots. Right, no more dots. Just moving your head to see different things in space. Yeah.
Let me make the. I just need to mute myself, sorry. Let me make the debate a bit boring and just say that I fully agree with everything that Marcel was saying, because sometimes you really do need to have separate visualizations because the spaces really are very different. Brett Victor, in some sense, does this pretty well in drawing dynamic visualizations. Yeah, sometimes things are just qualitatively different and you just need things separately. So Marcel is doing the right thing. But what I'd say is that if you have two kinds of data, this is a bit of an obvious statement. If you've got two kinds of data that ought to be compared with one another, you should put them in a place such that they can very easily be compared. And that's next to each other.
Let's go to another question.
No, on top of each other.
I have a question for Lou, and I have a question for Alex and Ivan. So for Lou, I thank you for the presentation. I'm curious if you have any thoughts about how to do that, but for writing. I struggle personally with it a lot, so I'm just curious about that.
I mean, there are some really interesting tools out there for writing which help you get over emotional blockers. I wish I could have squeezed them in, but there's like there are some tools that make your writing turn invisible. Like after you can like see your words like fade away, and what it does is it stops you worrying about like the previous sentence you've written, right? Like there are some which like require you to output a certain number of characters each minute. You know, like so like I think there are some like really interesting ideas out there that we could probably take further. You know, I don't know about like editing and things, like editing and version control of writing. I haven't seen many experiments. So if anyone knows more about writing in that sense, that'd be cool to hear. Yeah, thanks.
And for Ivan and Alex, I'm just curious if you could talk a little bit about like what the iterations were like to get sort of a grammar of interaction that was simple enough that you could get it that expressive, but without any extra stuff.
This is a question for Marcel too, who's also in this project.
One thing I can say on the iteration side was the design of the gizmo and the sigil at the center and that little, Alex always calls it a tribal tattoo of the arrow with the little kind of, you know, semicircles on either side. That went through so many different iterations. There was a version that looked like a big crossbow where there was this big arc coming out of one side when we were thinking of a gizmo not as being a sort of a bidirectional thing, but having like a point and then like a vector kind of thing. There were versions that used circles much more heavily. There was a lot of iteration on the visual language of it. If you saw the slides, right? During the presentation, the slides I was flipping through, you saw those.
Do we have any questions for Michael? who we haven't heard from yet in the Q&A? CodeFlow Canvas? I have a question, Michael, I'm curious, how do you think about visualizing time in your system? So we saw a few different takes on visualizing time today, and in yours, I know we saw like a time slider where you could, I believe, scrub time back and forth and see values flowing. I'm curious how you arrived at that approach and what you've learned from visualizing time progression in your system in that way.
I hope I don't hear myself echoing now.
We hear you, yeah. You might need to mute yourself or take your headphones off while you talk, but we hear you.
Yeah, just put my headphones on while I talk. Well, I've learned a couple of things on dealing with time. With that, for example, with that K-means clustering algorithm that I showed. In another version of it, when I used the timeline slider, then I could see. That's really hard. I hear myself really hear myself talk. It's very irritating. What helps me, well, with the timeline slider, it helps me debugging the structures of the code that is being generated. But I should. It's better to show it than to talk about it.
Got it. Makes sense. Yeah, and we can, if people have more for you in the chat too, that might be an easier way for the remote. Yeah, we have time for Taylor.
Yeah. So a lot of you guys talked about like matrices and linear algebra today, and I know nothing about math or the United Kingdom. So what is a Brit vector? A what? A Brit vector? You guys keep like
Get off the stage.
You're the enforcer, Josh.
Any less trolly
Very
questions?
good.
Looks like we got some. Or you had your hand up in the back. Yeah.
Thank you for some wonderful talks and for the wonderful work that you're doing. One of the biggest blocking points for computing creativity is the level of abstraction that you're using. And so some of the impression that I got here today is that the way you visualize how things change is at a very fine grain level. Do you have any thoughts about how to make that more abstract so you could see bigger steps instead of every little step?
Yeah, sure. I think that's definitely, a challenge. One of the things I've been thinking a lot about is how to, in subsequently at least, right, the visualizations are all built in, right? And so it's very hard to get like to a level of like, okay, if I'm sort of take this whole operation that I built in the system, right, how do I make that a reusable component that people can reuse? And I'm not quite sure, right, because it basically, I think in the end requires like the implementer to come up with a custom sort of domain-specific visualization for each function that you would implement. I don't think that there's necessarily a sort of generalizable approach there. I think you'll just need to go like, on a case-by-case basis, come up with visualizations for each particular thing, yeah.
I could say for a Roost, the underlying virtual machine has like capacity for like, encapsulation. Do you see the zooming in thing, like the way I envisage that working is being able to zoom into a function, right, and deal with the nitty gritty and then zoom out. And it's not just for music stuff. It's just music's been like my first thing to try and do with it. But I think that is really hard. I think some of the work that Josh has done about like composability is actually one of the hardest things, because I think it's very easy to like wrap everything in a plastic thing and say that, look, I've abstracted it, but then you can't always like plug it into other things in the right way. So that's like one of the, I don't know. It's
One thing that has come up in the work that the three of us have done, not part of Inkling, but part of a more recent project we've been working on, is that the visual affordances and the kinds of programming that you do on the inside of a thing, like what Lou was talking about zooming in, Zoo was talking about looming in, are like when you go deep into something and you're dealing with like a very low level behavior, you want a very kind of low level visualization. You want a lot of fine grained control. And then when you pull back out and look at like the broader behavior of the system, you want something that's more like orchestration. And we have this in textual coding, but we don't have this kind of, ladder of abstraction, for visual programming. And so seeing a bunch of these different kinds of presentations all back to back make me feel like, something like subsequently inside Inkling, inside a Roost would be like a really nice way to kind of bridge those levels of granularity.
Speaking of the ladder of abstraction idea, one thing that we showed very briefly in our presentation today was this go everywhere thing, which is a gesture we can do in our system where you say, hey, this handle, tell me what happens if you place it anywhere on the screen, like everywhere on the screen, and then we do some simulation to see where that handle would end up if we put it here, and if we put it here, and if we put it there. That gives you kind of a higher level understanding of the behavior of the dynamic system that you've put together with these gizmos and stuff. And it's not exactly the kind of components or whatever that I think you were talking about with abstraction, but I think it's a very powerful thing that Brett started talking about a long time ago, and I think it's nice to be able to explore the ways in which we can do that in all these systems that we do for live programming, because really we can learn a lot about a system through the lens of an example, but it's when we can look at it through the lens of many examples that we get a much better idea of what's going on. And it's hard to just use your smarts, all the time, and kind of system could do a lot for you instead of just sitting there twiddling its thumbs. It's 32 thumbs or whatever.
If anybody knows how to do that in closed form, come talk to me.
Yes.
Okay, that's my cue to say something that I was slightly wanting to say to Ivan, which is, so geometric algebra allows, and this is also relevant to the actual question, geometric algebra has a very powerful distinction between reversible things and non-reversible things. So you can imagine, as a programmer, you sometimes write a function where, if you knew the outputs of the function, you would be able to find out what the inputs are, like the square. Yeah. Okay, I won't try to give an example, but yeah, sometimes you can do that, sometimes you can't do that. The part of geometric algebra where you can do that, is called the Lipschitz group. If you can't reverse things, then that's called the Lipschitz monoid, that is a really meaningful distinction between different kinds of functions, and it tells you, like, in the case of Ivan's stuff, is there a solution related to the question of does there exist a solution for this set of constraints? This is a very abstract thing. I don't think that you could try to apply. Maybe this is what tries to do or whatever, but it's pretty hard to try to apply that to most practical computer programs, because most computer programs just aren't reversible. But for the small set of things where you can, for example, with some geometric constraints, yeah, it could be a really powerful thing, and that's to do with changing state.
So with that, we are at time. Can we get another round of applause for all the speakers from this session? Really strong talks to start the day. If you have more questions, obviously, talk to them, talk to each other. Now is lunchtime. I believe there is food, probably in the big area where the bagels were this morning. And we will see you back here promptly at, we have a 90-minute lunch break. We'll be back here at 2 p.m.
Bye-bye, folks. Thank you very much.
algorithm that kind of makes sense. Or
Yeah,
doesn't.
I can see that. Have you done all of the sorting algorithms in the system? Like,
No. I've been trying. Like I've been doing like merge and like insertion sort and whatever.
yeah, because it seems like at least that's a good bridge. Like if you could do all of them,
Right, this
right?
is
It's a
my
good,
target.
yeah, it's a
to
good
get all of the
starting
sorting
point. Like,
algorithms.
okay.
we've heard a lot about programming with pictures, which is great, but I've heard that in Egypt, they're taking pictures, they're shrinking them real tiny, and they're making words out of them. And that's what we're going to talk about in this session. We're going to talk about systems that do really exciting, interesting things with good old text. So to kick it off, we've got Albert Zach with his project, Run, Build, and Grow Small Systems Without Leaving Your Text Editor. Take it away.
Thanks so much. Oh, come on. Or where is that? How do I turn on mirroring? Can anyone help me?
Yes, use arrange displays and optimize.
Mirror here. Change that every couple of years. Okay. Wonderful. Okay. So, thank you. I think that you should be able to play with and inspect and debug and change a running distributed software system all from within your plain old text editor. So what I built is a simple ClojureScript environment where you can see the value of any expression. You just hit a shortcut and it wraps it in what I call a query macro. When you change the code and save, the value will update. If you put a bang before the expression, that value will update on every key press inside or any change inside. This is Clojure, or ClojureScript, and you can use this to watch intermediate values. And it's fairly performant, so not just in terms of frame rate, but also things like robustness to indentation, selection, new line spacing. It's also a distributed system, and we can run code on any node that's somewhere out there if we know its ID. So we can just def our RPy here and paste in the ID. And then we can run code on this thing. And the way we do that is we call the node function and say on the RPy, this function should run. And it receives as an argument all of the capabilities of this host. What are they? We can just inspect them. So I query the caps here, and we see some GPIO pins of this Raspberry, some serial port stuff, file system stuff. It's all in here. So let's play with the stuff that's attached to this thing. I can just turn on some LEDs by toggling the Booleans in my code here. Thanks. The editor is also a node, and I can run code on it. In this case, it receives capabilities such as toggling this help modal thing down here, or showing and hiding line numbers, or changing the theme. And remember, anytime I change the color, I change the text. And because there's a bang in front of the expression, the entire function redeploys on every change. And you see it's quite smooth. Importing stuff from the internet is also a capability, and we can import stuff in any node, including our editor. And you also see that it works with inspecting asynchronous values. Jarvis promises if I run this, it's pending, and then it'll change to fulfilled here. So you can look inside of asynchronous values. It's also an open world system. So while these capabilities are the only way to access the outside world, they are flexible enough to do anything really. So on this RPy, I'm getting out the function to look at files or directories. And I can just look at the root directory of my Raspberry up here and browse around, like what's interesting, the boot directory, or things like procstat. I can sort of live stream the contents of some file into my editor right here. And then this only works live because of a sort of glitch. We built an infinite loop here. And because this changes the text in the editor, and because there's a bang, it'll redeploy on every change of that file. And because there's no fixed point to be reached, it just goes on forever. But that's OK. If we ever want to stop this, I just put a minus here. OK, now it's the other way around, whatever. But usually you put a minus there and it stops. No idea why it doesn't, but yeah. Because there's the bang here, of course. So let's try turning off the bang. inspecting that and do proc stat again. Oh, whatever. Okay. There's also a very lightweight, like I call it declarative process scheduler. It's probably not the right term, but I'll now start that, and this blinks these 3 LEDs. And these are 3 different processes running concurrently. And I'm giving them process IDs, so the keys in here are the IDs, and that's the function that implements them. And if I want to stop a process, I can just comment out this thing. Now you see the red LED stop blinking. Let's stop the green one too now. Only the yellow one is blinking. Let's stop that one as well. And if I comment it back in again, it'll start up the blinking again. So whatever you specify in the code is like this goal to be reached by all of your nodes out there. There's 2 ways to do state in this thing. One is like in Erlang, when you receive the state of the previous iteration as an argument, and you can change it and pass an updated state to the next iteration. So in this case, let's just run this. We blink that LED. We look at the state here. It just, oh, come on. Yeah, I think the Wi-Fi is really like full of stuff here, so it's not super live, but yeah. The other way to do state is to, if you have some expression that you want to like keep the state of, even when you change the code around it, you can mark these expressions as stateful. So in this case, I'm opening the serial port here, and this returns some stateful JavaScript host platform object, and I want to hold on to this even if I do changes in the code around it. I can wrap this in this stateful function and give it some stable ID, and then this value will always be the same. So I can inspect that, and I've got this distance sensor here, which will just stream my value into my editor. Okay. Now when you're working in a distributed system, it's like your editor is connected to all of the nodes at once, and you usually don't want to look at all of the nodes updating their state or whatever. You want to focus down into one specific instance on your code, say running on that particular node over there. And you can do that with a feature called context. So imagine this is a simple enterprise-y document viewing application, and there's some React components, and what this with context here does is attach some arbitrary piece of metadata to that context of that node that it's running your code. So in this case, we attach the username of the user that's currently logged in, and then anywhere else in our code, we can just use this context function or macro to sort of scope down our views into, say, we want to look at the title of the document that user Dave is looking at. And so Dave's looking at some astronomy stuff here. And let's check what user Sventek is doing. And I probably should not look at that. But you see, you can use that to focus your view down into specific instances or track some users, some request ID across your system. Let's go back to our happy little blinking LEDs. So they're blinking again. The same code as before, and up here is the function that implements it. And I know that this B right here is the value of the pin of any of these LEDs. So we can look at that, and it'll toggle between true and false. And this is scoped to the green LED here, and you should see this. Oh, come on. It's the Wi-Fi. But you should see this like match up with when the green one is on, it should say true and false otherwise. So that's cool, but we would really ideally be able to define very small custom moldable inline visualizations to make this a little more pretty. And we can do that. We can just define a function here which takes that value, and then if it's true, we just show an emoji that looks like a green LED that's turned on, and then here we call that visualization function. And now we get this like sort of view rebuild of the world in our editor, and it should match up. Trust me, it usually does. We can of course do a much fancier version of that with like this, which just looks at the context as before of the process ID. You know, these are the PIDs, and now we should see that match up here. All right. Yeah, you can also visualize the history of these values. So you can write a function that looks at the past, I don't know how many, and then you get this. Oh, what is that? That's not supposed to happen. Let me try again. Oh, really? So. Okay. Yeah. Now we get this not too terribly useful list of all the state changes of that particular expression in this particular context of the red LED here. But we can improve this a little bit and juxt the timestamp onto this. Come on. So juxt the T onto this. And now we have this timestamped log of all the state changes of this particular thing scrolling through our editor. And let's try pausing this now, putting minus there. Yeah, that worked. So now we can just take out anything that interests us and, paste it here and inspect it some more with our code. Right, you can also do return HTML from your visualization function, mark it with a metadata attribute to tell it to render in a certain way. Now we should have the world's lowest budget, super flaky bar chart in here of some live value over there. Right, running out of time here. So this is the tech stack that I wish I had when I built my tiny SaaS business in the medical sector 9 years ago. It's for hobbyists, solo devs who want something fun and very low ceremony. Is it important that it's written in Lisp? Yes, Clojure specifically, because it puts the data front and center, and you can hold on to it without it changing from you underneath. Obviously inspired by Smalltalk Lisp, especially org mode of Emacs. There's the idea of serializing a round-tripping state, much of the statewide plaintext. Thanks, Jeffrey, for telling me about that. The idea of trace points is from APX. There's IDs in the code, saw that in Captain Proto. There's self-rewriting music, live programming environments, like we saw earlier today. Very lovely stuff. Super custom inline visualizations. There was Eve of better tools for thought or more humane direct programming. There's darklang. You have live runtime traces and data in your structural-ish editor, and you can play around with production data. There's also this somewhat unknown Clojure notebook style thing, which the code is your interface to the database, and it's all the same thing, rewrites itself. Yep, it does not have error handling, no code-based management, everything has to be in a single buffer right now. No persistent story, no security as it is implemented here. Also, there's no communication between nodes, which I think Electric Clojure would fit perfectly, where you can define the entirety of your distributed system in a single expression and have the compiler infer the network splits and handle the networking for you. Near future, I'm going to turn this into editor extensions so that people are actually going to use this, make it just secure enough to run my own things. Call it via OCAPs. Talk to me about that later. Some gnarly open questions. What does it mean to delete stuff, especially if you're done working in a code-based management style? How do we deal with things that take a long time to run, starting up Docker containers, downloading dependencies, crunching data over hours or days? Anything that's, how do we hold on to things that we can't define ahead of time in the text, like web clients that come and go? Also, what does it mean for a function or different versions of one function to run at the same time all over your system? How should we deal with that? So what have we seen is there's this query macro which rewrites itself in the text to show data of your running system inline. And there's very lightweight distributed declarative deployment thing where you can just say this function should run on that node over there. There's also this context thing to scope down your view into one particular instance or instances, whatever you're interested in. And there's this object capability thing for effects. But really, it's about showing the data and looking inside variables. I mean, how hard can it be? So, thanks.
That was fantastic. Thank you so much for presenting. Reminder that we're going to have question and answer in a group panel at the end of the session. So with that, can Ian please come and join us? Thank you. And Ian will be presenting tape from direct to programmatic and back. I'll ad-lib a little bit. You all know text is visual too. It's all just stuff we're looking at. It's pixels. Yeah, no, take your time. Yeah, you know.
Let me do the sound check also.
Oh yeah, great. Yeah, for sure.
Continuing the theme, this is also a sound check instrument.
It's the canonical tester. Sounds great. Okay. Well, then I'll put this mic in and leave it to you.
Okay, thanks. And I will start my timer as well. So I know. Okay. Hi, I'm Ian Klester. I'm a PhD student in music technology at Georgia Tech in the Computational Music for All lab, where I work with Dr. Jason Freeman. Today I'm going to be showing off a little prototype called Tape, the Transformative Action Preserving Editor. And while I think Tape is sort of nifty, its real function was to serve as a Trojan horse to let me infiltrate your charming programming workshop so that I could commandeer your collective attention and point it at a problem that personally aggravates me. So the problem, in my view, is a fundamental dilemma in computational media, which, you know, if I were more grandiose, that'd be the title of the talk. But it's the tension between direct manipulation and programmatic transformation, between immediacy of action and preservation of intent. So to illustrate this, I'll first talk generally about software for creating media. And I want to put it into three categories: editors, programming environments, and computational editors. So first category, this is an editor. I press the H key on my keyboard and an H shows up. I can use the arrow keys and my cursor moves in that direction. I can use the mouse, move the cursor, select stuff. I can also do some higher level actions like transform to uppercase or copy and paste. Same thing here with Krita. This is a drawing program and I can draw and I can use higher level things like circles and copy and paste. And the point of this category is just everything just happens, right? I want to make a change and I grab the appropriate tool and I just do it, and then the canvas or the document or whatever it is changed. That contrasts with the second category, which is programming environments. So this is OpenSCAD. This is 3D modeling software where I have this view of 3D models, a 3D scene, but I cannot actually modify it. If I try to grab it, then it just moves the camera, and I have to go and edit the program on the left in order to enact a change, even if I know what that change should look like, and I have to go edit the program to affect a change in the output. Similarly, this is EarSketch. This is a project I work on at Georgia Tech, where you have a script that populates this sort of DAW timeline with sounds and effects, and that should have had audio, oh well. And I can't just move clips in it. I need to go and change the script if I want to change the DAW project. So we have this kind of dichotomy between editors and programming environments where one is direct and immediate. Within that, there may be things that are more or less direct or sort of lower or higher level. And then we have this other category of programming environments where nothing is direct. I have to formulate any change I want to see in the output as a change to the program. But I can do things that would be tedious or impossible just to do directly. And they preserve my intent in the form of a program, which is nice. So what about something that does both, the computational editor? Well, okay, you know where I'm obligated to go to this? Spreadsheets, right? So here's a spreadsheet. Wow, I can just start I can start typing. I press H and there's an H, and I can go back and edit it and do stuff. And then when I'm ready, I can bring in a formula. And so here's a 10 that I've entered directly, and then here's a formula where I reference the thing and then have a tiny little program. That's great. I say, oh, there's too many 3s. I want to tweak that. Okay, I can't grab the 3s, right? I can't do it. I'm not allowed. And this causes me great distress. You'll see why in a minute. But anyway, I have to formulate what I want to see as a change to the program, and maybe I come up with it because I'm a great programmer, whatever. But I've lost the directness, and if I have a lot of tweaks, this is going to get annoying, and especially if I'm just trying to make intuitive tweaks to some output. And so the other option I have is just copying and pasting the output of the program and then tweaking it directly. Now I'm allowed to grab the 3s. But of course, now I've lost the program. I threw out the baby with the bathwater. Now I don't have the linkage, and I'm very sad. OK, I'm also obligated to mention things related to spreadsheets. Potluck, get it? So Inkling has done a lot of inspiring work on dynamic documents with projects such as Potluck and Embark. And to my knowledge, these basically have the same sort of thing, where like spreadsheets, they let you combine content and computation, the direct and the programmatic, and they do it in a more flexible way than spreadsheets. But still, if you have something computed, it's read-only. It's an annotation. OK, why care? Like, how often do you want to tweak the output of a spreadsheet formula unless you're trying to cook the books or something? Like accounting fraud, I don't know. So here's a non-spreadsheet example. This is Blender. This is more 3D modeling software. It's great, it's wonderful. I can do direct manipulation. So I can grab my model in the scene and move it around, and I can grab vertices from the mesh and move them around. It's awesome. Also, it has geometry nodes, which are really awesome, because now I have a data flow program, and look at all this geometry. And so it's like a spreadsheet in that I'm referencing some stuff that I created more directly. And then if I tweak the stuff I created directly like this, then wow, look, the stuff updates. The problem is now I have this artifact, and I'm like, oh, this scene looks pretty good, but I want to move that one. That blue noodle right there, I try, it moves everything. That's not good. I try to select some vertices. There's nothing to select. It's not really there. It's an illusion. And so I'm deeply distressed. OK. I'm even more distressed because this has affected my own work. So this is Lambda. This lets you put little formulas in the dot timeline. OK, I'll be a little bit quiet for a second. So I have a formula, I have MIDI that it generates. I want to change that, make an intuitive tweak to the end. OK, the worst part is Lambda actually lets you do this. But then, if this ever gets reevaluated, it just erases it. It just overwrites it. So it gives you false hope. And that's really the cruelest possible design choice here. So this infuriates me. And so I want to be able to do it all. I want to go from direct to programmatic and back. I want to have the thing not just be an annotation. OK, so enter a tape. It's an editor. That's what the E is for. I can type. I hit H. There's an H. OK. I can copy and paste. And because we know how copy and paste works, and this is an editor, right, it's just a copy. If it sort of has forgotten what it came from, I change this. The other one doesn't change. OK, in tape, you can press the modifier key, the special modifier key, Alt. When it's on, the recording light turns on. And then you can do preserving copies and pastes. So now it does the thing. OK, so I just still did Control-C and Control-V, but while holding Alt. And then this made them go from immediate copy and paste to preserved copy and paste. So when I do that, this creates a computed region. And I can add stuff to this reel, which is the recording of everything, all the computations in that region. And then I'm allowed to just edit the computed region. Like, that's allowed, and it doesn't forget it. Even when I go and force a reevaluation, it's still there. So this is this is the one feature I want to show off. Like, this is the thing I just want everything to have some version of, please. So, OK, but anyway, once you have this reel, you can modify the reel directly, too. So you can rearrange the order of events here in this little pipeline. And yeah, or you can delete or add things directly. That's allowed, sort of like editing the formula. And in addition to the programmatic copy and paste, you can also just directly run any command, including commands from the command palette, while holding Alt. So here I have wonderful. I go to the command palette, and if I hold Alt while I do uppercase, then that becomes a computed region itself. And so you can see now there's a reel because there's a region. I can change sort of the source material there. In this case, there's no input region that's separate. This is kind of a standalone computed region. Okay, last thing I'll mention for time is there's kind of a generic action you can take, which is a formula. So I just did an immediate mode formula where it doesn't save the formula, it just does it. You can, of course, also hold Alt, like with all other things, to make it preserving. So now I'm going to do that. I'm going to say equals, this divided by 3. Okay, and now this is just like a spreadsheet again. Okay, so let's see. That is tape. And oh yeah, and here I'm editing this and adding a formula directly to the reel, and that works too. Okay, so what I actually want this for is not what I just showed you. I chose text because in some sense text is easy, and CodeMirror 6 is great and gives me just a normal text editing experience as a baseline, kind of for free. Hooray! But what I actually want this for is not text, right? I'm still mad about Lambda. What I want is something more like, okay, so here's Strudel again. And I have this beautiful chain of function calls, method calls here, this pipeline of composition, and it sounds great, but I would like to be able to take any intermediate part of this, and I want to be able to intervene directly and modify that, and not have to think necessarily about how to first formulate it in code. I'd like to be able to just make the change and both have the change recorded and also not throw out the rest of the program in the process. Similarly, in Blender, there's these modifier stacks. I'd like to be able to go make a manual edit to the output of some geometry nodes and have that remembered as well. So really, I want this not in, a text editor is fine, but I want it everywhere. And there are some challenges, right? So one kind of obvious challenge, which I'll show back in tape, is it captures everything super naively. Like, it just does like the dumbest thing you could think of to capture your changes. This is fine for like higher level things like uppercase, but yeah, for just typing. Okay, what did it record? It recorded that I inserted an S at like index 5. Okay, so I pluralized, but then I changed the word, and now it should be planets, but it's planest, right? Because it didn't actually capture my intent, it just captured my action, and it made up like a fictional intent that I never had. I can manually fix this by editing the reel and putting something closer to what I really meant. But yeah, this seems like a general problem. There's a lot of inspiring work on bidirectional programming and output-directed programming, as with Sketch and Sketch, where it's more of the programming environment interface. You can modify the output, and it tries to come up with an explanation for you, maybe a number of explanations, and you get to choose. That's great. I'd love to incorporate something like that into tape. But the virtue here is that at least it does something. And I would like more software to at least do something. And let me edit the thing. Okay, so yeah, there's other things that are, I think, interesting to discuss, like if you are making if you're making a bunch of these tweaks and it's kind of coming up with naive, kind of filler explanations, like dumbest possible edit to the program, and you're getting a bunch of those, then it gets messy, right? So relatedly, how do you deal with the mess? I think if you're using this to just create a piece of media, like you're using it to create an artifact, then a lot of times maybe this won't matter. Maybe you'll just get to the end and the reels will be a mess, but it'll be okay because you're already done. It looks the way you wanted it to look. Another thing I'm really interested in here is time. So all of the systems I mentioned are very focused on a program that creates a static output, but I'd be very interested to think about how would you deal with something like processing or Scratch or Strudel more broadly, where time is an important element and the output is changing over time, and it's not just a static document. So, okay, let's see. Yeah, in summary, if it's on a computer, let me compute, right? Give me some kind of, yes, this is the one. I added this right before this just so I would have something. If it's on a computer, let me compute, right? It's a computer. It can do so much stuff, please. And if it's in my document, let me write. Let me edit it. Don't just make it like a annotation or like this illusory thing that kind of exists. OK, so anyway, direct and programmatic. Tape holds it together. Tape is also super hacky. But anyway, the goal here is bring back the bespoke and the intuitive. Like, let users just make changes while also embracing computation. And don't worry about making it perfect or making, capturing the intent perfectly all the time at first. So, OK, that's what I got. And I think that's time. OK.
Thanks so much for that passionate manifesto. And yeah, next up we've got Luyu, is that right? Presenting Diff-based interactive compiler debugging and testing. You should come on up and let's get hooked up. Oh, the HTML is there yet? Yeah. I'm thinking about text a lot. I'm wondering, emojis, they get a lot of love, but anybody have a favorite ASCII character? Absolutely, that counts. I think that one's sometimes called 0, but oh wow, I don't know. Okay. Okay. Sure. What's that? What about it? It's a cool hat, that's all. I thought it was topical. Is that looking good? Yeah. Okay, great. Well, take it away.
Okay, so hi everyone. My name is Luyu Cheng. Today I'm going to introduce a new perspective into debugging and testing compilers. Compilers are a kind of sophisticated software. It takes a bunch of source code files and produce one or more programs, sometimes libraries. The implementation of compilers are intricate as they consist of many stages. This makes compiler difficult to be tested as a whole. A common practice of test is to compose a large quantity of source files and then execute the compiler on them. We can either test the properties of compiled programs, or we can collect the output from the different stages and compare them with some expected results we already written. This is not an easy and trivial task. Therefore, there exists many test suites which can help compiler developers test their software. Each of them has thousands of source files and expected outputs. However, emerging languages can only make their test suites by hand. For example, Rust's compiler has a set of UI tests. Each test contains a source file which indicates the line where errors or warnings are expected. Together with them are expected output. For example, a file describing what is expected from the standard error output. So the Rust compiler should produce the exact error message matches the output. We believe that this traditional method of compiler testing and debugging is not very developer-friendly. So first, a test file can only be considered as a test case, which is either expected to succeed or fail. However, we may want to conduct multiple tests in the same program and with the same context. Then each test file is usually not written in one go. Developers need to go through a cycle of writing, running, and inspecting. Moreover, they usually have to switch between the text editors and terminals to view the results. Lastly, the compiler tests only record and compare the output from the standard output. As the compiler has many stages and we cannot check and compare the intermediate results of a specific stage, this makes the test completely black box. Therefore, we propose diff-based testing. Although it is still based on plain text, we argue that it can address the aforementioned shortcomings. Okay, so since time is limited, let's start the lab demo. Let me change the. Okay, I want to turn on the mirror, but it doesn't work. Yeah, I want mirror.
I think from here, there's a top level.
Yeah.
One of these is mirror?
No, that's weird. Okay, let me see this. Ah, I see. Okay. Yeah, okay, cool. So here we are working with a test file of the ML script compiler in VS Code, and each test file is organized into multiple test blocks, separated by one or more blank lines. The test framework will continuously monitor the test file changes in the test directory. So whenever you save or modify a test file, the test framework evaluates each test block in sequence. This allows the latter blocks to reference the variables and functions defined in previous blocks. For example, in the third block, we can refer to the two functions defined in the previous blocks. So let's go ahead and save the file. Let me turn on the, okay. Oops. Oops. I guess I might run the wrong program. Ah, I see. Sorry. Yeah, okay. So now, as you can see, the test framework automatically writes the results as special comments directly into the test file. By default, it logs the inferred type and the evaluation results. Now, if we add a new test block right after here, for example, you can see that the results will be instantly written back into the file. But what happens if we make an error? For example, we can change this to a string, but the function accepts an integer. If we save, you will see that the test framework detects this type error immediately and right after the test block. So this makes the experience feel very interactive, providing real-time feedback. So it's almost like we are using an interactive notebook. Sometimes, though, errors are intentional in compiler development, so we can actually use the debug flag here, the E debug flag here, to mark the block as the error in this block as intentional. Additionally, there are other test flags, for example, PE for parsing errors and RE for runtime errors. These debug flags are also used for exploring intermediate stages of the compiler. For example, we can correct the error here, and we can use the JS command to see the compiled JS. And also with the DP flag, which means debug the parser, yeah, we can say that we can access the detailed logs from the parsing stage. This tree-like log review the function called hierarchy and the state changes during parsing. Yeah. The debug logs serve two key purposes, debugging and change tracking. Many of these logs are committed to version control, making it easy for developer to see how their changes impact the compiler's behavior. The test framework is also integrated into our continuous integration pipeline, ensuring that we don't forget to update the test files. However, these logs can sometimes get quite long. For example, here we are looking at a log let's use the DP flag to review the debug flag. It is very lengthy. We can activate a side panel with interactive tree view of the logs. From there, we can search and filter specific function that we are interested in. And clicking on the logs, the button here, can even take us directly to the relevant source files where this log is happened. This interactive view stays in sync with the test files. So in practice, this setup is often more efficient than traditional debugging tools, as it eliminates the need to constantly switch between debuggers, code editors, and terminals. So with this live feedback, we can stay entirely within the code editor. Okay, so I think my time is up. So this is the end of my talk. Thank you.
Thanks so much for the presentation, Liu. I'm noticing some themes emerging in this session. Yeah, next up is Oscar, who's going to be presenting example-driven development, bridging tests and documentation. And while he's getting that set up, does anyone have a candidate for a new ASCII character that we don't have yet? Diagonal tab. Just because people love tabs so much. I had no idea. We're not doing Unicode. We're doing ASCII here. Okay. Looks like it's connected okay. It's just a matter of getting things in the right place. Always a challenge, but take your time. Just get it set up the way you like. Oh, you want a mirror? I think what I like to do is in the top right, is there a, actually, I'm sorry, this little guy. There's a screen mirroring option. Does that? Oh, but that just takes you to display settings. Does anyone know how to do mirroring? Option drag. Okay, option drag one onto the other. Yeah, they mess it around. Is somebody very talented at performing the option drag and want to come? Yeah, it works. Oh. I think we're good. I think we're mirroring.
Okay, good.
If you're happy. They're always improving things. They're always improving things. Okay, so is this set up the way you like?
Yep, looking good.
Well, then I will. Get away.
And I'll start. Okay, hi, I'm Oscar. I work for Fink. We're a little company in Switzerland, and we modernize legacy software systems. And the approach that we take is called moldable development. The idea is to take the software system and open it up so that we can see the internal domain concepts, and we make them live and explorable. One important component of moldable development is example-driven development, which is what I'll talk about today. Our platform is called Glamorous Toolkit, or our substrate, if you will. What we see here is the Glamorous Toolkit book. The GT book is a knowledge base of notebook pages. And what we see here, for example, is a notebook page describing the Ludo game, a game for children in which tokens move around a board on the roll of a die. And we've documented some of the kinds of moves in this game with various examples. A particularly interesting one is this example here, which is an impossible move. This move cannot be made on a roll of 6 because it would take us off, player B off the end of the board. What's interesting about this is we can dive into this, and here we see the state of the game that we got to. This is a live instance of the game, so that's a particular view we have here. We can dive in and see the players of the game and inspect those. We can look at the squares of the game. We can even go through the history of the moves of the game, and what's kind of cool is that we can then have a kind of back-in-time debugger, if you will, for free, where we can step through and see all of the states of the game. This by the way, what we're seeing here is just an object inspector. It happens to be a moldable object inspector. So normally what you would see in an object inspector is this thing. And what instead we have is we have custom views, tiny little tools that make the environment explorable. So little bits of code that will configure these. What are we actually seeing here, however? This guy, this example, is just a little snippet of code, and it's grabbing the result of this method, which is a game showing all moves. And what is this thing? Well, it's just a test case. Here we have a setup. Here we perform some actions. We have a bunch of assertions. So, and there's even an annotation saying what it is. It's a test. Well, it's an example. The only thing that's different is we return the instance of the game. The object under test is returned. What this means is that instead of just having a green test, we actually get an object back that's live. Now, this is interesting because now we can actually compose these guys. So this test was actually made up from another test that returned an object. And you can see where this is going. We actually get a, come on, we actually get a tree of examples. So examples composed from other examples. And of course, when we run these guys, if something fails somewhere along the way, the dependent tests won't get run. The reason it didn't run anything because some of these, it's only running the examples in this class, and we're actually reusing them in other classes as well. Okay, so what's an example? An example is just a test that returns an object, an example. That's what an example method is. Why is this cool? It seems like such a trivial minor change. It's actually fundamental, and it's a cornerstone of what we do. It means that an example isn't just a green thing, which is, okay, the test is green. What can I do with this? Nothing, nothing. You can stare at the code. Only if a test is red is it really useful. Well, in our case, green tests are useful. We can build other examples from them, but we can do a whole bunch of other things as well. So here's a partially implemented example. I've got a film collections example here. It's actually coming from IMDb. So I've grabbed here an IMDb file from IMDb, and I grabbed the CSV by pulling the data from that file, and I grabbed the JSON from that, and finally I wrapped the JSON as a collection object. So these are just tests that return objects. Now I can dive into this guy, and I see a whole bunch of movies here. This is only partially implemented. I'm working on it. And I can dive into them. So I have film objects and film collection objects. I see, oh, there's all sorts of other things that might be interesting to show in here. In fact, there's a director's field here. So we can actually look at the source code, or we can talk to the object and see, oh, well, there's a director's field. We can verify that talking to the directors actually returns something interesting. Why don't we have this over here? So we can actually go to the source code of this custom view, and we can edit it. We say, okay, well, let's have directors and directors here, and we'll save that, and bing, it's updated live. Notice I wasn't programming in a text editor. I'm programming really in the live environment using the inspectors. Running out of time here. Last thing I wanted to quickly show you is how we can use examples for all sorts of interesting things. We've got way too many examples of examples, but here's an example of explaining a squarified tree map algorithm that comes from this great paper which has the description of the algorithm as a diagram in the paper, but we can do much better than that. We can turn this into a live example, which we can now explore. So we can see the squarified tree map avoids getting these elongated nodes by going step by step through the steps here. We're adding a node one step at a time. Here I am. And I find that if I At this node, it's going to break the threshold, and so we don't want it there. We're going to push it over somewhere else. So by having live examples, we can also explain algorithms. Good. I've run out of time, and my final slide is just the summary. Yeah. Examples are a combination of tests and factories. We can compose them, use them for further development, stick them into live documentation. And what I didn't talk about, but you can see it in the paper, there's a link in the proceedings, it actually leads to a different style of development. The system is open source. You can download it and play with it. I'll be here all week. You can talk to me. Thanks.
Thank you, Oscar, for the tour de force demonstration of the power of multiple development. And yeah, next up, looks like we have Martin, who will be connecting, and the others. That's fantastic. Okay, great. I was hoping it would be a posse cut, and I didn't come up with any patter. Does anybody have any patter? Good, coding related. Okay. Well, they will be presenting live programming, a live programming environment, and experience report. So give it up for them while they get connected.
So, how do we get this larger?
You just say enhance.
No, the resolution, right? Was it in screens or?
I think you're in the right place. Go back.
Go display. Displays.
Display. Advanced.
That's, oh my god.
Show resolutions as a list.
What? Up there. Ah. That should be a check.
There's some other way around.
Okay, good. Okay, and then?
Try under a range. Oh, there it is. Yeah.
Alright, so how's this? Is this good? It's better. Alright, I hope that works.
Can you turn off True Tone on the laptop display?
Alright, bonus mission. Where's that?
Scroll down. Just if you just set True Tone.
True.
Yeah. It's here. And then scroll down.
It's also called.
Oh yes, click on built-in display. There's two displays. You gotta click built-in display and then turn off True Tone. It's really bad.
All right. So we're good?
Yes.
Cool.
Okay. Hello? Okay. Hi, I'm Elliot, and I'm presenting with Martin and Philippa from Nextjournal. And we're talking about live programming, a live programming environment, an experience report, which is the paper we made for live that you can find at live24.clerk.vision. And we also made this with some other folks from Nextjournal, Jack and Andrea. It switched on me. So at the start of the summer, Jack invited me to come out to Berlin and work with the Nextjournal folks. And I got to learn about Clojure and Clerk and see how Martin and Philippa and others at Nextjournal live program every day in Clojure using REPL-driven development. And I also got the amazing opportunity to learn about the automotive logistics industry. So yeah, Clojure, in Clojure, the way people do live programming is called REPL-driven development, which is like a fine-grained type of getting feedback on your program where you evaluate individual expressions And it's a part of the culture of closure programming. And the folks at Nexternal work on a complementary system to this style of live programming called Clerk, which allows you to apply rich and moldable viewers to your data and apply incremental computation to your closure files. So yeah, our Nexternal's working with clients in the automotive logistics industry, and they have a system that generates a ton of data about cars, and the users have a need to understand and explore and generate insights from their data. We wanted to submit something to live, and we also wanted to build a tool for our users. So we decided the project we want to work on together is a live programming tool similar to Thomas Petracek's The Gamma and Histogram, a report builder, so that users can explore their car data. In reading The Gamma and Histogram, we liked the framing that Thomas had, where he shifts from talking about programs to talking about how we program. So the focus of our paper and this talk is not about what we built. It's about how we built it in a live programming sense. But first, I want to show you what we built before we talk about how we built it. So on the left here, we have a closure file. And on the right, we have our report builder in our browser. At the top, you can see our data sets called dispatchable vehicles and the result of evaluating that. And mirrored on the left side, we see it in this trace. And I can click on this plus button to make a choice from a curated DSL based off of the data. And I can build up my pipeline in a sort of interactive way this way and see intermediate results as I go. And as I add these data processing pipeline steps, you can see them also reflected in the closure code. And finally, we get out a plot so I can understand a bit more about the distribution of cars in our system. But how did we go about building this? The problem with live programming is it can be transient. So when I show you this artifact, or I check my code into source code, or into source control, you can no longer see how I went about building this. And when I went to Berlin, I didn't know anything about how people live program in Closure and Clerk. And sitting with Martin and Philippa every day and seeing them live program is how I learned what that means. So we want to try to share that with you. So I'm going to pass it to Martin, and he'll show you some live programming in Closure and Clerk.
All right, so yeah, this is Emacs on the left here, right? And on the right we have Clerk's view. So yeah, dear reviewer C, you can call Emacs many things, but I think a dead editor is not one of them. So this is Emacs connected to my live runtime. And so first kind of evaluating closure forms. I can evaluate the thing at the cursor. You see I get back to 41 when I'm standing here, but with a different shortcut, I can evaluate the whole top level expression, right? You see this highlighted. And I get back to 42. And I have another shortcut to show this in Clerk. And yeah, let's now try to recreate, or let's first look at the data set. And I can show this in REPL, and I get this in the mini buffer here at the bottom, or I have a different shortcut, and I just see that in this panel here, or I can show it through Clerk, again, with this shortcut, and this is kind of Clerk's default view, or I display this as a table. And then you get this view that we saw earlier. And that's one example of like choosing a different viewer to represent this data set. And let me do a quick detour about clerk viewers. By the way, Glamorous Toolkit, which we just saw, was a big source of inspiration for building clerk. And so this is kind of my favorite example showing clerk viewers. So this is just a standard view, but I can bring in different viewers like this number viewer here. And things will start to look a bit nicer. And like with 2 specific collection viewers, I get something that still, yeah, looks better yet. And this still composes kind of with Clojure's standard data viewers. So this representation of this hash map here. All right. So yeah, back to trying to recreate this pipeline that we just saw. So we kind of started out from the textual DSL and having concrete targets for what we want to build. I'm gonna map over this. You see I get completions on the keywords here as well. And do the frequencies. And then I'm gonna, so we don't have the plot function here. And I want to show you how to recreate this real quick. So I'm evaluating this and replacing it with the buffer, giving me like concrete data to work with. And now I'm going to turn this into a plot. So I think this wasn't quite right. Yeah. And get the keys. Okay, so now we have these labels here at the top, and let's turn that into a bar chart. Yeah, no, so now we have a concrete thing of what we just saw, but it's not yet a function, right? So I'm grabbing the sample data, putting it down here, and refactoring this into a function. And so I'm naming this at the last possible point. And finally, I can kind of wrap this in a clerk example. And then I will see kind of clerk will show me the code and the result kind of side by side. And I could have other examples here. Like, let's see, I want to see what this is like with a very large thing. Yeah. All right, so back to our slides, which aren't quite slides yet, right? And wouldn't it be nice if they were? So we bring in the slideshow viewer, and there we go. And with that, I hand it off to Philippa.
Okay, thank you. Let's make this bigger. And where were we? We were. Oh, it doesn't work at this resolution. This sucks. Okay. So, give me a second. Okay, part 3, keeping the liveness alive. Okay, going through this experience, building the report builder, we ran into things that killed liveness for us and supported liveness for us. So one of the things that killed liveness for us is doing way too much, right? So we started with Figma mockups, and we kind of like designed the whole system from the start. And having this like largely scoped thing really resulted in 2 large reports for us and in a 2 large DSL, like this underlying data transformation DSL. And we got overwhelmed and stuck, and it was not a good place. Another thing that killed liveness was complex architecture. So this might be a Clerk specific thing, but dealing with 2 runtimes in Clerk, that is the JVM and the browser, we had stayed in way too many places, and this made it really hard to reason about the effects of a change in the system. Another thing was deadlines. So deadlines, we really wanted to have a nice, fully functional thing for the initial live submission, but the deadline really made us compromise a lot. So we fell back into console log for debugging. That's a thing you don't want to do in Clojure world. Like you want to inspect at the REPL, you want to have as much liveness as possible, and console.log did not give us any liveness. And we kind of like dropped out of this principled process. Ironically though, deadlines is also a thing that supported liveness for us. So after the initial submission feedback, we really gained clarity. So this, like the feedback really made us cut scope for the final submission. And we focused on tiny steps and bottom-up design. So we figured out no step is really too tiny. So keeping your changes tiny resulted into keeping a running system for us at all times. It made stuff inspectable for us using the REPL. And we started over with tiny reports and a tiny DSL, and working the small made it really easy for us to reason about things and be principled. So we also came up with this thing called the 20-minute rule. So if you weren't able to build something in a complete live process in 20 minutes, we kind of needed to take a step back and rethink the entire architecture. So another thing that kept the liveness up for us was starting with a concrete data structure. What that means is like you first start thinking about the UI you want to make, and then make an initial sample data structure that kind of like captures this UI. Like for us, that meant having a place that has the code, the choices that we want to show in the UI, and the results. And from that, we built the UI using Cloric viewers. And we also made sure we can always generate code from this UI data structure at all times. And from this, we kind of got into this iterative process, doing this over and over again. And this made us focus on finding irregularities and eliminating them along the way. So I'm really zooming through this now because we don't have much time. But if you read our paper, you'll find these experience boxes throughout, which you can expand, and you can read up on where we got stuck and how we felt being in that place. Okay, I want to wrap up. There's 3 things. Like liveness really makes you feel great. Like it's great for thinking fast and getting you in a flow state and feel fantastic. It's great for exploring data workflows. And if you know where to go, it really helps you get there faster. But losing liveness can also be a prompt for you to think slow again. It doesn't absolve you from actually thinking about your architecture. So if you start losing liveness, use it as a prompt to take a step back and question your architecture. And finally, we feel there's a folk culture of live programming techniques that we're not talking about enough. So often the discourse is about the tools that we use, the live programming tools, but not so much about how people actually live program in the day-to-day job, right? And I really wish we would talk about that more. Thank you very much.
Fantastic. Thank you for the presentation. Oh yeah, and you should stick around because we have now entered the final panel discussion of this session. So all people who presented in sorry. It's a mess here. It's a mess around here. Yeah, if everyone could please come up and join me. Yeah, this is going to continue being a mess. Yeah, clearly. Okay. So any hands for opening questions for the crew? I've got one from Peter, and we would like to make sure that we get questions on the mic. So please, let's try to remember to do that. Great.
Okay. I really liked this point you made, Philippa, about what I would call the wetware, right? The part of the system that lives in the brain.
Yeah.
And I think it's something that's really a distinctive character of both Clark and Glamorous Toolkit. And you mentioned Glamorous Toolkit as like an inspiration for Clark. I'm curious, like, whether you see differences or like how you could, like, can you characterize that like way of thinking a little bit more for people who don't have these hands-on experiences? And I'd love to hear like, what are the key sort of insights to be successful maybe in those environments, you think? Because I think actually it's also for I think basically everybody's systems have this property where it's like, it's as much a way of thinking as a tool, as you say. So if you could talk a little bit about that, I'd just be interested to hear each of you.
I need to pass this on to you because I haven't looked at Glamorous Toolkit as much as you.
I mean, if you speak for yourself, I think Oscar could probably speak more to Glamorous Toolkit.
Well, I'd be happy to. Let me see, a couple of little revelations. I learned programming, like probably most of you in this room, with a static dead language. You program in a text editor and then you pass it off to some interpreter or whatever. When I retired from university 3 years ago, started working for Fink, and I know this stuff, but at least intellectually, but when I started writing demos and so on, I would go straight to the text editor, to the coder, and Tudor would be sitting next to me or pair programming online with me, said, no, you don't have to go there. You can go over here. And it took me a long time to learn that I don't have to program in the text editor. Second revelation, I was preparing a lot of demos and slideshows and so on, and the slideshows are code. They're methods in a class. And it took me about a year before I suddenly realized, because I was programming these slideshows in the text editor, I said, damn it, I've got the world's greatest environment for moldable development. A slideshow is an object. It should be a live thing. And I should just create custom views of it. So I just spent a couple of hours in an afternoon, and suddenly I had a programming environment for slideshows that was live. And I stopped programming in the text editor. I was also mentoring a student at the University of Bern, a student of my successor, and he was using Glamorous Toolkit to analyze GitHub actions. And I was doing the same thing Tudor had been doing. Saying, no, Pablo, you don't have to go here. You can actually stay here. You don't have to go somewhere else. You don't have to go to another window, to another tool. And then after a while, he said, yeah, you keep doing the same things here. And he said, yeah, there must be some patterns here. And then we started thinking, yeah, there are probably 2 or 3 patterns here. Let's see if we can write them up. We ended up with over a dozen. I said, okay, we've got to workshop this, send it to Europlop this summer. So now we have a nice collection of moldable development patterns that articulate what's going on in the process of this live programming and opening up systems and making them explorable. So this is an ongoing experience for us. And it's the same thing with the examples. First, I thought it was just a nifty thing. I didn't get to talk about it because 7 minutes is too short to demo that. But it changes the way you think. When you're doing example-driven development, you don't actually write the test first. You start with the live example, and the example emerges from it. It's a slightly different way of thinking, and it's liberating. It's really interesting.
Yeah, real quick. So I think we actually really do have a lot of overlap here. So one of the things that really drove me like working on Clerk is like I have this, or I guess we all have this experience of like opening our text editor, and then you're presented with this view of having a file tree on the left side and an editing pane in the middle of the screen. And I feel like this is just not rich enough. You know, if I drop into a code base, like I don't want to dig through the files, like give me some high level overview, like how are the modules connected? How can I reason about this thing, right? But for some reason we are stuck in this local maxima, and we think like this, it's fine, you know, it's fine. Let's just not keep improving it. But I guess it's not fine.
Okay, the next question. Looks like there's a question from Alex.
Hello. So my question is that a lot of the time when I'm programming by myself, my hacker brain kind of, decides that it's in charge or whatever. And there are times when I know that I would benefit from having a custom visualization of whatever thing I'm working on. And I know I could make that visualization, but there's a trade-off, right? You think, oh, is this worth the effort that I'm going to put into it right now? And often the hacker brain wins in my case, and I don't do it. And I think that if I had done it, opportunities would have opened up, and I probably would have ended up in a much better place anyway. And so my question to all of you is, what are the things that you're doing in your systems to make it easier for people like us to create these custom visualizations so that this kind of calculus that happens ends up, the result ends up kind of in favor of the creation of the visualizations and stuff?
In learning about Clerk, I think a really cool thing about it is you can make a Clerk viewer, and you can apply that to a specific piece of data and see it using a different representation. But not only that, any place a data of that format shows up even in a nested place like a table or inside of I don't know, some richer data structure like in some nested way. It also has that viewer applied inside of the table, for example. Seen in a lot of other systems where viewers compose inside and outside of each other.
One of the things that's important for us with GT is that nobody's going to build custom tools if it takes you half a day to build them. So this should be something that you can implement in minutes. Most of the code, and most of the views, and that's one of the patterns, is simple view. Really simple views get you a long way. Occasionally you need to invest in something more heavyweight. And we also have a built-in tool for building very easy graph-based visualizations called Mondrian. And once you learn how that works, you can build even a fairly sophisticated visualization in a few minutes. So that's really key. So like 98% of the visualizations that you build should be really cheap and easy. And then more complicated things, you need something else.
Also, if it's just a function you write, just another function like what you would show to your user. If you have some component that shows some data to your user that you ship in your app, you can just reuse that same component at development time to look at the data yourself, and vice versa. If you build something for yourself that you think is useful, you can ship that same function to the user. If it's just a function that lives in the same namespace as all the user space functions that you ship. It's really no effort to create them.
Okay, I have a quick question, which I think is relevant to a few of your projects, which is that I'm noticing a pattern that of projects that sort of patch things into a text editor. So whether that's sort of feedback patched back in, or even your project as you edit something, in the report builder you built, it patches in the steps. So that seems like a neat technique. I'm feeling kind of excited about it, but I'm curious about your experiences with it. Does it work well, or are there things one should watch out for if you're going to be doing that? Like, I'm curious.
Yeah, actually our test, we call it diff tests. It's not something new. It's already there for a long time. For example, in the ML sub project by Stephen Dolan, it has a variety of names. For example, the cram test in Python and the expect test in OCaml used by Jan Street. It's also called, I think that is the snapshot test in the Jest, a test framework. So I think our contribution is to bring it into the compiler testing, because when we developing the compiler, we built it from scratch. We want to use the language immediately. We don't want to implement the parser, then implement the type checker, then implement the code generator. Then we can use the language. We just want to see what's going on inside the compiler, and that's why we bring this technique to the compiler testing. And with the tool, we can just say the trees, for example, the parsing trees, and elaborated or type-checked trees, and even the generated code within the editor. I think the diff test, it has a same goal as the first presenter. We don't want to leave the text editor. We want to live in the text editor forever. Yeah.
It's a beautiful dream.
Yeah.
Any other perspectives on living inside of a text editor?
Yeah.
So I was amazed to see Clerk doing this, like with what looked like there's no point in the textual code to hold onto this location to insert that. I'm curious how you did that, but I'll ask you later. So the way I did it is actually a huge hack. It's this question mark thing has as its first argument after the question mark an ID, and it's hidden visually, but it's there. So in my system, you have to like give IDs to all of the expressions that you want to refer to from somewhere else. But that feels like a hack, and it is a hack. So because there's a hidden ID there, you can't copy and paste expressions with a question mark in them. You always have to use the shortcut. You can just type the question mark out. It's my least favorite part of the entire thing, and I would be glad to have some protocol. I did look into this, what's it called from Microsoft, this language server protocol thing, if they could do that, or this build server protocol, I think, the other one. But they don't seem to do that. So I'm kind of waiting for the community to come up with a good way of inserting things into text or holding on to some locations in the text. Can you?
No, I don't have answers there. I must say, like our thing is also just a small hack, I'd say, and the idea was like we haven't implemented this so far in Clerk beyond this report builder because of like we think you're just like then you need kind of operational transform support or something in your editor, right? Or yeah, or this other thing, this more complex thing. But yeah, it's gonna be yeah, it's gonna be hard.
Okay. Oh.
Hello.
It looks like we're ready. Great.
This is the text block, right? I have that understanding correctly. I noticed a curious thing, which is that y'all are supposed to be the text people, but there's like sonification of data, there's LEDs, there's like generating web slideshows. Y'all are playing with a lot of different kinds of turning data into other forms that people can interactively play with and appreciate. In some ways, even more so than the earlier block that was all kind of like vanilla, just visual kind of stuff. I'm curious if there are kinds of like that sort of like, hey, we're starting in text and we're reaching out. Are there things you found yourselves wanting to reach out for, other forms of data representation or forms of interfaces that you struggled with? Crickets.
Yeah. So I'm like the weirdest person to pick this because I actually stayed in my lane and it was all text. But yeah, I would like to get, stray from my lane and step on some toes visually. And yeah, I'm going to pivot and bring it back to the earlier question about patching stuff into text editors. Yeah, I think, so for one thing, I'll shout out again to CodeMirror 6 because it's awesome. And yeah, I want to, when having this kind of dichotomy between direct and programmatic manipulation, I want like more kinds of direct manipulation than like editing text affords. Like, yeah, on the one hand, I'd like to have the kind of tape feature in other environments that are not primarily text editors, but also I just want like more interesting text editors that are not just text and have, different kinds of interactive widgets and so on. So yeah, I want to stray into this and patch these things into the text editor and then, have everything live in harmony. That was a rambling answer. Someone else take this.
Any other takes on that question? Sorry. Okay, great. That was a great question. Oh, goodness. Let's take one from Jeffrey, if we could.
Hey, thanks for a bunch of amazing talks. I'm curious to ask about, in some of your systems, there's stuff happening in the editable text itself. In some of them, there's kind of a relationship between an editable text buffer and views that are next to the text buffer that are less editable. I think Ian had some interesting hybrids of both happening, essentially. And I'm curious to ask about, do you have any reflections on the tension between putting stuff directly in the editable text versus having side-by-side views, the trade-offs either way, the advantages of each approach? Have you had thoughts that you want to move more in one or the other direction when working on your systems?
Yeah, so there are a couple of things. So one is when we have our text flows in the notebooks, we want to have lots of different kinds of things, not just text. So we want to have different kinds of elements and live examples, and just about anything can fit in there. Part of the substrate that's really fundamental is we have a graphic system called Block, where everything is at the same level. There's a single rendering tree. So whether it's a character or a widget or a window or a tool, anything can fit anywhere in the tree. And that makes it really easy to build any kind of explanation you like. There isn't a difference between these things. So that's important. The other thing, however, which you might have seen in some of my examples, we're navigating through this explorable domain models. And this allows us to create stories or narratives. And sometimes what we do is we take screenshots of those and we post them on Slack if we're asking a question. Say, I'm having this problem. So you can see in one window, oh, here's some code that we're trying to execute, and this is the result. Or might even be 3 windows. And we always take the full picture, and we discover this is an important pattern. Whether it's a static screenshot of something that you want to use to explain to somebody, or whether you're doing it live with somebody, because you're always telling this story. So having things side by side and being able to walk through is an important pattern. So sometimes you want to do one, and sometimes you want to do the other, and they serve different purposes. Yeah.
Yeah. So, of course, so to recap the question, putting stuff in the text itself and where it's editable versus on the side. Yeah. So obviously, I think more stuff should be in the text and editable. Things might appear to be in the text but not editable, which I think is bad. But yeah, notably, in my demo, there's a big split, right? There's like the main text, but then there's like some other text, and it's all editable. In fairness, but you only get all the magic features on the left part, right? The action reel you can edit directly, but you don't like record edits to the action reel itself in like a meta action reel. I did think about it. It seemed like a bit much, but yeah, I'm in favor of more stuff in the text itself. If it's part of your document, it should feel like part of your document.
Final question. Looks like Peter's got something.
So I think tape is like kind of alien and radical in a really interesting way. And weirdly, it reminds me of Vim and like the macro system there. And I wondered if that was an inspiration, and then therefore whether you had thoughts about building on the current sort of system you have and like generalizing from it.
Yeah, thank you. This is a great question. So this was in my submission video, but I didn't have time for it in the talk. I think like one interesting way to preserve intent better in the first place is make it just easier when you're doing immediate actions to do them in a like way that conveys the intent. And Vim is amazing for this, right? But even like in just a kind of vanilla editor, like with the pluralization example, I could have, instead of clicking at the end of the word and pressing S, I could have gone to anywhere in the word, then done like Control right to go to the end of the word, then pressed S. And if this thing recorded movement the way it records insertions, then that would kind of do the thing, and that would help. But also then like the mess gets exponentially worse if you're recording like every movement that happens to happen in a computed region. But yeah, what editors already have that's like kind of almost this but not there yet is macros, as you point out, and then also like undo history, right? So editors already have ways of like recording actions. These are the 2 ways, but they're sort of not reified in a way that you can like use usefully, and they don't kind of have the linkage that you get from like spreadsheets and that sort of thing. So yeah, I want to unify like all of these things, like undo, macros, the tape stuff, like it's all just recordings of actions, some of which are, you arrived at programmatically, and some by just like doing the thing.
Amazing, thank you.
Fantastic. Another round of applause, please, for a session of great talks, great conversation. We now have a 30-minute coffee break to re-up, and then at 4, we'll be meeting back for more fantastic talks.
Final coffee break of the day. Our next speaker has just left the room, which leaves me in the awkward position of introducing someone that's not currently here, but I'm sure he'll be back quickly. This is the fourth and final block of the most high-density workshop, I promise you, at Splash this year. Thank you to all the speakers. What we lack in quality, we make up for in quantity. I mean, wait, no, this has been an incredible day so far. And we're gonna finish strong with our substrates block. At the end, we'll do a little closing, stick around for that, and the usual Q&A. So it's my pleasure to welcome Jeff Lindsay and the Manifold paper. And Jeff, the floor is yours.
Cool. Hello, can you hear me? Okay. Thank you. Oh, this is awkward. Okay. Let's get started. Yeah, so my name is Jeff, also program on the internet. This is a demo of Manifold, which is very early, like most of this was put together like a week before submission. And given time, I'm mostly showing and not talking about it or explaining it. So talk to me afterwards to get an explanation and give me feedback. It's really important. Nobody's really seen this. So Manifold is a system for interactively assembling software components, eventually in a mostly language independent way, but for now, just Go. How many Go people in here? Any? All right, fine. There's also a JavaScript implementation, but the goal is to make building and interacting with software closer to working with a design tool, but in a bottom-up way, so you're building on top of the language as opposed to building like a top-down Adobe product. And besides being very early, Manifold is not like a complete solution, it's a primitive, so you could use it as a kernel for malleable software, or as a foundation for live programming environments, or I've been thinking of it as maybe doing a new kind of shell. You could say all of this stuff about Smalltalk, but this is sort of in a way that works with the world, maybe. Inspiration, obviously, we've got stuff. The middle row are a bunch of software design tools that I like. Visual Basic, Flash, Unity is a big one. Huge, really the main inspiration for a big part of this. But also like Unix, Bell Labs back in the days, thinking about these abstractions of file systems and the shell, right? They invented these like ideas, these abstractions that they also refined in Plan 9. I'm sure many of you are Plan 9 familiar. And then, I don't know how many of you know this, but a lot of that deep Unix philosophy worldview was sort of embedded in Go because it was all the same, authors of Plan 9. Go is also people call it a very productive language, especially for a systems language, which is very interesting. So let's see an example. We'll build an HTTP server. You're all familiar with HTTP servers, right? I mean, we'll build it in Go first, and this is very simple since Go has a great standard library with an HTTP server in it. But just to kind of walk you through, basically we're assembling 3 components. We do one, which is a net listener, which lets us accept sockets. I'm not sure how many. Anyway, I like the net listener abstraction. Another component where we're basically putting together the handler, the custom logic for the HTTP server, in which we will just return hello world. And then, of course, we'll have the, okay, where is my scrubber? We're playing video. There it is. Okay, good. So we build a server, and then we activate it, and we run it, and we get a hello world. Yeah. This is to orient non-Go people, too. Let's build the same thing, but in Manifold. But I have to reorient you now, because there's this UI on the left. The program on the right is actually running right now. This is a live environment. And really all it's doing is exposing this sort of direct manipulation API that this extension, this VS Code extension, is giving us a user interface to. So this UI is not specific to Manifold, but we'll be using this and see. We'll just add some components, so add the TCP listener, add the web server. Let's see. configure it, our component, we can just sort of generate stub 4 and then fill it out. We'll do the same thing, return hello world, and then we'll activate the system by hitting this little play button. Even though it's running, we're activating what we wrote. When we get hello world, that took like half as long as it took to write Go code, but that's not really the point. The point is that this is a live environment, so everything's faster. Exploration, iteration. We could go to this handler that we put together and change this, put a message field on it and then have it return the value of that. How are we going to set that message field? Well, we've got this cool inspector. We can just set that string there and hit play, and we go and get hello message. And of course, this is live, so. But we can also start doing other stuff like adding new fields to this struct of different types and hitting save, and then our inspector updates in real time, and we can add methods, and we can mess with this data, and then we can call the method that we added dynamically. So it's like we turn Go into almost like a dynamic language through this API. We basically made Go into an interactive live programming environment, which is interesting because most of the time you see these implemented in JavaScript or Lisp or Smalltalk or whatever. So to have this language that is out there that is used in the industry all over the place is pretty interesting. There's sort of three legs to this manifold thing. One is this component programming model, which is really just how I write. Well, first it defines what a component is. So it's just it's a type with fields and methods, which struct satisfy. So any object-oriented object will satisfy what a component is. We just call them components in this model. We also, again, just like Go best practices, we lean into interfaces, which Go has a great great implementation of. I don't have time to get into all of this, but if we do this, then we can do some cool dependency injection stuff where we automatically wire things up. The other big part of Manifold is the direct manipulation runtime, which is both that hot reloading, so you can make changes and updates without having to restart anything or get in the user's way. But mostly it's this reflection API. And Go, part of what makes this possible for a systems language is Go has a reflection API. It's one of the few languages it does, and it's not really fully utilized. But this gives us basically direct manipulation of any addressable value in any of the components, regardless of the type, and get a nice user interface for it. But really, the coolest part, I hope this is mine, is this, I haven't even showed it to you yet. It's this sort of it's this object model where so far we've been talking about these components, but we put them all on a single object in this hierarchy. So this is a default, object, but we could have multiple objects. Well, first, an object contains components and doesn't really do anything else. It has a name and it can have subcomponents. Does anybody work with Unity or have worked with Unity? So this is familiar, right? Yeah. You can have, objects can have sub-objects, which can have components or not, or other objects, and that's basically the whole thing. Most of the data model comes from the components you put on it, which makes it a very sort of almost programmable tree structure, which is already very versatile. So we can get a lot of mileage out of this while getting all of these other benefits of interactivity and UIs and stuff. To help you imagine this primitive with a body of component libraries and systems, I'll show you some that I threw together really quick. One for doing UI stuff, quick and dirty UI. Yeah, that's all I'll say. So this project has a bunch of stuff that's already in it that is going to serve a web page that will show our layout. It also gave us this sort of, you can do anything you do there, you can do in code as well in a pretty declarative way. But it gave us this sort of starter layout. There's this text node with quick text component. Layout with a quick layout. If we activate this, we get hello world, which was the text on the text field of the quick text. Obviously, changes and updates in real time. Oh, big deal. But we can also add other objects that have these components that would just update the UI. So I created an object with a quick input component and called it name. And here I'm creating an empty object with no components, using it as a container for other objects, these button objects. And our layout system uses that structure of that container to go from a column layout to a row layout. And so we didn't have to do anything, it's just the convention, so getting stuff out of the structure that we have here. And it did something, so that's because we have this event handler. We can view the source, and this is inspired by PySimple GUI, this model. It's kind of like an Elm thing, but we're gonna log what the event was and the fields that were set, put it in a field on this struct, and then we're gonna do some stuff. This is all, again, like contrived example code, but we get the quick text component and set text on it. If we look at any of these quick, component UI components, there's no rendering stuff here, it's just data. That lets us have the renderer be totally separate, and we could render it in a totally different way, like in the terminal. And we would just get that for free, and it works, does exactly the same thing. And then because we have this terminal UI, we could very easily make this an SSH server. Since we have an implementation of a SSH handler, we can just put this SSH server component on the root, and we don't even have to do anything. We can just hit activate, and everything wires up. And so now, besides the UI, we have this SSH version of the UI, which updates everything and live. We can change the hierarchy. We change the reset button to a quit button, which has a default handler that will quit. Here's another one, totally different. File systems. We'll make a virtual file system in the same project. We'll put it under an empty object called FS. We'll make a couple files, an object with a file buffer. So this is a struct with a slice of bytes. It's just bytes in memory. Empty directory can be a empty object can be a directory. Put another one in here, file 2, and we can extend the host environment, in this case VS Code, to have custom editors for whatever the object is, depending on its types or components or whatever. And then we can do a custom dynamic file. We'll call it cool file, which has this cool file component, which here's the interface to do a slurp-based API for files, read file, really easy. And then it's going to do the file name and the Unix time. And so this container that we put up here, put a treefs object on it that converts this whole subtree into a virtual file system. And then we could do a lot of things, but we'll just make a fuse mount with that file system. And then there's a lot of things that we can do with this. And now when we go, we can start playing with this file system that we made, of course, as dynamic stuff. But you notice I did it in the same project because we could also navigate over to this layout hierarchy, and it's just kind of cool that you can see this layout as a file system. It doesn't do anything. This scrubber's in the way. Can I move that? Apples? Nope, can't click. It's okay, I know how to get back now. So did I do the thing? Okay. So I put a component on that name object that I made called field file. Again, another contrived thing, but it just goes up to the event handler that has all the submitted data and returns that, so that ultimately we can set the data and then get the name. There's a name line there. You can see. Let's see if we can get that scrubber to go away. This was supposed to save time. All right, last 3D scene. It looks like Unity. Hey, because it's basically the same thing. A lot of design tools are basically a hierarchy and an inspector with custom editor views, and we basically have that in VS Code now, but it could be for anything. So the idea is to make a kind of a Unity for all software, and then you have something that feels like a design tool, especially for software system integrators like me. And this is how I intend to throw together software very quickly. Anyway, that is all I have time for. Also, thanks to my sponsors, GitHub sponsors, I'm starting to do consulting again and looking for collaborators to build stuff with this, tools, environments, experiments, whatever. But let me know what you think of this. I have no idea what anybody would think of this if they saw it, so come tell me. That's it.
Thank you, Jeff. Next up, we have Peter Saxton with EYG. After this session, there'll be a brief break so everybody can say hello to their friends in the hall. And then I think we're all hopefully going over together to a beer hall not too far away, about a 10-minute walk away, so we can carry on the conversation increasingly loudly and incoherently as the evening progresses. More on that later. Peter. Well, I'll stand here and entertain the audience while you see if your Linux machine will export HDMI today. So far, so good. Actually, honestly, I think of the presenters, the people on Macs have had more difficulty with their HDMI output than the Linux presenters. So let's see how you do.
There are 3 hard problems with your size.
There you go. Ever since I got a Steam Deck, I've believed in Linux on the desktop. Leave it to Valve to solve that problem. All right, here you go.
Cool. All right, thank you. So, right. So I'm going to live code my way all the way through this. So this is EYG, a language, an editor, and a couple of other things that I've built. But in 7 minutes, I really just kind of want to talk to you about the editor and then effects, which are slightly related to how the editor is useful. So this is a structured editor, and we have single key presses for stuff like, so if I want an assignment, I press E and I go so X, and we're like, okay, this is the code. A number would have 10, and then if we want to use it, we press V. It knows all the variables in scope. So here's a function that produces 10. Okay, and we get the value all the time. We can do things like we have some built-ins, so we have int add. Call this with number 1. Okay, got a selection of functions. So the built-ins are the lowest level primitives, but we can also reference libraries. So this is another thing I might slightly skip over. So if we have a standard library, we insert a hash value, so it should be this one. And then it's okay, that should load up. And actually, if we press enter here, so it is a shell, although it's live updating all the way you go through. We can now see, if we use standard lib, that we have information about what type a standard library has. So press G to get all the fields on it. There's a string. Yeah, let's get another one. Upper, show that this is all doing what we want. Hello. Cool, and move on. All right, so this is kind of your functional language. There's nothing necessarily exciting in the core language. Where it gets more interesting is effects. So effects are how you talk to the outside world. And this is a web environment. So we have a variety of effects which are kind of unique to the web, including these like OAuth integrations. So in this space, there's an OAuth app set up with these services, so you can do things like list your domains from DNS Simple. But we're going to start with some simpler ones. So if we start with prompt. Okay, so we prompt and we say, what's your name? And so now we're not getting the live updates all the time. So as soon as there's an effect, you don't get the live value all the time because this effect might be launch the missiles or other terrible things. So we have to explicitly run this. We run this and I say I'm Peter. And we go, okay, it's Peter. So we can keep editing before we commit this. So let's make this the name. Actually, we'll skip around. We'll run this, say Peter again, and we'll run through. So now the name is in scope, okay? So one of the things that's important for running this in a shell is that types are, they're shrunk as we move forward. So you'll notice, or maybe, well, I'm going to tell you in case you haven't. But yeah, the type of name is now just OK or string. There's no error case, even though if you were to run the prompt, this is something that can return a string OK or an error, but the name has already been resolved. Okay, so let's get the name. So, okay, we've got effects, stuff out, stuff in. So EYG is meant to be kind of useful. I have this, these predictable and useful. So the effects make it predictable, and the hashes, same program, same result. Useful is this idea of extending where you can run it. So one of the built-ins we have is we have this built-in called capture. So if we call this with the variable name, we start getting the AST of like the source program. So even though this was a runtime value and it came from the outside, we can turn it back into valid source code. We can capture functions as well. So we're going to call this one client. We'll have a function which takes nothing. It returns the name. And then we go down here and we say, okay, let's, obviously we need to delete that. Delete variable client. Okay, so this AST is not very, it's not very readable, so let's turn it into something slightly more useful. Let's change this to JavaScript, because once we have some source code, we can do stuff with it. So now we have some JavaScript code, which is making a program where parts of the program only came from runtime. So stuff in the environment that's not needed, like standard library, is not included. We need to shrink this name down to something useful. So if we include the name here, I said that this is only ever going to have a value because we're already okay. So if we go text, v, text. Okay, so we now have simple program. So we're going to keep rolling with this client program. So what happens if, in this client program, we want to perform an alert effect? Okay. So now this JavaScript is kind of it's a type-directed transformation of effects into JavaScript land. So the thing that you'll recognize down here is we have this, what is the program, like what makes sense. So this, we can change this variable to make something else. So we're going to ignore this, ignore, but we try to keep track of this down at the bottom. So the program is vaguely recognizable. And if we go through this and we go, so, oops, down equals code. So if we say script, so, how long we got? A minute, we can do this. So, standard library, get string, get concat. Okay, call this with a list. We want 3 things in here. This one is going to be script. This one's going to be the code. This one's going to be close the script. Okay. Keep going down. So now we have an effect, uniquely available in the browser, which is download. So this, we need to give it a name. So let's make it, what do we add? So like live.html. Make the content, take the variable, which is the script. This should be an error. So I think we should need to do this one. String to binary. Okay. Right, here we go. We've got live HTML. Click on this one. We've got my name over here. So yeah, so this is the kind of key idea of extending one program over multiple places. The whole language is built to make an efficient runtime to do closure serialization, which is what you need behind this. This is eyg.run, but I don't think I've connected the conference Wi-Fi, so that won't show you anything. But yeah, eyg.run if you want to find out more or talk to me, and thank you.
Thank you, Peter. I think those effects, the explicit effects tracking is something really interesting. I'm quite enthused about that. Next up, we have Gilad Braca, who Jonathan Edwards wonderfully queued up with this idea of applications as documents and documents as applications with his talk about docu-apps. That is, you're going to need the other side, I think. Other side. There you go. Why would you know? Apple moves it every year or two just to keep us on our toes. Actually, they also routinely remove the HDMI port, and then I guess they get enough nasty letters to bring it back. Yeah, it's just stick it on the, yeah, along with the Magic Mouse charge port. Yeah, so hold Option and drag the one onto the other. Yeah. And yes, the Option drag for arranged displays. Take that with you. That's our take home for tonight. So intuitive, yes. Apple, masters of the user interface. All right, Gilad, here you go.
Okay. Right. So, DocuApps, Ampleforth documents as applications. What could that possibly mean? Basically, Ampleforth is a live document editor that's built upon and integrates the Newspeak live programming environment, Newspeak being a programming language in the Smalltalk tradition, but it's an object capability language and has other differences. And if you really want to know about Ampleforth, 2 years ago I gave a talk in this workshop, and you can find it on YouTube. If you go to newspeaklanguage.org, you will somewhere find the actual submission to that workshop, which is a live document, an essay that explains why Ampleforth might be interesting. So what is this talk about? This talk is about, at least I think, the reviewers thought differently, but I thought this talk was about validating some of the things that I had claimed in that paper. So I had basically argued that Ampleforth would be a general purpose application building and hosting environment, and that you should be able to build applications that are fairly powerful, such as presentation tools like PowerPoint or computational notebooks or spreadsheets and whatever. And I had this odd idea that maybe I should put my money where my mouth is and actually do that. And so actually we can make this a little bigger. This presentation is in fact an Ampleforth document. Now, it's in an app called Telescreen, which itself is also an Ampleforth document. And so historically, 2 years ago, I built the first version of Telescreen for my own dark reasons, and that was a regular Newspeak application, and it stored presentations in its own, in a format designed for that application. And the only thing it had to do with documents was that each individual slide was a document in an earlier version of Ampleforth. But that was obviously unsatisfactory, and so now I've done it the right way. And so this presentation is a document, and each of the slides is a transcluded document within that presentation. And furthermore, the app itself, if you want to think of that, is also a document. And what does that actually mean? It's really quite simple. You know, you usually do these things out of templates. So there's a template, basically, there's a document that is a Telescreen presentation with one empty slide. And because Telescreen and Ampleforth do not have a mode distinction between editing and presenting, all these controls here, like moving between slides or adding slides in particular, or showing the slide list and so forth, are in every presentation. So you can edit it while you're going, right? We can do things like this, whatever. Shouldn't be doing improvised things in a 7-minute presentation. Basically, so what you do, you take that template, you clone it, and then you start adding slides and editing the individual slides, and you have this slide presenter. And so that, in a sense, this presentation is an existence proof of the point it is trying to make. And I think that's kind of nice, but as I said, some of the reviewers were not impressed with that. But they, at least one of them was impressed by something else that was kind of a minor point in the submission, and actually accused me of burying the lead by emphasizing something else. So what is the lead? Apparently, I did not know this, but this presentation is actually about the fact that transclusion eliminates silos. And what does that mean? So here we have, as I said, this is a document with a presentation. This slide is a transcluded document. And in this slide is transcluded this essay, which is the actual submission I presented to, handed into the workshop. And in this essay is a slide from another Telescreen application. And in this slide is a Telescreen presentation where we can actually keep presentations. Now, usually I honestly have not before had to have a presentation within my presentations, but I think that you should do that. That should be possible. And thanks, Jeffrey, I got that. Well, that should be okay. There is also the quick case of the computational notebooks. So this collapsed thing will open up. And this is a blog post of mine about Ozymandias, which is the most rudimentary computational notebook in existence. That is its claim to fame. But it is an experiment that shows that. And if we go here and we start editing these things, then you can see, if you look at those numbers, right, they change as I type this, right? So, and an aside in my 2 minutes, right? This is the same distinction someone talked about earlier. You can have these things either evaluate absolutely live or you can do that, whatever. So that's Aussie. And down here is the section somewhere about the other interesting point, which is one thing I had to change about Ampleforth as I built these things. I realized that you really need a standard, self-contained, extensible, persistent representation for your documents. And so that is one small lesson learned from this. And yeah, I believe I've said all these things, but here this is to hammer them into your consciousness. I believe that all these things are true. And I think I've done this in less than 7 minutes, which I didn't believe I could pull it off. But thank you.
I think, Gilad, that was incredibly high density. Yes, amazing. So, Jonathan, what you suggested, apparently Gilad has done, so I guess the rest of us can head home and go start playing with Ampleforth. Next up, we have Taylor talking about scrap sheets. If you don't know Taylor, he's the mayor of Taylortown. And yeah, I'm just going to give the stage to him, so welcome, Taylor.
Where's the firewire? Thank you.
There you go.
I recently discovered I was written in Ampleforth. We good? Mirror display.
Option drive.
Oh, okay, I know what's happening. I want to mirror. Uses main display. Mirror. Ho, ho, ho. All right. All right. I have 7 seconds? 6 seconds? Hello, friends. I am here to talk about scrap sheets. Let's talk about the elephant in the room. Spreadsheets, they are cool. We think they are cool. There's only so many ways to regularly and periodically tile a plane. Rectangles is a good way to tile a plane. Therefore, we end up always converging back to something spreadsheet-like, right? Like there's mathematical, yeah, the carcinization, yeah, the crabs, dude, it's the crabs in the spreadsheet. Lots of other nice features. We'll save those for later. Not cool. Spreadsheets are also not cool. At least the current implementations. There's a lot to be desired. I have been thinking about this a lot, and so I am here to grow the graveyard of better spreadsheets. The first version, which the reviewers very much did not like. Pretty much the main idea that I wanted to experiment with is that spreadsheets, you only have one cell to work with at a time, and I really wanted to work with lots of cells at a time. I wanted to work with the regions and make regions that produce other regions and stuff like this. So this was the kind of original thing. But working with regions, you need space to work with. So I made this thing called a buffer, and you can write arbitrary code in the bottom and manipulate your buffer and paste it back in. One thing you'll find, though, is you don't want to work in the buffer. You want rules to be applied in liveness. You want some liveness there. And so you can add code on the side that automatically applies to the main spreadsheet. One other thing is you want data from the outside. So if you look at the top, there's a little counter going on. That's just a counter from the outside, but you can use HTTP, whatever, get it in there. Also added search in here. Search is a nice thing. You don't always want a rectangular shape. Your data is not always rectangular. You sometimes want to search for things, and so you can both search for things, and you can make rules that target those searched things. And this is an example where I take Pluto, and if it finds Pluto, it erases it because Pluto is not a planet. And because you can write to the region itself, you can get something that, look at the citizen cane right here. Look at this Conway's Game of Life. You write to the cell below it, and it looks like it moves over time. Anyway, what I made is not cool. I'm glad I did it, but there were a lot of things that just did not feel nice. I tried making some like real spreadsheet type stuff, and it broke a lot, you know, like not great. So we're to 2.0, back to the drawing board. This is kind of my rough idea for the next thing. I liked the rules idea, but the rules, I wanted to co-locate it with the data. And because when you really use spreadsheets, you're thinking about, okay, I have this little section over here and it interacts with this. And so I kind of started with this next model, and it had a lot of nice properties, so I was pretty stoked. I will say to Ivan Rees that algebra is not an illusion. It's useful. Along the way, I started modeling some of this nasty async stuff with this little algebra that I created called reactive relational algebra, because this new Scrapsheets 2.0 was nice, but the async stuff was really driving me wild. It was becoming unwieldy, and so I reactive relational algebra. This stuff is nice for modeling sets and tables and stuff over time. You can also do some nice little proofs. It's like, okay, if your operation commutes, then you can have like CRDTs or operational transforms in Scrapsheets 2.0. So nice little features of this. You can reference tables themselves, and I'll show you why that's nice in a second. You can use any relational algebra, but relational algebra is not fun. So I ported a lot of this into a nicer DSL on my programming language, ScrapScript. So this is what ScrapScript looks like. Anyway. I have a Elm implementation in the browser up on GitHub, and let's get to the demo of 2.0. So what we have here is we have these little table views, and you can add rows. The code side of things creates the data, and the data is also manipulable. Should I make it bigger? You can manipulate it here. One thing that, oh no, I want this here. If you look at the code here, these are all like basic SQL type things. People really like SQL and thinking about sets in that way. So yeah, you could do whatever SQL can. And here you have memory. If you union one of these sheets with itself, you can show what happened in the last time step, right? So you can do some weird, cool stuff like that. This is grabbing a random number from the internet every 2 seconds or 1 second, and you can subscribe to this, and this will update in real time. And you can do some even cooler stuff with spreadsheets. Because you're operating on lots of groups of things, you can do something like this. This is Conway's Game of Life implemented in a spreadsheet program. And this over here is just some different reductions on this, counting how many exist in certain columns and stuff. So this is what I have right now. What are the next steps? Lots of fun stuff with undo and redo. With the relational algebra I have going on, there's a lot of provably nice things that you can do with undo and redo. There's a distinction between the code and the data. A lot of this is code-based and generating the little tables and stuff. There's a lot of remaining work to do on getting the data manipulations down into the code. LLMs, lots of fun stuff. Anyway, thank you guys.
Excellent. Rest in peace, Scrap Sheets 1.0. Alas, we hardly knew you. Our last talk of the day. Our last talk of the day. How many talks have we had today? Does anyone remember how many we scheduled? Was it 16 talks? Our 16th talk of the day. The ultimate talk of the day in a technical and literal sense. I don't mean any compliments in that. We'll save the applause for after. But Orion Reed, thank you for coming out. He's going to talk about scoped propagators. And here you go. Hold on. Yes, you need to hold Option. This is the meme of the event. Docu-apps and holding Option. Those are your two takeaways. And the word substrate, I guess. No, you had it. You hold Option. You got to drag the one. Yeah, no, go in there. Yeah, go into Arrange. Yeah, hold down Option. You drag the one on the other. Yeah, there you go. It did work. Today we all learned. Okay, Orion, here you go. Yeah, you're in business.
Okay. I'm going to talk about this little programming model called scoped propagators that came out of a kind of accidental need for it. A little note, if I just add an asterisk to this. This is not the perfect name. It's kind of reappropriating multiple terms. This is not propagator networks, and it's also not really talking about scopes, so sorry about that. Quick bit of intro context. So like what this came out of is I was doing lots of different kinds of experimentation, and let's say, for example, you're messing around with like some composable UI stuff, right? So I have this environment where I can take a shape and snap it to a line, and now I have a slider. But it's like you want to show people that that's a real slider. So I'd often find myself doing stuff like this, making some little tool that could take a value out of this slider and do something with it, right? Put it somewhere else. And I realized after this came up a few times that there was a way to generalize this. And what that looks like is really two things. One is that we propagate values along edges. So like typically in node and wire stuff, you do this in nodes. Here we're having like single input, single output functions. So for example, we can take the rotation, we can take the width and turn it into a rotation. We can say, hello. We can propagate this through, add some stuff to the end of a string. Or if we change the color of this, we're gonna kind of copy that color in one case and show it in text in the other. So the second half of this idea is that we scope the events that trigger this propagation. So the default here is that we have some on-change event. But we can also say that, well, when you click the target node, we're going to add an exclamation mark. Or we can come up with other events like a tick. So now every frame, we're going to get the current time, and we're going to chuck it there. So what this looks like syntactically is we have this little propagation in the middle. You have a from and a to node. I only picked those terms because they're like the least number of characters, and you're going to have to type them a lot. So we define this event scope, and then what we're doing is we're defining a partial state update on the target node. So text, W and H are properties that exist on this shape down here. And we have access to the from and to nodes, and we can kind of do stuff with that. So actually, if we let's copy these out and replace this with an arrow. So if we do that, now we've made some kind of weird, pretty useless propagator there. All right. Couple of little caveats. This is not actually advocating node and wire programming. The hope is that it's kind of more embeddable in existing contexts, because like if you're on a web page, there's already like a bunch of rectangles there, right? It's hard to chuck extra geometry into existing user interfaces. These are not real propagator networks, sorry again. And it's also not really a general purpose programming model. It's really meant to be kind of monkey patching, glue, whatever you want to call it. So let's run through some examples. Let me also start a timer. Okay. So, I know. I'll come in under time. It'll be all right. So yeah, we can do simple stuff, right? You can turn a regular rectangle into a button. It doesn't know that it's a button, but now it's a toggle. Or we can have a counter thing, or we can make these layout constraints. They're not really constraints because they're only one direction. So we have all of this behavior here is just defined on these edges. We can also do things like, geometric intersection, right? We can have values that propagate based on some kind of intersection and do weird fun stuff with that. With tick events, that gives you the ability to have smooth follow behavior, things like that. We can also, I'll get to this at the end, we can extend this with side effects if we want to. So in this case, we're making like a little rectangle tool paintbrush thing. It's also a very handy tool to just inspect things. So, we can see the data down here because we're just stringifying some JSON. Or we can do something silly like make this shape follow you around when it's blue. And yeah, we can start to kind of link these things together. So here we have a toggle, which is going to drive some system doing some weird math stuff that just kind of looks fun. Yeah, or we can do sharks. So down here we have this joystick, which is really just a rectangle, and we're just constraining some shape to it, and we're also pulling out the relative distance from the center of this rectangle. And then we have this fish and a shark with some follow behavior and a scoreboard and so on. And so if we hit toggle, it's a very easy game to win. It's actually lerping towards the fish, which means like if you're going at constant speed, it will just never catch you. But if you intentionally lose, we're now going to become a dead fish. It's the computer. It's not my fault. All right, yeah. So we have some asterisks. Oh yeah, I'm gonna be way under time. All right. So yeah, we can, if we want to, extend this with side effects. So I have this extra syntax of just adding some brackets. So if you wanted to go and send an email, do something out in the world, you could do that and then wait for it and get a value back. Another note is that you don't have to make this inversion of only doing compute on edges. So if I flip here, so here's a different context, right, where like we have these inputs being labeled A and B. We have in this case some LLM call that's using them. So you have some compute happening on a node, but then we're also using the edges to pull data out of that. So if I hit prompt, then we're going to see like this is going to pull the text out of that. This one's going to make it wider and show some useless information. So you can really like mix these two models together. A thing that I can't do yet, but I would like to, is that maybe we could start using this as a kind of way to glue actual apps together. So I have this little thing set up so I can doodle on my desktop, and I can also draw stuff onto Windows. And so if we chuck that in there, this is not using propagators, but let me just kind of give you an idea. We could do something like this, where we have some data coming in, and it will fail to paste. No one saw that. This is what live demos are for. Maybe it's the monitor. That should be pasting in a command. Usually that works. But you can kind of imagine a future where this already taken real estate of having a bunch of rectangles can be augmented with annotations like arrows, also sound. Yeah, there's some open questions with this. One is bidirectionality. I don't know that this model will ever really be a good fit for that. I'd love to be wrong. Another is, whether this can work in a multiplayer environment. How do you spread out execution over multiple clients, things like that? And something I would love to do is generalize this to directed hyperedges. So one of the limits right now is that it's a single input, single output system. That doesn't have to be the case. There's nothing inherent to this model that makes it that way, other than I don't currently have a good way to actually interact with directed hyperedges. If anyone has ways of having good UX for that, come talk to me. Yeah, a little bit of future work. I want to try this out in a graph database context. It's kind of a natural fit there, right? You can imagine edges that take one value that's updated and propagate it to something else, doing whatever kind of transformation you want. I would like to try and do this as a kind of web page annotation layer. I think part of the thesis of this is that arrows make quite a good kind of annotation layer, like way to augment existing interfaces, because you don't have to deal with this problem of like finding space for extra UI, extra rectangles in there. That's actually it. I came in way under time. Here's some affiliations. That's the whole thing. There you go.
Thank you very much. And if we can have our speakers come back on up, we'll do a little questions and answers. And I'm going to exercise moderator privilege as people get back up here, because I heard 3 separate people say the same thing in different words in their talks. I believe, Taylor, you referred to it as something about asynchronous multiplayer. You called it, what did you call it? I don't know. You called it something else as well, or real-time collaboration environments. I think Gilad was saying it maybe out in the hall instead of in his session. Jeff and Peter did not speak to multiplayer problems, but I imagine you have them. What is the problem, maybe, for people who haven't tried to build one of these with having multiple people collaborating in a live programming system? Would anyone like to start by answering that? And then what do you think we could do? So I'll pass it around. Don't all jump on this at once.
Okay, I'll bite. The problem, there are lots of problems. Basically, it's distributed programming. It's people conflicting with each other, stepping on each other. How fast does this work over the internet? I think there's lots of problems, but I actually think other people have solved it for me, so I'm not too worried.
Ryan, what's your problem? Sorry, with scoped propagators and multi-user.
Right. I think it's kind of the same thing. It is a distributed systems problem.
Can you be more specific?
Yeah. Let's see. I mean, I don't know what entirely all the problems are, other than the fact that I've tried a few times to make a good multiplayer execution engine, and it's really hard to do. It's very hard to resolve any kind of random computation. If everything is like idempotent and deterministic, your options become a lot easier and more straightforward. But if you have randomness, you have to make some kind of choice. Maybe that's electing particular clients or having some way of choosing a winner for whoever executed it first. I don't know.
A way of resolving a conflict?
Yeah. I feel like you might know something about that.
I don't have opinions, honestly. Taylor, if you want to speak. Why is multiplayer hard for you?
It's not.
It's not? Okay, so you're just not going to do it, or?
I just haven't done it yet, but
What are you worried about? You said it was in your list of like scary things.
Oh, like with the once I started like thinking through it, like a little sheet, right? You can that thing can be shared by multiple people, and as long as the derived state is the same for everybody involved, then everyone should eventually get the same derived state. Right? So.
Several ifs there, yes.
Yeah, I mean, there's lots of reasons why doing the multiplayer thing is hard. I mean, the AST, so I've had a bit of a look at this. Like, my minimal AST, I've not represented as a like CRDT or something like this. So, but I think it's actually a thing we also like doing, which we don't always need to. So in EYG, I didn't show like the package management is copy paste, because everything gets a hash, and you can kind of, if I've ever seen it before and you ever give me the hash, I go, it's the same one. And I actually think there's quite a lot of use cases where people could get really quick at just going, well, if we're working together, I'll copy paste it to your computer, and we don't need 2 cursors, because it's a whole other thing, and it's nice, but it's not a deal breaker, I think. So I'm not going to go that far down it.
I feel like there's approaches for some of the technical stuff, but most of the problems that I would think about with multiplayer manifold or systems built on top of it are more like the ones that you're working out on, like user experience and how to deal with that kind of stuff, especially because I would probably implement it in the way a game server does, where it's like you run the computation in one place, just to simplify it. But I've also tried putting nodes into CRDDs, and that's pretty interesting too. But it's stuff to explore.
Okay, do we have some questions from the audience? Jeffrey.
Great talks, everyone. I have a question for at least, I think, a few of you, maybe all of you. Some of you seem to be trying to build live programming systems that are actually useful for something.
Shots fired.
Peter,
Take it back.
Peter said the word useful, and I think I got undertones of usefulness from like Gilad's work and Jeff's work. Of the goal is actually, and I think this goes back to like to Jonathan's keynote and the talk about the sweet spot. Like, what are these systems actually for? What are we trying to do in them? I'm curious if you have any reflections on trying to pick good goals for what you want to achieve in your system. Like, how have you decided what your systems are used for? And have you had any challenges actually achieving usefulness?
I think I'm going to put this on Peter because he actually said useful in his talk.
All right, yeah. So I think, yeah, I mean, I intend to use this, and one of the I mean, there's a couple of contexts going back through the day. So there was like, what are the battlegrounds that we want to go for? And I think there are places where programming's worse than other places. So I've been looking at stuff which is like industrial machinery is particularly problematic as a space. And I don't like the programming models we've had in the past because, the kind of file system and a bunch of these other abstractions about Unix don't apply to industrial machinery. So the effects, they came from, I need to, like, this machine only has like a heating element. That's the only thing you have available. There's no terminal, there's no logs, there's no nothing. So I found that like it kind of fell out from that drive of needing to be useful, and then it shows up in other places. And one of the other things kind of, which is like related to the day, is, it's called live, but is live the goal? Do we want to get more people programming? End user programming is a different goal to live. And so like, actually I think like, are we going to developers or do we want more people to be developers and stuff like this? So the usefulness of like EYJ is it runs forever. There's no update option. If you get that hash, no one can tell you that there's a later version, so it runs forever. The effects are kind of discoverable ahead of time, so the security model's different. And live is really important because that's how you teach people through it. It's like a good UI, like discoverable buttons. But live is slightly subservient to a few other things I think we do wrong in software, which is churn. Like, I think churn is what really kills people using software. People who don't regularly use it, if you say, oh no, it's 6 months, you need to upgrade it, they're like, why? And I think actually addressing those problems are all very useful for end user programming as well. That was a few things at the same time.
On usefulness, what I wanted very badly was a spreadsheet program where I would open it up and it would give me the live SQL query just in a table next to all the stuff and maybe some live internet data. And it is bananas that doesn't exist. It's just absolutely bananas that I can't just open up Google Docs and it's like the live state of the world that it's synced to a CSV. So that was in terms of usefulness, like a one use case that I really wanted and it didn't exist, so I tried to make it.
I think I just really wanted like these tiny little augmentations to stuff I was working on. So often I'd be writing some more complex system and I wanted to just try something out, but I didn't want to have to go and leave the editor experience and go through that full development cycle. I really just wanted to stay there and be like, oh, what if I just connect this one value over here to this other thing over there? And that just let me kind of make this very crude glue that was really handy for just like these like micro augmentations. Yeah.
So on usefulness, I started out many years ago deluding myself that I might make something useful for other people, but other people have not taken a real interest in that, and so I've limited the scope to useful to me, and it's really a question of control over bits of software that I personally use, because even though Microsoft has probably spent north of $1 billion on PowerPoint, it does a million things I don't want and doesn't do a few things that I do. and so I prefer to have software I can control.
Good answer. Jeff, here.
The way I do most software is well, because I build a lot of stuff in my head. I imagine all I could build.
Stand a little closer to where I was getting this.
So there's like it feels like there's thousands of things that I want to make, and I build a lot of them in my head, and I'm sort of like, what are the common patterns? And then it's like, oh, a really hard thing, and it applies all these things that I built in my head. You know, I'm like, it's all that and that. And so I sort of like collapse all of these uses into a primitive, and that's usually how I make software. But I end up making more primitives than useful software, so we'll see.
All right, other questions? Will there, yeah.
So a consistent theme here was about handling effects and state. This made me reflect on, for instance, the most insane model I've ever seen, which is Unreal Blueprints, where you have what looks like a pure computation graph, and then you have an additional kind of edge, which is a control edge. And anyone I've ever talked to never understands that. It's a completely illegible form of effects that is nominally end-user programming. And I was reflecting on, I would be curious to hear each of your philosophy on how do you think about, in sort of a sentence or two, like the core of how you want people to think about state and effects in your system, and kind of extending that philosophy into the future. Is the goal like sweeping these things under the rug, forcing everyone to program in a pure functional way, visualizing state? Like, what is your core philosophy on dealing with state and effects?
Who would like to go first? Should we start with Jeff, because you went last?
I am not a functional purist. I like doing things the way people are already doing them, which right now is dealing with, just not trying to create stateless code. But maybe I don't have much to say about this, actually. Yeah, I don't care.
My kind of throwaway comment is I think the shell is a better abstraction for end-user programming than a spreadsheet. I just don't think we've ever given end users a good one. Because actually, I tried with code notebooks, and you have a kind of, if you edit in the past, what goes on. And just a really explicit of like, I'm doing this. Like end users with the, fire the missiles, update the thing, deploy the thing. If it's really implicit stuff, they're fine with that abstraction. And then, you can have data in that terminal where you go, oh, it's pretty now. So I'll put a massive table here because it's table data. But yeah, that's kind of how I separate it. Like actually, shell for stuff with side effects, and you go through it, and you just, this is what I've done, and then everything else doesn't have that, and you have to call it into that thing to get it done.
For me, the mental model that I think is within your table or sheet, you're thinking about a small little zone. That should be a nice little tidy world that is self-contained and correct. And then the linkages between, that's a lot more messy. That's where you want to get your async and your side effects. So that's part of the impetus for reactive relational algebra, right? Like you have some model of everything is async, and therefore it all kind of works, and you can reason about it with cool tools.
I think in my system, the way I thought about state is that I want you to be able to reason locally about the system. So if you see some shapes and some arrows between them, I want that to be kind of sufficient. Another aspect of it is that I tried to make it so that the legibility of state was encouraged. So almost all state there was represented in something visually, to the extent that in most of the examples, you should be able to recreate the full program from a screenshot if you wanted to. I had to add like escape hatches of having hidden values, and obviously at a certain kind of scale that doesn't become practical. Yeah, when it comes to side effects though, at least in my system, it's kind of just like, launch the thing and cross your fingers and just kind of see what happens. It's not handled very explicitly, partly just because it's under the hood just plain JavaScript.
So this may be a cop-out, but I'm a small talker at heart, and objects are a way of scoping state to some effect. Effects happen in the real world no matter how much we try to, at least we perceive them no matter how much we try and deny that. And so object capabilities are the thing that I'm trying to leverage so that, you know, there's a limit to what anyone can do. And when you can keep it functional, that's great. But occasionally, something actually has to be, to use a word we discussed earlier, useful.
All right, great answers all around. Any more questions? How are we doing for time? We got time for a couple more questions if anybody has any. Lou.
Hi, thank you. They were really great talks. One thing that sort of struck me, I think during Jeff's talk, was like the focus on environment. Like it's I really saw with all of these projects, a big part of it seems to be like making a better environment to work in, or in environment's case, kind of like augmenting your existing environment. And I'm just curious to hear like how much that's important to you, like that you're in an environment where you can think and work in a better way, or if that's not really a concern at all. I'm just curious to hear your thoughts.
Manifold actually isn't even necessarily supposed to be live. Like you could use it without live hot reloading and stuff. Because you could use it to, yeah, I know. I don't always care that it's an environment, but it's sort of like maybe it's that like purist. It's like, well, if I make the environment with the thing, or it's just like if you can do everything with it, then that somehow proves that it's a good abstraction or something. So I don't know. That seems like part of my motivation.
I think it's quite important from what I'm doing, although and I've built an editor in a shell, so I've not changed on like the paradigm, but I hope that I've made them a lot more pleasant. I don't even think I said that EYG stands for Eat Your Greens. That was the principle of the name. And the idea was, if we restrict a lot of things, like do a lot of like strict things up front, what benefits can we give you? So I actually, every single effect is explicit. There's no debug. But how much nicer can we make it? Like, I do want a nicer environment to work in. Like, the pains which we feel don't seem like fundamental, and how many of them can you get rid of? So yeah, kind of that's the question.
I think everything is in an environment. The question is whether or not you're going to be a compatibilist or not. My bent tends to be I don't want to play with the other kids' sandcastles. I'm going to kick it down and go build my own. And yeah, this guy knows ample fourth, yeah. And yeah, so compatibilists, nasty.
Yeah, I want new nice environments because they feel cozy and enjoyable as a programmer, but I think they're like a bad idea. I think back in the 80s, it was a lot more viable to like build a whole new universe and convince the entire world to come with you. I just don't think that's so much the case anymore. So I'm personally most interested in how we can take existing systems and kind of make their walls less opaque. I quite like Stephen Kell's notion of an integration domain for this, of like what exists between environments and systems that can act as kind of glue and like linking languages and ways to integrate components and systems that already exist. And maybe that would be called like an environment. I don't know. Yeah.
So the short answer is yes, the environment is everything. That's what it's all about, is to shield me and from the nasty world outside. And compatibilist is a beautiful word that I've learned here. But occasionally I do have these spasms of usefulness, and there is a need to interact with the vile world outside. And so the current environment is built on the web browser, not because I think that is a nice environment, but it is a useful environment. And my goal is to pave over it so the zombies never get out. Like, I do everything in Newspeak, and they're stuck there behind, but they're still there if I need to summon them.
All right, that's a great
Thank
note,
you.
I think, to finish on. Unless anybody has a burning question, if you do, you can grab someone in the hall or take it to the pub. Can we give all the speakers a round of applause? All right, so can I get Josh and Jeffrey up here? And you guys can return to whence you came. Yes, so that's it for Live 11 pretty much, or Live 10. Next year will be Live 11. I'm looking forward to seeing what Jeffrey and Joshua do with it from the second row instead of the first row, so good luck to you. And I'm sure they will probably try and recruit one of you so that the chain remains unbroken in future years. I just wanted to open things up a bit to the audience and ask for input from the audience. How was the format? Do you have things that you liked or that you'd want to see done differently next year? You know, I know the talks were very short. Hopefully that made it lively and not mentally numbing. But if anybody has any comments or things, of course you can email us or send us messages, but if anybody has things they'd like to suggest or feedback, please, now is a great moment. Anybody? Yes, Mr. Worth. Yes, remote speakers. And if either of you remote speakers are watching this on video or for some terrible reason still awake, we had some trouble hearing your presentations, and yeah, I think that's definitely a good note for next year to make sure we have quickly available pre-recorded fallbacks at least. Having watched myself given pre-recorded speech talks during COVID conferences, literally the most uncomfortable thing I've ever done is sitting there watching myself give a talk that I know I probably would have done better if I'd done it live. So sympathy to people who have that happen to them. But yeah, it would have been a great fallback here. Any other suggestions? How was the format? Did people like the discussion blocks at the end? Put your hand up if you would have rather, okay, let's do the poll. Put your hand up if you like the discussion blocks at the end. The alternative will be right after each talk. So block at the end. Okay, how about block after each talk? Okay, so a pretty strong preference for at the end, but not universal. So I think that's interesting.
Does anybody want to offer say if anybody who likes Q&A after each talk, is there something specific that drives that? Yeah?
Yeah, so several times throughout the presentations, I found myself wanting to ask a question about like something on a slide or an offhand remark or something like that, where having the context is important. And I could have written it down and brought it up at the end, but A, it feels a little bit rude to say, Orion, that bit where you throw me under the bus, wherever you are.
Yeah.
That sort of thing. It feels weird to like micro-focus on one person when it's the time we're asking shared questions. And the other one is like, you know, half the people in the room would forget what that thing even was.
So part of what we were trying to do was to avoid the more of a comment than a question style questions, and I think that was very successful. So we had a couple, yes. But I do think that's a good feedback, and I definitely had some questions for presenters as well, so maybe we can do short question blocks. Peter.
I liked it, but one of the things which I felt was strange was sometimes every question was quite often put to all 5, 6 people, and maybe it needs more from the moderator.
Tighter moderation, yeah. Yeah. Yeah, that's a good point. Will.
So for next year, Live is going to be in a far-flung locale, I imagine, for most Live attendees, and it's also going to be co-located with ICFP. So I'm curious if you thought about how to tackle either of those dynamics.
We have not. I will speak on behalf of the entire committee and say we have done literally no thinking about planning for or consideration of anything beyond about 20 minutes from now when we all go get beer. Yes, if you have, be careful, you might get nominated. I'm curious, put your hand up if you'd be likely to attend in Singapore, because that's where the next one is. Okay, yeah, not a huge number. I mean, I would love to go and eat in Singapore, but it's a long way from where I live. Yes? A design crit is an interesting idea. One thing that's challenging in particular is that we have a fair number of people who are not super experienced in academic conferences, and I thought it might not be the most positive first experience to come and present your like thing that you just made and then have a room of 40 esteemed peers and people you look up to absolutely shred you. So, you know, but I like the idea. I think generally though, like more structured feedback is good. And I know in a past year they had one person for each talk to speak to it. Josh?
I'm just curious to hear what else you have to say.
Oh, sorry.
Another thing I was thinking was like, I feel like bubbling under the surface of some of these things are like, what is live? Where do we want to go as a community? Things like that. And I think like we have time to talk about that over beer and stuff like that. But I'm wondering if there are ways to integrate those conversations more deeply into the main official part of the workshop in the future.
I think that's a great suggestion, and one way to do that would be to submit some talks about them. And honestly, like this is a little bit on the audience, right? Because like as the hosts, we don't give the talks, and we can only put on what you bring. And I think that those conversations are worthwhile. And you know, Josh gave a talk about sort of definitions of technical dimensions of liveness. But I think other talks that are not just about technical solutions or, hey, look at this thing I built. Like last year, Jonathan gave a talk about sort of schema change problems, which I thought was quite interesting. So I want to encourage everybody in the room that if you have opinions or suggestions or ideas about this, this is good. I also think it would be lovely, just speaking as someone who will be in the audience next year, to see perhaps some more survey papers. Like, yes, it's great that you made a thing, but I would love to see like let's see an analysis of like 10 live systems on these dimensions Josh proposed, or like the history of live programming, comparing and contrasting successes and failures. I don't know, whatever you got, I think it would be lovely to see more of that kind of thing.
Though I think to get specifically what you were after, it would have to be possible to submit. I think we should have this discussion for 15 minutes. Like a submission that's of the form, like it's not that I have a paper to present, it's that I have a discussion I want us to have. So
That's sort of an unconference. Submitting a panel, yeah, but
perhaps we should be explicit about that being an option.
yeah, so please consider submitting it next year.
In the working group on language design, sometimes someone will submit a talk that's really not them talking, it's them moderating a discussion. And that usually works pretty well.
And Rome had one as well, right?
Please do this next year. Any other questions or feedback? Please, yes? Well, I'd like to thank all the speakers one more time. Can we get a round of applause? Thank you all. Jeffrey, do you want to talk about post? Yeah.
Okay, so we have a plan for afterwards. It's pretty casual. The plan is we're going to take like a half-hour break to like reset and talk to other people in the hallway or whatever, and we're going to meet at 6 p.m. in the lobby to go over to, it's called Congregation. It's a brewery. I think it might be like a converted church or something. I don't know. It seems cool. Raise your hand if you're thinking of coming. Maybe is okay. Okay. Wow. Pretty much everyone. Okay. I may need to tell them we're going to be a few more people than we thought, but they're expecting us, so that's okay. Yeah, any questions about? I believe, so we're going to walk there. I believe it's about like a 15-minute walk from here. Yeah.
Does anybody prefer to share an Uber? If you do, perhaps meeting in the lobby at 6, and if people, for whatever reason, would rather take a car over, you can coordinate then, and that would be a good thing.
Half a mile, 15 minutes long.
Yeah, it's over to the west by kind of the downtown area. Yeah.
I haven't been outside yet today, is it?
Great, thank you.
Okay, yeah, so I mean, feel free to meet directly there, or meet in the lobby, whatever works. We'll probably be there by 6:15, 6:30, something like that. Yeah, any other logistical notes we should make?
I want to really specifically thank the people who submitted the first time. And if you're sitting in the audience and you have a system that you have been working on or thinking about submitting and you didn't get organized this year, get it in next year. We're still going to be here. And if you had a submission that didn't get accepted, you know, like it doesn't mean the work's not good. It just means it needed more work. And you got a whole year to do that. And if you submitted a system before and now it's out there and you're working on it, come back and tell us how it's going, right? Like this is not just a one and done thing. Like it's great to see the new shiny things, but I think experience reports and like field studies and like, let's see some more other kinds of stuff. I think that'd be great. There's lots of you in here, and with your help next year, our talks can all be even shorter. Okay. We'll leave it at that.